Good morning, everyone. I'll give you a few seconds to take a seat, and we'll start the session today. So I have a few announcements before we start. So first thing off, we need to take a selfie because, you know, it's the first time Antonio is chairing a session. We are two Italians, so we have to make the ITNOG group proud of us. So let's do that. One each. Good morning, everyone. So before we start, I have a few announcements. So first of all, please rate the talks. Let us know if you liked them, or especially if you didn't like them. As part of the program committee, it's important for us to understand the room, what you felt about what we chose as topics or as talks for the sessions. Then second is, again, part of the PC program committee, there are elections. And so far we have 2 candidates, but we would like to have more. So if you think you want to be where me and Antonio are standing, maybe at one of the next meetings, please send an email to be a candidate for the program committee. Then last is, when you go to the microphone, please state your name and affiliation before asking the question. That will help us also understand who you are, and maybe find you later if we need to answer a question better or continue the discussion. So having said this, we have, let's start with the first talk of the day from Zubair. Please come on stage. We're going to talk about hyperspecific prefixes, things that are seen on the internet that most likely should not be there. So give them a good applause, because he's brave being the first one on the stage. It's here.
Okay. Thank you very much, Max, and thanks for the applause. Good morning, ladies and gentlemen. I'm Khwaja Zubair Siddiqui. I'm a PhD candidate at Max Planck Institute for Informatics in Germany. And today I'm going to present one of our research work titled Hyperspecific Prefixes. Gotta enjoy the little things in interdomain routing. This work is done with a joint effort with my colleagues, Lars Brehan and Oliver Gesser, and is published in SecComp CCR journal. So, as we all know, usually autonomous systems use BGP to announce the routing information to each other, exchange the prefixes with each other, and BGP best practices recommend that prefixes that are more specific than /24 and IPv4, and also /48 and IPv6. For example, /25 to 32 in IPv4, and also /49 to 128 in IPv6. They should be filtered by network operators. However, plenty of these prefixes are visible and observed in the internet, or at least with the data set of route collectors that we could observe them. For this study, we call this range of prefixes as a hyperspecific prefixes. And we want to understand how prominent they are and why they are there. What could be the possible function or purpose that they are observed in the internet. Before our work, there were some blog posts about the topic. In 2014, colleagues from RIPE, Arbin and Petri, they wrote a blog post where they did some announcement of HSP with and without route object to measure how far they propagate in the internet. And they conclude their work that only 20% of route collector peers can observe these prefixes, so they do not propagate that far. A year later, they also did similar experiments, and they observed there's a marginal improvement. In 2017 again, Strauss and Petri conclude that at most 1/4 of route collector peers observe these prefixes in the internet. There was also a post by Jeff Houston about a similar topic where he investigated the more specific prefixes. And his conclusion was that there are possibly 3 cases for more specific prefixes. And he used the taxonomy of hole punching, where prefixes originated from different origin autonomous systems, or traffic engineering purposes, where the same origin advertises these prefixes, but through different autonomous system paths or AS paths, and also overlay networks. However, in that post, Geoff Hoston referred to more specific to any prefix that is covered by another one. For example, he refers /24 could be a more specific of a /23 if that /24 is included in the /23. So for our analysis, we use the data from well-known route collector projects like RIPRIS, RouteViews, and Isolario. And we did it for 1 decade, for more than 10 years, from 2010 to 2021. We collect a 7-day sample every quarter or every 3 months, and 1 rep per 24 hours, and also every 5-minute update to check. We have it in the paper why we choose this sample size, and then we filtered the outliers or the data that was abnormal, also the private and reserved IP prefix ranges from the data, and then we had a look at it. Additionally, we use supplemental data sets to give us more insight from CADA, Rapid7, and also ASDB. But the first question is, how prominent or how large are these HSPs that we are talking? How many of them do we observe? To answer this question, we try to check the hyperspecific prefixes existence or footprint in the routing ecosystem in the internet. In this plot, we show that here in the bottom, in gray color, the share of HSP. On the y-axis, we have the percentage out of all the routes that we see. And we group the prefixes from /8 to 15, 16 to 23, /24, and HSP. The left one shows it for the IPv4, the right one shows the data for IPv6. The x-axis shows the duration, the time frame that we collected the data. As you can see, while yes, the yellow one, the /24 is dominant, and also /48 is dominant in IPv6. However, in the interest of our study, we are interested in HSP, and you can see here sometime it reached to around 14% in IPv4 and more than 20% in IPv6. So what does it tell us? That yes, HSPs are there, and we can say that on average, HSPs make roughly 10% of the prefixes that exist in the routing ecosystem. Now that we know that there are HSPs, we try to understand how far they propagate and how long they stay in the internet. To answer this question, this was not possible to do it with a 7 days interval. So we collect for the entire year every update and every possible rep that we could collect. And we measure the HSP lifetime as well as the propagation. So here you can see that on the x-axis, we have the number of route collector peers. So the higher it goes, the higher visibility it has. On the y-axis, it's the number of route collector peers or feeders. On the x-axis, we have the time, how long they stay. And at the end would mean 1 year. Every cell contains like 2 weeks in duration, and on the y-axis, around 10 peer ASs. The left one shows the data for IPv4, and the right one shows the data for IPv6. What you can see here is that the longer the prefixes stay at HSPs, the higher the visibility. So you can see on the right side for this plot as well as for the IPv6. So there is a correlation between the duration an HSP stays in the internet and the visibility it gives. However, it's also to be noted that in the bottom, Here, the color is red, and if you look at the legend, it means there's high number of HSPs. So a large number of HSPs, they have a very low visibility. It's not that visible. I can say like largely they're visible by 40 or less route collector peers in this study. The next question we wanted to ask ourselves was, but what could be the possible functions, or what could be the possible usage of HSPs? To answer these questions, we think that certain CIDR sizes may hint a potential use case. For example, if an IP address is under DDoS attack, then that company may advertise that specific IP as with a black holing community, or as a /32 in IPv4, for example. However, it may not be the case where a large size of IP addresses to be advertised to address a particular under attack IP address. So hence, we try to associate the following. A /32 or a /128 in IPv6 will hint us that it's probably a black holing purposes. So this HSP is probably telling us that it was used for black holing. A /30 and 29 may hint us about possible infrastructure or peering subnets. And also a /56 and /64 in IPv6, we classify it as address block assignments. And /25 would possibly be used for traffic engineering. However, it's a limited observation, and I would love to hear from esteemed participants here how it is in your networks. So if you look at the data, for the left plot for the IPv4, the green color makes the highest fraction, which is the range of 31 and 32. So we argue that possibly the black holing is the most prominent HSPs in IPv4. And followed by the red color, which is peering subnets or the infrastructure and the routing infrastructure. On the right side, the case is different for IPv6. You can see that the orange color is the dominant one. And this is the range where from /49 up to /64. So the address block assignment to the customers or to the devices is the most common usage of HSP. However, as I said at the beginning, the CIDR size can hint us. And with this, we can say that yes, HSP has heterogeneous usage. Now, next we try to see, but what are the protocols running on top of these HSP prefixes, or the IP of these HSP prefixes? To understand or to do a deeper dive into this topic, we use the Rapid7's open data where they scan for top 100 protocols. And we try to measure the hit rate between, or the response rate between the HSP and the non-HSP or IPv4 wide IP addresses. For that, we picked the top 5 protocol, and it's interesting to know that 4 out of 5 protocols were similar in both cases, for IPv4 wide and also for BGP. In this plot, we can see that we show the hit rate, the difference of hit rate between HSP and IPv4. We notice that for SMTP, BGP, HTTPS, HTTP, and SSH, HSP has a higher hit rate than normal IPv4 wide. We also notice that this CWMP, which is a protocol used to configure the CP devices or customer devices, is commonly visible on the IPv4 wide, but it's not visible on the HSP prefixes. And also BGP was one of the top protocols in the HSP prefixes, but it was not one of the top 5 protocols in IPv4 wide. So we can conclude that HSP prefixes have a higher hit rate for these protocols, up to 5 times in some cases, than IPv4 wide. To do further analysis, we think that the community strings may also help us to understand what are the possible usage of hyperspecific prefixes. For this, we examined the BGP communities, and our question was, or the idea was, to check to what extent BGP communities contain specifically the black holing community, or if it has a route restriction, for example, no export, no advertise, communities like that. We're checking the data. We try to plot it, the median data in every bar here. And we have any community. So any community is some sort of string that's hard to derive or conclude a specific information. And if there was any type of black holing community, then we call it as any BH or any black holing community. You can see it in the plot that around 13% of the HSPs in IPv4 and around 7% of the HSPs in IPv6 have a black holing community. And the most well-known black community within these prefixes were 666. So we argue that at least limited to this number, this 13 and 7% of HSPs are a concrete example of black holing usage in the HSP prefixes. However, we do not observe so many of route restrictions for route restriction communities within the HSP prefixes. The next question that we wanted to ask is that are HSPs intended, or there are some accidental route leaks? So what is the use case? Now it was hard to address it particularly, but we try to look at different databases. And we think if the network operator takes time to add the HSP information into those databases, then it means they have an intention to use it possibly. For that, we look at the IRR database, RPKI, and the BGP is the data that we collected through route collectors. As you can see, the data for IRR and RPKI, we collected from the time that it was possible, so probably after 2015, 2017, it was possible. In this plot, the green color, the IRR, shows that there are roughly 2,000 unique origin autonomous systems that they entered the HSP information into the database, into the IRR database. However, for the routes that we observed in route collector, we do not observe so much footprint within the IRR, and the yellow color shows if an HSP was observed in more than one category. So if it was observed within the route collector, but it was also visible in the IRR or RPKI. This plot tells us that yes, there are operators that they intend to use HSP. They entered it in the IRR object, but there's also plenty of HSPs that they don't have any footprint. So it could be a route leak. It could be a misconfigured feeder or peer AS of a route collector that injects this information. To do further analysis, we tried to look at our BGPs are actually the cause of our HSPs are due to BGP prefix hijacks, because it could be that there is a more specific prefix and could win. To address this question, we look at the BGP and we look at the HSP data in the RPKI database. So in this plot, an HSP information is categorized in 4 categories. The first one, it's valid if the prefix length and the origin is correct. The second one, we call it invalid length, and it means the origin AS is correct, but the prefix or the length or the CIDR size is invalid. For example, the operator entered at /24, but we observe an HSP which has a /28. So the origin is valid, it comes from a valid origin, but the prefix length is invalid. The third case, invalid origin, well, this could be a hijack because the origin autonomous system is not valid. And the last case, the red one is invalid both, where neither the prefix nor the origin is valid within the RPKI database. As you can see, the gray color is the dominant one, and this tells us that large number of HSPs are actually originated from a valid origin. So the origin autonomous system is correct. However, the CIDR size is not correct. The green color tells us that both the origin and the CIDR size is correct. And you can see for IPv6, we have a large fraction, a percentage, nearly 20% maybe on average, they have both the valid length and also the valid origin AS. The yellow color, that is shown as invalid origin. It makes a tiny fraction of the data. And it could be a hijack, it's possible, but it's also possible that some sibling autonomous systems may have not entered the ROVA information into the RPKI database, or it could be that some companies, they use DDoS protection services, or DPS, to advertise their prefixes, and this could be also lead on such a situation to invalid origin. With this, we conclude this one that a legitimate autonomous system advertise around 75% of HSPs to the internet. Now, the question, now that we are here together in RIPE, the question is, what about future of HSPs? What do you think? So there's two aspects. One, we think the route collectors are heavily used, at least with the research community, and it's important to have a clean data there. To help the community, we also collect the HSP information, and we maintain a dashboard where we publish the HSP information, who originates it, from which feed, to make sure if there's a route leak or if there's unintended or misconfigured POAs, the operator could take action and fix it. And you can access the dashboard through this QR code as well as through that hyperspecifics.io URL. But that's a discussion for the research community. Here in operator community, when we discuss our results with operators, with 13 operators, 2 of them, they said, yes, it's a misconfigured BGP filter and they fixed it. Some of them, they also said, but yes, we announced it, but there's a customer request for it. For example, some small customers, they want to do traffic engineering, and that's why we announced it. I also heard yesterday that there is in the RIPE policy a discussion going on, especially for IPv4. Shall we increase the filter size from 24 to /25 or 26 or not? Which is an interesting discussion for me. We think that if the question is, shall we filter it or not? There's 2 parts. For IPv6, we think yes, we should filter it. And the reason is because IPv6 is cheap to obtain. And also if we do not filter it, it may create a large routing table in the internet for the routers. For IPv6, for IPv4, we think that probably in some cases, maybe shifting by few CIDR sizes /26 could be an agreeable compromise, but it's an open discussion. We can discuss it. We do not say particularly that we should do it, but I would love to listen and hear to your opinion on this regard. Now, my question is open. How do you handle HSP in your network, and how do you treat it? And what do you think? Is it okay to keep it, to use it, filter it, or not filter it? With this, I conclude my presentation. And in this presentation, just to have a short look, we analyzed the hyperspecific prefixes for 1 decade. And we use that most HSPs are visible by few route collector peers. However, hundreds of them, they are visible by hundreds of route collector peers. In IPv4, most of the HSPs, they are associated with infrastructure announcement or black holing. In IPv6, most of the HSPs related to address block reassignment. And we think that though hundreds of networks use HSPs, we attribute even more cases to be route leaks or misconfigured peer ASs, autonomous systems. With that, I'm done. And if you're interested to look at the HSP statistics, please scan the QR code or address check the hyperspecifics.io for the up-to-date information on this topic, and also for further details, our paper is available on that address. Thank you very much for your attention.
Thank you, Zubair. Do we have any questions for him? Oh, I see.
Okay, go ahead. Hi, Giovanni, CIDM Labs and TU Delft. I have a clarifying question. Can you go back to slide 7, please?
Let me take a while. Let me press it.
Oh, right. I'm just trying to understand what you were showing in the figure.
Yeah, there is
a question while you're clicking backwards.
Yes.
So hi, Warren Kumari, Google. So back in 2008, there was the Pakistan YouTube route hijack thing where Pakistan
Yes.
Yeah, people giggling in the back. Pakistan Telecom announced the YouTube routes. Anyway, I was on call at the time, and so I decided to announce 2/25s, not really thinking that would work, but around 80% of the traffic came back with those 2/25s. And then I figured, hey, why not? So I announced /29s as well, and another like 5 or 6% of traffic came back. This was surprising and slightly worrying. But what I was wondering is, did you look at all at the difference between sort of hyperlocal or hyperprefixes on peering interfaces versus what you would kind of call transit? Or isn't that really something you could see from?
So if I got you correctly.
So yeah, I announced /25s just towards what I would call peers, not transit type connections.
Mm-hmm.
And I don't know if there's a difference in how often you would see very specific prefixes just between peering type agreements.
So I assume the peering should not advertise it publicly. Because the peering information is a bit hard to derive as well from the public internet side. However, we try to look at it at the different network types, like what are the operators. And we find that the ISP transit is one of the, like comparing to the non-HSP, they are one of the dominant users.
Yeah. So yeah, I'd like to know, what are you showing actually on the y-axis there? You say IPv4 visibility, maximum number of ASs. What exactly is on the y-axis?
So it's the number of route collector peers.
Route collector peers, all right.
That we have, and we see that the same prefix was observed by maximum how many route collector peers.
Okay, no, I get it. Thanks.
Benedict?
Benedict Stockelband, random IPv6 guy, so I don't really know what I'm talking about here. But a customer of mine the other day had some strange problems relating to IPv4. And it looked like there were problems routing /23s, 22s in some places already, apparently due to routing table constraints and some old hardware. Do you have any idea if there's something going on in that area? Or did you just focus on /24 and longer?
For this study, the scope of the study was the /20 longer than /24 in a sense, but or more specific. I think it's a deep dive question to look where the problem is. It could be, I mean, there are different cases. It could be a filter, particular filter. It could be invalid announcement by RPKI. Oh, well, I mean, I cannot say it right now, but that was not the scope of this work.
Okay, thank you.
Rüdiger Volk, retired. Let me first make one short remark. I always cringe when people talk about ROAs with invalid length. 1232 would be an invalid length, definitely. And since you are academic, terminology counts. The correct terminology is non-matching length instead of invalid. I know the invalid length is circulating in the practical community, and I cringe nevertheless. For your question whether HSPs should be usually filtered, or well, okay, no, your question was, well, okay, should the length restrictions be relaxed? And your argument that, well, okay, V6 is cheap and you do not need, addresses are cheap, and you do not need to restrict there, and then, well, okay, you restrict the announcement lengths. But, well, okay, V4 is a different question. But, well, okay, kind of, you are then kind of suggesting that the cost pressure and the scarcity of the address in V4 space should be moved. Well, okay, that's cost, should be moved by relaxing the length to the FIP implementation in the routers. Something like now 20 years ago, within the IETF, we had activity because we were afraid that the cost of the FIP implementation, the line cards, would be going beyond what can be done and what kind of there is a cost trade-off. And I quite definitely say we should keep the old borders. If we open up that, we do not know how much cost we will actually force onto the hardware. And last,
Rüdiger, we're running out of time, yeah. So please.
Yeah, last remark for your analysis of black holing communities. Kind of all of the communities that actually have a part where an AS number is in. Kind of, I would suspect, or well, okay, quite clearly, if you have an AS number in the community is kind of negotiated and defined by that AS. And if that community spreads somewhere else, or is kind of telemarketed to some distance AS, well, okay, actually, I think that is essentially either a bad behavior or unintended and unfiltered spreading of stuff, and you should actually kind of do that differentiation in your analysis as well. Kind of hygiene for announcements in the community space is pretty bad in many networks, and that's actually a problem that some of your colleagues, for example, Florian Streibel, have been working for earlier on.
Thank you very much. So on 3 points on community first, we understand that we have the lower bound analysis. Communities might be stripped by operators, might have been manipulated, and it could be across the path that is changed. On the borders, keeping the border, it's an open discussion, and I appreciate the comment about the ROVA and invalid lint. I mean, part of learning journey, I learned it. Thank you.
So we have a question from the chat from Miteko.
No more.
No more, not anymore. Okay.
Retired, but there was a quick discussion on the chat on your presentation.
Okay. Illich, is it quick?
Yes.
Please.
Replying to Rudiger's point that routing table size could be an issue with IPv4 if we allow longer prefixes. We are looking at 1 million soon, so we all need to replace our line cards and our routers anyway. And also, if we split the IPv4 space into /24s, it's already 40 million. So I don't think this is a definite objection that holds.
Okay, thank you, Illich.
Thank you very much.
Thank you, Zubair. Thank you very much. Now, next, we have Alexandros Milolidakis, which I didn't, oh, there he is, who's going to talk to us about things that evade root collectors. So the floor is yours.
So hi all, my name is Alexandros Milolidakis, and this work, I'm from the KTH, I'm a PhD student, and this work is based on our recent article. So if you want to know about the full work, please read our article. Okay, so this is the outline of today's presentation. Just to make sure that we are all in the same topic, I will start with a very quick background, then I will introduce the problem about public root collectors, the lessons that we learned, our real-world findings, as well as suggestions to deal with the problem. So, BGP hijacks keep affecting the industry with multiple suspicious as well as well-known events documented each year. For example, in 2022, hijacks affecting governmental infrastructure and cryptographic services, as well as multiple suspicious hijack incidents documented from the previous years. The problem begins because BGP was not designed with security in mind. Therefore, networks have to focus on proactive-based and reactive-based solutions to identify and deal with hijacks. Today, although a lot of effort has been made on cryptographic-based solutions such as RPKI and mutually agreed norms for filtering, these solutions are still not sufficient to capture all forms of hijacks. Currently, that is. For this reason, networks focus on reactive-based solutions, so monitoring either the data plane or the control plane to identify hijacks. Monitoring the data plane has been always harder to commercialize due to events unrelated to hijacking. Therefore, most of the successful commercial solutions currently focus on the control plane. So monitoring public root collectors and looking glasses. So just a definition, a root collector is a BGP speaking device which simply collects and reports all the routes that it receives from its peering neighbors. The public root collector infrastructure, namely RIPes, routing information service root collectors, and the root fuse root collectors, etc., consists of a collection of multiple root collectors distributed around the globe. BGP networks peer with this public infrastructure to publicly disclose their best routes. So we call these networks either monitors or BGP feeders. So these networks at the bottom. These networks connect with the public root collector infrastructure. They disclose their best routes. Then those routes are collected by the infrastructure and later analyzed by commercial solutions such as Kending, Artemis, Thousand Eyes, etc., with the help of either private data analysis framework or public analysis framework such as BGP Stream to identify BGP hijacks. Now, the problem begins because root collectors observe a limited view of the internet, precisely those routes that feeders choose to disclose to public root collectors. A hijacker that observes what routes public root collectors disclose for their victims will potentially design a hijack under the hood that is not visible by the public root collector infrastructure. And to understand how this happens, let's go one step bit deeper to show you how a BGP feeder reports its routes traditionally to a public root collector. So what you see here is the routing information base of a BGP feeder. The routing information base, normally per the RFC, consists of 3 tables: the adjacent RIB-in, the local RIB, and the adjacent RIB-out. Routes that the feeder receives from its inbound neighbors are first stored in the RIB-in. Then from there, if they pass the inbound filtering and they are selected as the best route, they propagate to the local RIB, and from there to the RIB-out and to the root collector. Now, the problem begins because a hijacker that observes what routes the route collector discloses for its victim could potentially design a less preferred hijack that won't be selected by the BGP best path selection algorithm and won't propagate to the route collector. Just to show you an example of such an attack, in its simplest form, you can see here a victim announcing its prefix /24 and the hijacker claiming to be the neighbor of the victim. That is not true, and AS2 here sees both the malicious and the valid route. However, because the malicious route is longer, it is not reported to the route collector, because AS2 chooses to propagate its most preferred route, so the shortest one. So, in this presentation, the example that I showed you was rather simple, but in this presentation, we are now seeking to answer how capable hijackers are actually to design a hijack not visible by public root collectors. And essentially, if I was to, yes, we performed multiple hijack simulation as well as real-world measurements. And essentially, if I was to summarize what we learned, it's summarized in 3 bullets. For a hijacker to be able to achieve such an attack, knowledge about which BGP feeders will report the attack matters. Knowledge of the hijacker about the routing policies of other ASs also matters, and where the hijack exports the attack and the shape of the attack also matters. I will go now through each bullet to explain you why this is the case. So this is what you see here is an example of a past BGP hijack incident of Vodafone accidentally hijacking Comcast prefixes. And what you see here is how the view as seen by BGP Play, so how the BGP feeders reported the hijack. I say that this is a hijack, however, this has been documented as an accidental BGP leak actually by the Cisco BGP monitoring service. And in such attacks where the hijacker announces the same prefix as the victim, they usually split the internet in 2 regions. One is the affected region and the other is the unaffected regions. BGP feeders in the unaffected region won't observe the hijack, while BGP feeders in the affected region will observe it. A hijacker which is able to learn what is the affected region will potentially shape its attack in such a way so that feeders in the affected region won't observe it. And for a hijacker to pull such an attack, knowledge about the routing policies of other ASs matters. We experimented with multiple types of hijackers. First, a baseline hijacker. So a traditional type hijacker which does not deliberately try to avoid route collectors. We did that to collect the baseline. We then experimented with a realistic hijacker. Such a hijacker is how we expect the attack to be launched in the real world. Such a hijacker has limited knowledge about the routing policies of other networks and about the routes that other networks have in the internet, but can learn such an information from the routes that public route collectors disclose for their victim. We also experimented with an omniscient hijackers that knows the routing policies of every AES in the topology. So using a simulated environment, we analyzed from 1 day of measurements that the public root collectors disclose the routes that they were reporting, and we extracted the monitor AESs that were actively reporting their routes. From 1 day worth of measurement, we ended up with around 367 AESs that I have here in the x-axis. And we performed multiple simulations to figure out what hijackers could achieve. We experimented with multiple types of baseline hijacker. If you are not familiar with that orology, essentially the higher the type of the baseline hijacker, the less preferred the hijack is. So the longer the hijack that the hijacker announces. So as expected, essentially the longer the hijack that the hijacker exports, the less preferred the route. So for type 1 hijacks, we saw that in 2% of our simulations, they were completely stealthy. Type 2, 7%, type 3, 15%, and type 4, 21%. Compared to those hijackers that did not actively try to avoid public root collectors, realistic hijackers were stealthier. So we were able to achieve stealthy attacks in 62% of our simulation. And when those hijackers were visible, they were visible by less monitors than usual. And such hijackers can still make mistakes that reveal them. However, if the hijacker was to know the complete routing policies, we saw that the attack was completely invisible, as you can see in the line in the y-axis. Yes, we also checked the impact of such hijackers. We saw that realistic and omni hijackers are usually more impactful than baseline hijackers. We also experimented with future topologies of flatter topologies with more IXP links and topologies containing more monitors. For our full results, due to lack of time, feel free to look at our journal. And where the hijack is exported, it matters. So we saw that actually not all neighbors of the hijackers are responsible for the hijack propagating to the route collector. We quickly grouped the hijacker neighbors based on where the hijacker was exporting the attack to customer, peers, and transit providers. What we saw is that essentially for baseline hijackers, the length of the attack matters for peers. So the longer the attack, the less visible it is for peers. However, that is not the case for transits, because for transit providers, routing policies matter more. Realistic hijackers were much more able to influence hijacks announced to peers compared to hijacks announced to transits. Such hijacks were quite visible still by realistic hijackers because transit providers care more about routing policies and not so much about path lengths. However, again, if the hijacker was to know those routing policies, the hijacker can design an attack that is still stealthy. So we also experimented with our attacks in the real world environment. We used the peering testbed. The peering testbed allows us to emulate with BGP hijacks in the real world. We set up a victim AS at the peering testbed website site at Wisconsin. The victim was announcing its prefix, and we set up the hijacker at the GRNet site at Amsterdam Exchange Point and GRNet. And our goal was to try to design a completely stealthy hijack that won't be visible by public root collectors. Essentially, for a hijacker to achieve that, the ability of the hijacker to identify the dangerous monitors and the ability of the hijacker to circumvent the attack from reaching those monitors, it matters. Unfortunately, the peering testbed was limiting our announcement, so we couldn't utilize the full strategies that we wanted to use. But still, we saw that for a hijacker, it is quite possible in some circumstances to identify all the dangerous monitors. So we experimented with a binary classifier that was classifying monitors between safe and dangerous. If you remember this figure, essentially hijacks where the hijacker announced the same prefix split the internet in two regions. Monitors in the unaffected regions are safe from the perspective of the hijacker. It's because the hijacker won't observe the hijack. While monitors in the affected region are dangerous, that the hijacker needs to react against to avoid them. So we experimented with a binary classifier and actually two classifiers. So a proximity classifier that we try to classify monitors between safe and dangerous based on the AS path length of the hijack announcement. And also a business relationship classifier based on GAU-Rexford routing policy. We experimented with announcing the hijacks in multiple neighbors, so 3 transit providers and 3 peers in the Amsterdam exchange point. We selected those peers based on their high KIDA AS rank. What you see here is the number of monitors that were observing the hijack. Those number of monitors may change a bit based on the hijacker location in each of our announcements. And we experimented with the accuracy of our classifier, so its ability to identify essentially the safe and the dangerous monitors. What we saw is that, as expected, a proximity classifier is not sufficient to identify completely the dangerous monitors. What we actually saw with our announcements, the interesting thing was that it could quite well classify the safe monitors. So our classifier was a bit overestimating those monitors. Compared to transit providers, we saw that for peers, we could sometimes completely identify all dangerous monitors. Although, as you can see in the table, outliers may exist. So it is not a golden rule. However, announcing essentially a hijack to peer, the hijacker could take advantage of this vulnerability. Now, for a business relationship classifier, we saw that it quite well improves the identification of dangerous monitors for transits at the cost of misclassifying some safe monitors. So I will conclude with these slides and with some suggestions also. So in this presentation, we tried to answer how vulnerable are root collectors public root collectors actually at stealthy attacks. We saw that root collectors may be vulnerable if 2 conditions hold. First, if the BGP feeders report only their best routes, and if the route collector is public, a hijacker can take advantage of this vulnerability to design a hijack not visible by public root collectors. Some prevention methods, obviously filtering helps. So if you don't use filter, please use filters. Recently, I was also checking ASPA, so Autonomous System Provider Authorization Objects. And from a theoretical perspective, at least, I can see that it helps to limit such attacks. So when it comes, also please implement that. We also experimented with what happens if we pick feeders at new locations. It's harder to find which are actually these good locations, so which are those strategic locations, but we can definitely see benefit. Some other recommendations will be perhaps to think about a smarter feeder, so a feeder that does not simply report its best route, but actually is able to identify suspicious routes to report them to the public route collector infrastructure. And of course, implementing BMP, BGP monitoring protocol helps, although there may be some difficulties there. And yes, thank you very much.
Thank you, Alexandros. I don't see anyone with any question. We didn't have any on MeTech. Oh.
My name is Daniel Karrenberg, first and current employee of the RIPE NCC, speaking only for myself. Thank you for the very interesting presentation. When I sort of had heard it all, my personal conclusion was what we need to do now is to keep the local neighborhoods clean. So is that a good conclusion? Would one of your recommendations be to that every BGP speaker should be do filtering and be conscious of what's going on, not just the transits? Is that a good conclusion?
Yes, essentially, if also the edge is interested in filtering, it definitely helps to limit hijacks, especially because those hijacks at the ends are very hard to observe. So definitely it helps.
And then second question is, do you have any great ideas on how to do that easily? Sorry, I don't want to put you on the spot.
Yes, but I mean, those meetings help for the community to get interested. As long as the higher networks, so the AS is higher in hierarchy, get more interested in security, I believe that in the future also the ASs at the edge will soon get interested.
Let's hope so. Thank you.
Okay, before you, there's a question from the chat.
Yes, we have Emil Aban from RIPE NCC. What recommendation would you do for road collector projects like RIS? Should we try mitigate by finding the peers that make this type of attack as hard as possible, or is that a lost cause?
I do not, of course, believe it's a lost cause. Now, what we need to do is, it's in my final 2 bullets here. So if we can have a smarter feeder, or if RIPE-RIS could implement BMP, I know that there are some difficulties there. I'm interested to learn actually why this has not been implemented, but that will definitely help, at least to limit those kind of impact that stealthy attacks have.
Okay, thank you. Please.
Tom Strix, Cloudflare. Thanks a lot for this talk. It's super interesting. I was wondering, say that we're in the ideal world where, you know, RPKI is almost everywhere, ASPA is almost everywhere. We're running into a position where it's still possible, like we're all human, automation breaks things, humans break things. There's always a possibility for leaks. With current export mechanisms, the likelihood of us being able to find these problems is going to shrink significantly the better security improves.
Yes.
The only way I can see through that is BMP pre-filter sending to route collectors, but then the problem obviously is you can't distinguish between what's being actually seen on the internet and what's, you know, like trash that you're filtering. Do you have other like ideas or suggestions that might be helpful in not a malicious detection, which I guess this is mostly about, versus, you know, like config errors more than anything else?
So first of all, I do not really believe that. I mean, if we implement BMP, we'll definitely need one way to know what is the best route. That shouldn't change. And I believe this is an easy solution. I mean, somehow we need to know this information, the BGP feeder itself could actually provide this. Now for your actual question, sorry, I'm a bit stressed, so I don't remember it exactly.
More about, like, you're specifically talking about malicious attacks, right? But
yes.
Like, how do we, if we get to a better routing security ecosystem, how do we detect non-malicious configuration mistakes more than anything else?
So the thing with malicious attacks is that they try to seem valid or to seem like mistakes. So you cannot really say that something, if something was a real BGP hijack, you cannot really distinguish it from a leak. I mean, the hijacker will say, sorry, this was a leak. And how will you know? You won't. The effect is essentially the same. So it is really hard to deal with them. Now, regarding RPKI, because you mentioned it, it's not sufficient. It helps only against type 0 hijacks, but not all kind of hijacks. And the example that I showed you was actually type 1, that RPKI won't help, but ASPA could help.
Brilliant, thank you so much.
We have Rudiger. Rudiger, please be brief,
well,
and
okay,
then Maria.
Just one short remark. You are distinguishing between ASPA and RPKI. That's wrong. ASPA will be an object type in RPKI.
Indeed, that you are correct. That is how it will be implemented. Well, so when it is done, please use it.
It's how it is implemented.
It is how it is implemented. Noted.
And actually, and also Rudiger, you were talking in the future, but it is ASPA. So Maria, please.
Maria, developer of BERT. I'd like to ask, wouldn't then be the best solution really, how Tom was suggesting, to have BMP or something like that from every single BGP connection to some feeder?
Yes, so I mean, let's say that, I mean, if we have it from every feeder, indeed it helps. Let's say that this is possible. Actually, no, it's not the best solution. And the reason is that from the perspective of the hijacker, if you report every route, then the hijacker also learns something. So it's very predictable by the hijacker what routes the feeders have. So simply the hijacker needs to not reach these feeders, and the attack is again stealthy. However, if we have a smarter feeder, the hijacker really doesn't know, like what the feeder knows, what are the routes there. So it's much harder from the perspective of the hijacker to hide the attack. So having a full BMP, it helps to reduce impact, but stealthy attacks could still exist in the internet. It will be much harder, definitely from the hijacker to pull, but I believe that it will be still possible.
So it looks like a possible topic for today's BOF on the AI is coming up.
I was waiting for that.
We can discuss that.
Okay, I see no more questions. We're actually out of time. So thank you, Alexandros.
Thank you very much.
And now to complete the Italian team in this session, there's Massimo Candela from NTT talking about geolocation. So we change a little bit of topic.
Thank you very much. Thank you, Max. The clicker is here. Okay. We are a bit late. I'm going to try to be shorter. So good morning, everybody. My name is Massimo Candela. I'm a senior software engineer at the global IP network of NTT. And as you can imagine, also from the name, the global IP network is a pretty big network, and we are also not immune from geolocation issues. And geolocation is the topic of today. I did already some presentations in the past about this topic, and but this is I would say, quite an important status update. And also, we will have an answer to the question, geolocation problems, do we have a solution? And the answer is probably yes. So why status update? 1.5 years ago, with a bit more now, with a bunch of folks, smart folks of our community, we did this RFC, RFC 1992. We will see this RFC. However, the important part is no matter what technical solution you propose, it is good as much as the adoption that it basically manages to get. And this is what we will talk in this presentation. So, but let's start from the beginning. So what is IP geolocation? Well, you have an IP address, you want to know the geographical location where that IP address is connected, and why you want to do that: to respect country regulations, to provide localized content, to, for example, not only the language, but maybe a specific movie for a specific country, to optimize latencies, or you want to do troubleshooting. For example, network operators for years have been annotating reverse DNS with geographic, I don't know, country code, IATA code, SILI codes. So that clearly shows that that information is needed, and to do research. So basically the geography is just another dimension of network. And if you have a geolocation problem, you essentially have a problem on how content, for example, can be accessed through your network. So you have a network problem. And at the end, please. So the why this issue, how this issue started. So essentially, it started mostly because the entire geolocation approach, geolocation, it grew as a, let's say, unorganized development. And so there are the various regional internet registries, and that they are not geolocation providers, and they don't want to be geolocation providers. So there are geolocation providers instead, which are the one providing the service, and they have their own data sets. And there are several, I would say many. And then there are content providers and CDN. These content providers, CDN, they use the geolocation from the geolocation providers, but they often have some patch fork enrichment of the data that locally they maintain. So when you have some problem, how do you find where it is? Because now the data is scattered across the entire, is scattered in various data sets. So how do you correct it? So there is also no common strategy. So in general, you go and you see blog posts. They tell you, oh, try to change this, try to change this other thing. And in the end, send emails. So essentially, there is not a formula, reproducible amount of steps to reach a fix. And this is mostly because geolocation is in general done by, I would say, guesswork, mostly on WHOIS data, but also reverse DNS, latency, and stuff like this. And WHOIS geographical hints are a mess. Also, you own these resources. These are your resources, or you're managing those. And basically, there is no way for you to actually provide that information. You are not the source of that data. So in WHOIS, which is the basic source for many of the geolocation hints, there are for two examples of attributes. There is the geoloc attribute, which is supported from 2 out of 5 of the RIR. Which allows you to annotate an INNAM with latitude and longitude, which is essentially the most accurate and human and friendly way to describe geolocation, to annotate something so vague like an INNAM. You can geolocate a /12 in your living room, essentially. And then you have and still 2 out of 5 RIR. And then you have the country attribute. The country attribute is associated to the INNAM. It works in 3 out of 5 RIRs, but all the 3, they have different definitions. So APNIC, it says the country attribute is the country where the network is deployed. Fine. The LACNIC says is the country of the company that has those resources. And then you have RIPE. RIPE, the official documentation says this, that is reported here, which essentially says it has never been specified what this country represents. It could be the location of the head office of a multinational company, or where the server center is based, or a home that the end user. So you can say it can be whatever you like, but it's mandatory. You have to put it. there is no definition of it, but it's mandatory. So we had an issue recently as NTT about this, because for reasons that I don't quite, we moved our LIR account from the US to the UK, the one associated to RIPE. And basically, for some reason, maybe some of our colleagues, or maybe during the process, I don't know, many of the country attributes, they became from US to UK. And then all the prefixes that they didn't have geofeed, they basically, almost all, in many geolocation providers, they moved to the UK. I had a VM connected in Dallas, but UK. So they are quite used, even if the documentation says, oh, you cannot use it for this and for that, they are quite used. And again, on INNAM, so if you would want to make this scale, even if you would want to make it scale, how many things are we going to put in INNAM? Also /32 in INNAM, I don't know. So how often does it happen? Quite often. 241 emails about geolocation problems only in NANOG mailing list from September 2019 up to 2 months ago. So one mailing list is quite a bit, I would say. So what do we want? We want to gain control of this data. We want to provide this data, and we want to be flexible. So we want to have basically be able to specify this at prefix level or single IP level. Or we even want to do something like, oh, this /12 is in Italy, but this /24 inside the /12 is specifically in Rome. We want to be hierarchical even. We want to be also flexible geographically, country level, region, city, whatever. And we want also this to be easy. We want a lot of stuff. So we want this to be simple, like editing a file, editing a text file somewhere, okay? In particular, we do not want to send emails, please. We do not want to send emails to geolocation providers or to content, to whatever tickets and stuff. We want just to edit a file somewhere and they have to pick it automatically. That's what we want to do. Also, we have to remember that in medium, large organizations, most of the people do not have access to LIR portal or to LIR. So basically they cannot change this data in WIS. And so what we want is essentially a way that once the system is set up, the network engineers, that they know where these resources are deployed, they can just edit their file whenever they want. So the solution is RFC 1992, basically gives to the network operator the power to control the geolocation. What we did is we took a RFC, with basically a geofeed file, which is a text format that existed, and it was already in use by geolocation providers, and it was also known by ISP. So we took something that already people were familiar with, and we just link it in WHOIS, essentially. And this allows for various things. Why WHOIS? First of all, is because WHOIS is authoritative for when you want to know information about resources, you go there. So that is the right place to start. And once somebody puts the link, maybe you ask your colleague that has access to put the link, you keep managing on the file. That's the idea. This allows also the geolocation providers, or whoever wants to fetch this data, to just go fetch WHOIS data, find this file, and basically know where you set your geolocation. In addition to this, which is quite important, we provide a way to validate ownership of these files, because so we said these were already used, so they were already shipped by email, but how do you check that you own those resources? How do you even check that you are who you are by email, or that you are authorized by the company? And I received various questions like, oh, we check the domain of the email, stuff like this. So at least we provide also a way to validate the ownership. So easy. How do you do that? You create a CSV file, which is a simple text file. You put in this, every entry is in this format: prefix, comma, country code, which is ISO, comma, region code, another ISO, comma, city, comma, there is also zip, but don't go there, deprecated, why you want to provide a zip code to match. That's why there is a trailing comma there. And then you put this file somewhere. You host over HTTPS this file, and then you go find the INNAM that encompasses the resource that they are described in the file. In the file, there can be more resources, so you have to find all the INNAM that encompass basically these resources, and you add a remark in this format, which is geofeed with uppercase G and the link to your file, okay? This is an example of file. All these fields are optional, so you can put whatever level you want. If you don't put any of those, it means do not geolocate, but it doesn't mean the geolocation provider are going to respect necessarily your wish. This is how you add the remark in the RIPE database. You go in resources, and then you go in your INNAM and you add the remark. This is what it will look like if after you do a WIS query and you have the file. Important is do not forget to link from INNAM. So imagine this is the file on the right, okay? And you have various resources. The way how the system works to validate is that this INNAM will validate these resources here, okay? So whoever reads this, for example, goes in WIS dumps, not fetching single WIS query, but goes in the entire WIS dump, find the INNAM with geofeed remarks, and after it finds a link, follows from that INNAM the link in the file and grabs only the prefixes inside the INNAM, okay? This is how it validates. So if you forget this link, for example, in this case, what would happen is that this IP will not be fetched by the geolocation provider because you forgot it and cannot be validated. So do not forget to put the link from the INNAM. Once you have it, you just keep editing the file as much as you like. So there is also a utility if you don't want to do this manually, mostly because there is at the moment more than 5% of geofeed files that they are like with random ISO code. For example, a U is not an ISO code. There are like various stuff. So you can use this tool, which is packetvis.com/geofeed. It's not an entity service, it's a utility, which simplifies the entire process. Or you just go on packetvis.com and there is an icon, geofeed, you can click, you set the prefix. Next step is asking you the location. You can just type the city. It will make sure that all the ISO codes, they are correct. It will show you also on the map. So you cannot go wrong there if allows you to go to the next tab. Then it tells you what you have to modify in terms of INNAM. The system already creates and hosts the file for you. So basically you can just copy paste the remark in your RIR portal and you have done with it. Otherwise you can just switch to host myself. You download this file and you host it wherever you want. So you can use it as just as a tool to create the ISO code automatically and stuff. And then you click save and test. And when you click save and test, you will see that if everything is fine, so if your file was reachable from WIS and all the ISO codes were correct and stuff, you will see this green thing here at the bottom, and then you are done. There is nothing else to do. Your geofeed deployment is correct. Now the geolocation provider will fetch it in general in 1 day, maximum you will see, and essentially you're done. There is an extra step optional, which is check where my geolocation provider say it is. That if you go, you will reach this table where you have a list of geolocation providers and will tell you where at the moment they see your prefix. And the one in green are the one that they are now matching your geofeed file. And they will also, well, you keep checking this page, and in a few days, since you just corrected it with the geofeed, in a few days, they should be more or less all green because the geolocation provider will start fetching this new data. So you can use it to check and also as a sort of feedback loop. And so it helps you with the correction of the data. So, but let's talk about adoption. So another website that you can go is geolocatematch.com. This is the website dedicated to the RFC that I created. There is an ongoing experiment that basically crunches every day adoption numbers. And when I did this screenshot, it was like around less than 2 months ago, we had 63,000 prefixes with geofeed. Now we surpass 100,000 in basically a bit more than a month. So this is pretty good. But even more important, there is this table here, which gives you a list of geolocation providers that they are automatically fetching, so they are supporting the RFC. And you see that they auto-discover for V4, auto-discover for V6. This is also an old screenshot. Now there are more of these providers. And you see also how much time they take to fetch this data automatically. And here there were like some 1 day, some the last, if you go now on the website, the majority of these, it takes 1 day to automatically fetch this data. And there is one geolocation provider, only one of the big missing. A lot of the effort behind this was also to talk with geolocation providers and interact with them and explain and support. And this geolocation provider, which is missing now, sent me an email a few weeks ago saying, we almost have it. And they gave me a date that is really close. So when we will have that, we basically will have the entire market supporting that, the fetching of the geofeed, but I will leave to them to do the announcement. So it's pretty good coverage, I would say. We are using it, identity, quite successfully to correct our geolocation. Then there is also in this page a way to do a quick test. This is only a test. It doesn't, you just set it up however you want it. It's not a tool to set it up. It's just a tool to test it. And it just checks that it's reachable. It checks your ISO codes and stuff. And there is also the share on Twitter. I know that now Twitter is not fancy, let's say, like it used to be. But anyway, if this is a way that I put there to help spread. So if you have all green, this button will be green. And if you click that, it says, my organization, blah, 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 deployed correctly, geofeed. And in this way, you help me and us share the knowledge about this solution. So there is also an FAQ where you can find more information. And you find also a file that you can download about all the geofeeds validated that they are available at the moment. So my presentation is done. So quick recap. So we do have a solution that works quite well, which at the moment, I would say it solves many of the problems about geolocation, and that possibly in the near future will solve it all. At least that's my hope. And that you have also this utility, the first link, packetvis.com, where you can use to set up your geofeed. And by the way, there is my brother in the audience today. He's behind this, so you can also ask him a question. And there is also, that I can see Manuel there, and there is also the geolocatematch.com to test, check adoption number, and read more info, and of course, the RFC that is here at the bottom if you want more information. So if you have any question, please let me know. I think we have a few minutes. Yeah.
We do have a few minutes.
I recovered that.
And great. This is not very Italian though.
I know.
We have Illich, who's been standing there for quite a while with a question.
Yes.
Actually, I am an anonymous person, and my location is none of your business. I think this is all nonsense, and I think the EU privacy regulations agree with me, because they classify an IP address as a piece of information that can lead back to a person. So GDPR,
okay,
deal with it.
Yeah, no, it's fine. Well, as I told you, the format allows you to even say that you don't want to be geolocation. You can express your wish about it, which is a thing that was not possible before.
Sorry, can you go to the mic?
They can ignore it. But anyway, so the reality is this. No matter how much you like it or not, the geolocation, it makes your services possible. And if the geolocation is wrong, your services will not be possible. And then at least we can correct it. You can express that you don't want to be geolocated. There are options. But this is where we are, and this is what we have to deal with. The system is to help fix a problem. And there is basically, if you don't want to be geolocated, I don't know, use VPN or other solution. I mean, there is not really so much at the moment. This is how you access content. So at least we have a way to fix it.
Peter there.
Peter Hessler from Global Ways. RFC 9092 has two methods to declare your feed. One is a geo feed, attribute itself, and then one is a comment geofeed URL. I looked up the geofeed or the location information for the right meeting prefix, and they're only publishing the geofeed attribute itself. However, this database has, or this service you mentioned doesn't look at that at all. And so it only shows, oh, you have nothing, we're in Berlin, like last time.
No, both the services that I showed, they actually read the geofeed attribute. So if you did an experiment and it didn't catch it, then we should check why, but it does read, and I made sure it does read geofeed. The only thing is that at the moment, the only RIR that supports geofeed attribute is RIPE, and it does not support for all type of allocation. So it became for me a bit complicated at the moment to explain to people why some yes, why some no, and stuff like this. And also I realized that since it is a new attribute, geolocation providers, they basically rely mostly on the remarks, because it's the only solution at the moment that you can use to fix geolocation across all the 5 RIRs.
Okay, that was actually going to my real question, was which do you recommend? Do one or the other or both?
So at the moment, I would recommend the remark, because there is no clarity on what the geofeed attribute, when can be used, how and stuff. There is actually the DNS working group on Wednesday, I think, I don't remember, there will be a part dedicated to this. And also because the remarks are across all the 5 RIRs. So you have at the moment more chance the geolocation provider will just read remarks across all the entire thing. But the geofeed attribute is a reality in the RIPE, and the tools should fetch it to test it. But I would recommend for now to use remark.
Okay, thanks. And then after the session, let's just chat really quickly and I can show you what I saw.
Okay, perfect. Yes.
Okay. Next.
Hello, Vladislav Podopian from the Global AI Foundation. My question is, what about the content providers who have their own methods to determine the geolocation? For example, we are the Swiss Foundation. We have data center in Germany, and 2 years ago we got IPv4 location from RIPE, which belonged in the past to a telecom provider in Russia. And some providers, content providers, still think we are in Russia, despite we put our coordinates and country code Germany in the INetNum object. And for example, Google thinks we are in Switzerland because, well, our foundation is registered in Switzerland.
So the answer is try to use the geofeed, which would help in that case. Also, Google accepts geofeed also directly on their portal, which is not something that I am advertising. They should support just the normal RFC. But anyway, the geofeed is possibly something that will definitely help you in that direction. Sorry, what was the first part? Oh, the content provider. The content provider, they fetch geolocation providers, and I am in contact with some of them, including a big CDN and probably the biggest streaming provider. And at the moment, they are also in the process of implementing this. It's sometimes difficult to understand where they are, because they provide feedback that their pipeline is different. However, by fixing geolocation provider, you essentially fix 90% of the problem. And that they want to already fetch the geofeed file directly is actually a good thing, in my opinion, because it may speed it up. It may make the geofeed file even more authoritative. So it's actually not bad. But try with the geofeed and should help fixing your problem.
Thank you.
Okay, see, Maria.
Hi everyone, Maria Stafilara, IPNC Senior Legal Counsel. Thank you, Massimo. I just wanted to mention 2 things. First of all, about the country code in the INetNum objects. On Thursday at the database working group, we will present some observations that we made from certain RIPE database use cases. And one of them is relevant to what you mentioned about the country in the INetNum objects and the fact that there is no agreed definition over how these attributes should be used and how it was misinterpreted in some cases. Now, regarding the geofeed, there has been recently a discussion in the database working group about the geofeed attribute. Initially, from a legal point of view, we raised some constraints because geolocation was not supported under the current purposes of the database, and therefore we urged the community to agree if geolocation is a purpose that the database should fulfill, to agree on that so that it is documented. And then for this reason, we had suggested that technical limitations have to be implemented when the geofeed is used. Now, we have recently sent another email to the database working group summarizing the situation and having in mind that there has been consensus that geolocation is one of the purposes that the database should fulfill from now onwards, that it is okay to be used, but the privacy of the user has to be kept in mind, because it is up to the resource holder themselves to decide the granularity of the geolocation information that will be inserted there. And of course, before inserting any geolocation information, the resource holder themselves need to have the explicit consent from the user, if we are talking about single IP addresses.
Perfect. Thank you very much. Thank you for your clarification. This is actually a point that is related to your, thank you for your.
Thank you, Maria. Rüdiger.
I was first. Massimo, you were responding to Ilyich. Well, okay, just get it. There will be no, well, okay, the service will not be available to you if you do not support geolocation. I quite certainly want to object to that kind of statement. I'm a level 3 networking person. Geolocation doesn't matter anything for the services I'm concerned about. Kind of, yes, there may be services and service providers, upper application layer, that depend on it for whatever. And there may be cases where kind of no service is delivered if they cannot figure out geolocation. But I have to say, from my personal point of view, I probably will not want to use that kind of service. Thanks.
Yeah, okay, then don't provide it. It's not that this thing is now mandatory and everybody has to do it. Just don't provide the data. And also, yeah, okay, it's I mean, we are a backbone network, and also we are a customer complaining, oh, this doesn't work because of geolocation. So it is anyway related to impacting the services that you offer, even if you are working on a lower level of the network. But still, if you don't want to, it is a way to fix a problem that there is at the moment. If you don't want to use it or you don't want to fix it, just go ahead. Anyway, you have to be aware that somebody is making the geolocation decision for you at the moment, and it's out of your end. The only thing that I'm introducing here together with the co-author is a way for you to gain some control of it. That's the final feedback of it. Do we have other?
Yeah, we have one last question here from Kurt Kaiser, then the rest is.
Yeah, Kurt Kaiser, ordinary internet citizen. I think there goes so much wrong with geo IPs that I want to raise the issue even higher, that it creates artificial boundaries and walls. And for me, it's a modern way of racism, actually. It's more a statement than a question to make it better. And I would hope that Randy would also be heard in the queue, because he was also a long time waiting, and hopefully I would like to hear him too. Thanks.
Yeah, I can agree with you. However, we are in a system that there are also legal requirements that, for example, require geolocation. So in the end, yeah.
That Hollywood wants to slice and dice who gets to show what, where. That is nonsense. We are here in the EU. I'm revealing my location with moderate precision. And in the EU, You don't have borders. You can do business with anyone, and we shouldn't support this kind of nonsense.
So you mentioned data locality. How do you, in GDPR, how do you do data locality if you don't know what locality? So how do you put the cookie pop-up, or how do you enforce the GDPR inside the EU if you don't know the location of the end user? Including the GDPR introduce a lot of content and a lot of websites to actually check the location of the user to respect it. And that is another.
No. You are completely backwards. What they do is they want to know, is this a non-EU person? So we don't have to be good private citizens. So they don't protect us. They don't stick to our rules. They want to ignore our rules if they can get away with it. That is the purpose of the geolocation.
Okay.
So we shouldn't want this. We are ahead here in the EU. We should export our privacy to the rest of the world, not import their misuses of personal information. We shouldn't import that from places like the US.
Look, when there will be no need anymore for geolocation and the services will all fail, then we will just call it a day and close it. But for now, we need it.
Okay, I think we've run out of time for your questions. So thank you, Massimo. Thank you very much.
Thank you very much.
And before I let you go for the break, two things. There are the program committee elections. So please step forward if you'd like to join us. And then second is please rate the talks. Let us know if you liked them and especially if you didn't like them. So thank you very much.
Right. So test 1, test 1, 2, test, test. Is low. Okay. And what about new? Is it better? Test. Nothing happened. Oh, sorry. This is my mistake then. Mix streaming. Test. What about now? This is better. More volume. Do you need more or not? Test. 1, 2, 1, 2. Testing for the stream. Test. Okay, I'll keep it this way. Very good. Stream.
functioning yet? All right, great. Well, good late morning, everyone. I see we're still kind of filling up this huge room, so we should have decreased it, or maybe increased the screen size. All right, so this session has 3 blocks, so to speak. We have 1 extra large talk, 1 regular talk, and 3 lightning talks. So the starting one is you regulating open source software, the proposed Cyber Resilience Act, and Product Liability Directive. And we have 3 presenters. It's Ben of Render, Bastian Goslings, and Robert Carolina. I think this is the order of their presentation. Okay, people please sit down, and we're going to start with them shortly. Oh, Benna is already on stage. Hi, Benna, and please go ahead and speak.
Okay, thanks. Okay. Should I wait for a minute, or you rather have me started? Okay, thanks. This is so important. The introduction is so important. Otherwise, everyone is lost. Anyway, good. It's counting. So, for some introductions, actually, I should have updated also the presenters. So originally, Martin and Bastian would be here on stage. Martin is working at the Knowledge Labs. He's unfortunately has to excuse to be here for a fortunate, unexpected event. So I'm not the expert as Martin is. So I will, instead of a very in-depth discussion of how things went on after last Arrive meeting in Belgrade, where he did a presentation at the Open Source Software Working Group, and I think also cooperation about a new legislation, the Cyber Resilience Act. So instead of that, an in-depth, I give a little bit more high-level presentation to get everybody on par. Bastian will give some more about the status and the follow-up steps, and Robert Carolina will also present another initiative or another regulation, which is the product liability. So we're a little bit broader and less in depth. And yeah, thanks. All the credits to Martin, all the failures and the mistakes are on my account. Good. So the CRA. Yeah, who's familiar with the CRA here? Okay, 1/3. That's good. So the CRA is something like it's the CRA. The European Commission tried to regulate products with digital elements. And so, what are digital elements? Well, actually, that's everything with hardware and software. And it's about security. So they want to reduce the number of holes, security vulnerabilities in your product. So that's the intention of the CRA. Well, next slide. So. And you're probably familiar with the CE marking. So that's, they actually want to have software kind of have a CE stamp, that it's have been audited, has been approved, and it can be put on the European markets as a software product. But there are a number of issues here. So we're not against security. We're not against regulations and security, but we are for good regulations. And I think there was room, and it was definitely identified half a year ago, there was room for improvement here. So how to go? So we specifically look at open source software here, not as software in general, on the European market, but open source. I will come to that later, but well, our own interest at Knowledge Labs and IEC, we make open source software. And so there were some specifics that is very interesting for us and has a serious impact for our organizations, how we produce and maintain software. And I think a lot of the internet is running on open source software. So it's not only us feeling an impact, but it's also the users and other people here developing great open source software for routing, for DNS, etc. So it has a really impact for producers of open source software and users of open source. So again, okay, everybody, we talk about products with digital elements. So it is hardware and software. And there are a number of exceptions. So not covered is open source. Okay, that's interesting. Come to that later. Services, so running, for example, a DNS server, that's under NIS2. And it has been, for some of the discussions have been already gone through the RIPE community, so I won't go into that. And also outright exclusions. So for example, medical equipment, they have their own regulations already. So these CRA regulations won't apply to that. So that's one single regulation. Back to the non-commercial projects, including open source. That sounds good. So again, we want to produce secure software, but an open source software, but without, or maybe go back. So this open source, not part of a commercial activity. And that's the whole crux here. That's very difficult to define what's a commercial activity, and we come back to that later. So what is the CRA? How does that work? So there's an so that's through the lifetime of a product. There's a design and implementation period. There's a maintenance, and at some point, we call it it's called conformity assessment. It's just checking if you if you meet the requirements or not. So there's a long list. This in the annex. I removed the bullet points here, for example, for lack of time. But there are a number of requirements you have to meet before you're allowed to put your product on the market. So okay, that's good. So that's the green arc. So who does this assessment? Well, 90% of the products are in category, the default category. They say, well, so there's some examples, photo editing, Word. So they do self-assessment, it's fine. That's also the thing the open source developers do, actually, because they want to put open source and secure open source on the market. But for the critical class 1 and critical class 2, there are different ways for this assessment. So it's either application of standards or a third-party assessment. So this application standards we'll present that a little bit later. But the third-party assessment, so there will be other external parties doing an assessment of your software. And again, speaking for myself and for IEC, we develop DNS software and other software close to the routers. That's really infrastructure, industrial software. So our guess is, well, analysis is here, we are in the class 3. So we are in this ballpark that if we have commercial activities, then we are in the third class 2 category. We need third-party assessments. Good. We'll skip this one. Great. So there's this again. There's a lot of legal talk here, and so I want to introduce at least some terms here. So the new legislative framework is kind of what's the EC using internally as a guidebook, what it talks about. So it talks about manufacturers, notified bodies, etc., etc. And so I want to identify a number of these definitions and how they relate to the third parties we talk about. So the notified bodies in this new legislative framework, this is what the EC is using for creating new laws, for acts and directives, is they call notified bodies. So these are the third party assessments. So in the Netherlands, we have the Lift Institute, checking lifts. We have TÜV, there's a German one, and there are many, many more. But as far as we know, there's no third-party assessment organization for software. So it's something completely new. So that has to be defined and has to be, when this becomes a real law, European law, these kind of institutes has to be created with all the expertise. So that's something we have to think about. And then again, you have the notifying authorities. In the Netherlands, it's the Rijksinspectie Digitale Infrastructuur. And they also have to accommodate for this new law. Good. So where are we now? 23, about halfway. I think Bastiaan will go more in depth where we are now with the process. But important is that the standardizations, so because the requirements are a little high level. So the standardization will give exact rules we have to apply. There aren't any standards. So they have to be defined. So that will be after 24. And then in 24 months, I think there should be harmonized standards. And that's very, very optimistic. There is nothing. And in 2 years, they expect to have standards we have to comply to. So that's also a concern for us. And the standards, it's not about security. It's about kind of a security assurance. It's about the feeling it's secure, and not so much as we try to build software that's secure. And the whole thing, this the little bit the tension between the act, the Cyber Resilience Act, what it tries to achieve, and what it does to us. It's more a feeling that everything is secure than it's really secure. Good, given time. Ooh, going faster. For open source, well, just the hardware products, you know them. Washing machines, telephones, they have the CE mark. And it's clear who is owner of what. For open source, the simplified example for Linux kernel, for example, it's not clear at all. So who's the owner of the Linux kernel? Is that the Linux Foundation, or is that kernel.org, where I can find my source from the Linux kernel? But there are also many, many developers contributing from different companies. So this whole CE marking for products, they want to apply it to software, open source software, but a large group of people collaborate, doesn't fit well. So there are many, many things not very clear here. Okay, so how does it affect FOSS? And going back to the commercial activity, I have to speed up now. It only applies, so we exempt, FOSS is exempt if it's out of the course of commercial activity. So how do we define commercial activity? Well, open source is free, so it's not a product on the market. It's what some of us do, IEC and other companies also. We provide support contracts, and that's in that sense a technical of a commercial activity. So we're in the current definition, we would be in. So open source, and there are all kind of risks here. So can you read? Oh yeah, you can read it. So this expensive interpretation of commercial activity narrows down the organizations or the open source projects that are exempt, and that makes it quite dangerous. I will skip all the implications here. You can look at the slides. I have to speed up here. And also, there's the blue guide. It's also with part of the legislation, the new legislation, is that commercial activity or standalone software as a product is not well defined there. So they didn't thought about it as standalone software as a product. It's more as part of a larger product. So there's also the definitions are not aligned yet, harmonized. So there are all kind of problems here also. I think I sketched the problem. I think it's good to go to Bastiaan, to where we are now. So with the current definition, yeah, okay. So kind of summarizing, in the current situation, we're looking at, we are in the discussion. So we have, in this past half year, there's a lot of outreach to members of European Parliament, to other organizations, to make our point that with the current interpretation of commercial activity, open source would be in the CRA with all kind of risks that innovation would lose because people as an individual and you get some kickback, some money, some funding to do some open source development, it can be considered to be a commercial activity and then you are regulated. And for small software developers, companies or individuals, that can be a reason to stop contributing and stop innovation, etc. So that's how we identify the risk. Yeah, Bastiaan, please take away.
Thank you. Is this mic working?
Yeah.
Can you hear me? Hello, can everyone hear me or not? Yes? Oh, excellent. Hi there. My name is Bastiaan Goslings from the RIPE NCC. I joined the Public Policy and Internet Governance team just a year ago. And this is one of the files that I also have been involved in. And I will now in a relatively quick overview, try to share, what happened since Maarten from NLNet Labs gave the presentation on the CRO in Belgrade, the last RIPE meeting. What happened since, input that we provided, and also give you like an overview of the current status and what's happening and what potentially could be next. So thank you, Benno, for your great introduction. When we saw the initial proposal from September last year, yeah, it seemed like good intentions, improving cybersecurity within the European Union region. Of course, harmonizing and creating legal clarity sounds like a good thing. Yeah, the risk-based approach seems like very sensible. Security by design, we like that. And also the part, that's not necessarily something that you went into, Benno, but that's also part of the regulation that manufacturers and others, distributors, importers, that bring products on the European market also need to provide consumers with clear information with regard to the products. So all in all, it sounded like a good thing. But still, after reading it, it raised a number of questions, and the European Commission gave the opportunity for external stakeholders to provide input, reflect on this proposal. So that's what we did as a RIPE-NCC 2. On the 23rd of January, we submitted a response. There's a URL, short URL there that you can read it if you have not already done so, because this response was not only on behalf of the RIPE-NCC, how did we read the proposal, what did we think of the scope and the intentions, etc. Of course, how it potentially could affect our services, the way we read it. Atlas, for instance, is in scope, not considered a critical service or critical product, but still, that would have implications. And last but not least, we also went to the community using the respective mailing lists to see, what do you guys think of this? And that's actually where the open source component came in and was flagged. So we brought that to the Commission as well. This is a screenshot of the response we provided. And I want to go into like the community concerns. When it comes to the RIPE-NCC, please read that. But with regard to the community concerns, it was all about the open source component and the exemption there, which in itself seemed like a good thing. But it just raises a lot more questions, as Benno just illustrated. Like, how does this work in practice? As was referred to, it only applies when developed or supplied outside the course of a commercial activity. How is that then exactly defined? You go to the Blue Guide, and that really doesn't give you a clear answer too. The terminology that is being used here, as was referred to, it's part of a framework. But how does it actually, how does it apply to software, and more specifically in this case, to open source software and everything, that surrounds the development and publication of that. The way that we read it and what we received also from the community, that this potentially could have a huge impact on smaller entities, developers, as well as individuals, that are working on this. If you, for instance, then fall into a category of critical products, that has significant impact in terms of compliance and the costs that come along with that. What does that then mean, in terms of, are people going to stop developing? Are they going to stop placing products on the European Union market? What does that mean in terms of innovation? Everything, that the European Commission is advocating for. And another thing, that came back from the community as well is like, the emphasis should not necessarily be on the type of license associated with the product, but actually what is it used for? If a bank, takes part of an open source repository and use it for a certain service, that you could consider that much more critical in terms of potential impact if something goes wrong than if you as a private individual, hobby around with it on your private website. That was with regard to providing the European Commission with input. Recently, we also sent a message to the European Parliament, especially members from the ITRE committee, the leading committee that is working on this, again to raise our concerns, to flag the concerns with regard to this open source so-called exemption. And then also referring to what we considered would be improved text that actually was something that the Council came up with, the member states. And that brings me to this slide. Some of you may be aware of how this works. Initially, the Commission, European Commission, will come with a legislative proposal There's work being done before that, right? Like stakeholders are consulted, an impact assessment is done, of course, and a need is defined for something to be formulated in terms of new legislation. But once the Commission comes with its proposal, that is published, and that is it as far as they are concerned. People can provide input and reflect on it, but the proposal itself is not going to change. Then we have two other entities I already referred to. We have the member states together in the European Council, and on the other hand, the European Parliament, and they will also look at this proposal and think about that and, you know, reflect on it and come with their own proposed changes, so-called amendments to this proposal. And that's actually, you know, the process that is being worked on now, and it's actually, you know, almost being finalized. But when it comes to open source, the Council already has reached a compromise text, and we're now in the midst of the European Parliament, especially in the ITRA committee, to discuss, they're discussing all the amendments from the different parties that have been tabled with regard to the CRA, and in this case specifically with regard to open source. So as I mentioned, the Council already has reached its compromise text. I included that as an annex, as an additional slide, if you would like to read that. The European Parliament is actually, you know, and the pressure is on. They're really working hard to finalize this. For them to table new amendments at this stage is not longer possible. But if you do feel the need, right, to flag concerns that others have already raised, you know, just in terms of quantity and keeping this on the agenda and having it go to the right direction, it could still make sense to reach out to either your local or regional MEPs or from certain parties, you know, that you feel sensitive towards, you know, the position they're taking, you want to reinforce that, or others, you know, that you think, hey, this is going the wrong way, and you want to provide them with arguments to make another proposed stance on this. As I mentioned, I included the text. This is a compromise text from the Council, and from the latest draft report from ITRE, the proposed text in there, but there are numerous other amendments. It seems, summarizing, going into a better direction than the original proposal itself, but we're not there yet. I'm looking towards Benno. Do you think, does it make sense to have questions with regard to the CRA now, or go to Rob first? Okay. Give it away, Rob.
Hey. Hello, everybody. I'm going to do a bit of a context shift here, and I think this is the gizmo, but clearly someone's driving this as well. Let me see. Yeah, okay, that works. Fantastic. Right, in a little less than 5 minutes, I'm going to introduce you to a topic that sort of the legal equivalent of teaching you everything you need to know about lattice cryptography in order to get ready for quantum computing attacks, but in less than 5 minutes. But as an engineering group, I have a feeling you folks will be up for it, not a problem. Very, very simple thing. You can read this slide at your leisure later. This is the trust me slide. I wanted to, in order to introduce you to this idea, context shift, I want to talk to you about the Product Liability Directive, PLD, the Product Liability Directive. As Benno said, the CRA is not just about creating software, it's about creating an environment of security assurance. It's the cost and process of chasing that little CE label. Who's required to do it? How much will it cost? How difficult will it be? What I'm going to talk about now, Product Liability Directive, is about who gets stuck with the bill, civil liability, lawsuit liability, when something goes wrong and a person is injured or killed. So to do that, I'm going to introduce a hypothetical. I'm going to do what lawyers do. I'm going to tell you a pretend story. This isn't a real story, thank God, but one day it will be. About 7 persons, 2 pieces of software, 1 car, and 1 victim. Read this later. I'll just tell you the story. Here's the picture. We have a company called Firefly Limited that writes a piece of software that I've described as Open Sesame. It's a cryptographic unit designed to authenticate users. They live in Fredonia. There's a company called Bravo Bits Limited that writes a piece of software called Bravo Drive that translates user inputs to control surfaces. It's fly-by-wire type software for automobiles. And they incorporate Open Sesame into Bravo Drive. They live in England. Third person, Einstein Motors Incorporated lives in California. They build cars and they take Bravo Drive software, which also incorporates Open Sesame software, and put it into the car. Exotic Imports Limited lives in Ireland. They import the car. Someone named Johnson lives in Ireland. He buys the car. Someone named Victim lives in Ireland and gets hit by the car. Why hit by the car? Because someone named Dennis Dastardly, who lives in Mauritania, hacks into the car using a zero-day exploit because of a coding mistake made by Firefly. That's the picture. The question is, what happens next? We get a forensic expert report that said the reason this zero-day existed was because of a coding error made by Open Sesame in the first small piece of software. Misplaced semicolon results in a zero-day exploit. That doesn't sound at all familiar. That's never happened, has it, in the history of security software? Firefly, everybody else in this chain is very careful in terms of who they select, how they build, how they do quality assurance. Everyone's very, very careful. And the hacker, well, he gets hit by a bus, he's broke. In my law school exams, I teach technology folks in cybersecurity about law and regulation. I've been doing that for 23 years. I always have the hacker gets run over by a bus or killed, or in this case, I think killed in a paragliding accident. I changed this. Here come the lawsuits. 2 more slides, very dense, but only one change. This is the only thing you'll see for the rest of my little blurb. The law as it exists today, if you think of lawyers and lawsuits as an attack vector, your exposure to a lawsuit, think of that as your attack surface. 2 main paths of attack that someone representing the victim will take. They'll sue you for negligence, or they'll sue you for having supplied a defective product that resulted in death or personal injury or damage to personal property. 2 different types of attack vector. And as you can see from this slide, basically nobody today gets tagged with negligence liability for the story that I just told, with the possible exception of Firefly, but I have to tell you it's pretty attenuated given the way the law works today. Because reasons. Don't have time to go through this block by block. And in terms of strict liability for defective products, the law in Europe as it exists today, the law in the United States as it exists today says software is not a product. So the automobile manufacturer will definitely become liable for this problem. Why? Because it turned out their car was not safe. But I thought you said they were careful. Yes, they were very, very careful. But nonetheless, someone was able to gain remote access and pilot the car off the road and kill a pedestrian. That's not the level of safety we expect a car to have. They are a least cost avoider. They are the types of people that society, at least in Europe and in the United States, has decided should bear the cost of this kind of damage. What does the product liability directive going to do that matters to people in this room? These slides are slides that I first presented at Etsy Security Week 4 years ago, predicting to the people in that room what is happening this year. And I said then, and I was right, and I'll say again today, that if Europe decides to change the law, the difference becomes this. And if you look down to the lower right-hand quadrant of this particular slide, you will see, and I've got a big red light here telling me to shut up, so I've only got 30 seconds before someone gives me the hook. This says that although we didn't used to think of software as a product, once this directive is in place and transposed into member state law, we will, which means that all of those people upstream are suddenly potentially liable in the same way that the automobile manufacturer is, including the supplier of that component, the mistyped semicolon. Were they careful? Yes. Doesn't matter. You can be as careful as humanly possible. Was the software defective? That will be the only point of inquiry. What does all this mean in practice? Nobody's going to know for sure for at least 3, 4, 5 years. Thank you. On that cheerful note.
Okay, unfortunately we are running short of time, so we will not take any questions in person here because you are present here and the speakers are present here. You can actually engage in a hallway break, but we have an online question which is, I'm shocked that hard drives and smart speakers are in the default category. Both would seem to provide significant risk to the rest of the ecosystem. Will the categories get better refined? By Michael Richardson.
That's a CRA question.
Yeah, so that, oh, I try to trick you into this to answer. So I don't have an answer for that, for the question. So to redefine this 90%, 10% class, and so why are the hard disks and microphones not critical in the class 1 or class 2? I don't know who defines that actually. So that's why, well, I have to defer to Maarten here. So just but concluding, this is all new to us. It's not a familiar place to be for software engineers, for network engineers, is in this policy and governance or in this well, there are more and more regulations are coming to are being made by the European community. And I think it's a call to you all to think about what's the impact to my business, to my organization, or to the products I use, and think about what you can do. So it's also, I think regulations are not bad, but we need good regulations. So, and I think it's a kind of a shared interest in all of us and a responsibility to monitor the activities and to give feedback so that we get good regulations. But there will be regulations. And I think that's very important for you all to understand. Okay, thank you.
Thanks to Benno, Bastian, and Robert for their presentation. Now we have a presentation on the new encrypted protocol stack and how to deal with it by Bert van der Velde from Cisco.
You got that right. Thank you.
The floor is yours.
So it's a real pleasure to be here today and talk to all of you, the RIPE community. It's my first time I'm here, and I'm really happy to see there's so many people showing up. I'm going to try to talk to you a little bit about the new encrypted protocol stack that we're seeing heavily being used by application content providers across, all these networks that you today operate. We collected a set of data points, snapshots across the world over the past couple of years, which I'll share with you, and then I'll talk about some potential ways of dealing with that kind of traffic. But before we get started, I just wanted to make a call out in memory of Mark Gallagher, a dear colleague and friend of ours that I actually started this work with a couple of years ago. He sadly passed away in 21, so we always keep him in mind when we talk about this topic. So as I said, I'll talk about some data points of traffic analysis that we see, talk about the implications that we think are out there, and also discuss a couple of aspects that you could use to deal with certain sets of use cases that we've been seeing from several operators across the world. So let's talk about how the internet really looks today. In 2020, this was really the start of our investigation. We got a very large data set from an operator, fully anonymized, just packets in, packets out kind of a view, where we did some analysis on, and these are kind of the top level conclusions that we got. Essentially, all of the internet is encrypted. Over 90% of the traffic payloads are encrypted. A huge, very important concentration to a very discrete set of large logos that you see here. Over 70% of traffic going to the cloud. So the notion of a very distributed internet with content sitting everywhere is kind of a thing of the past. And you essentially have elephant destinations sitting out there as where all the traffic gets siphoned to back and forth. And then very importantly, a large amount of the flows, around 50%, is effectively DNS traffic. So DNS has become, the total content load balancing mechanism for traffic to, arrive on your mobile phone or on your PC. And then a very important thing we picked up on, and we'll talk about this in more detail, is essentially at that point in time, we saw 20% of traffic being run over QUIC. That's with a C, not with a K, right? And we started kind of digging into that and started tracking it. And QUIC is a protocol, it's an IETF, fully standardized, that runs over UDP. So it's kind of a change from the TCP/IP stack that traditionally has been used. And this chart, we show a few snapshots of how the volume of traffic is morphing more and more towards a quick delivery mechanism. So in 2020, we did a snapshot, that's the 20%. 2021, we saw it rising. And today, as we take these snapshots of various operators in LATAM, Europe, North America, we see the traffic hovering around, the 40–45% range in terms of volume. So undeniably, this is a piece of technology that is being extensively used on the internet, and it cannot be ignored if you're thinking about, how to deal with your network environments. So a bit more digging in on data. The big 5 logos generate around 48% of traffic, the usual applications that you all have installed on your phones. QUIC roughly in this 2022 snapshot was 40%. And for the other destinations, you slowly started seeing, QUIC adoption happening as well. Now, it is less chatty, even though it's been designed to have very efficient interactions between, client and server or application. But in these applications that we see, essentially, it's being used for very heavy bulk transport of video-related visual traffic, right? High bandwidth traffic. So you still see a lot of chattiness or more flows in the TCP camp. In case you had any doubt, we do see consistent patterns of this utilization across the world. There's ranges. This is not a scientific study, obviously, but I think it's good enough to see that the trending is out there, growing adoption of QUIC, growing consumption of QUIC-based traffic across the globe with, the US snapshot, you have here LATAM and EU. Now, what's important to note, and this is a source from Jeff Houston, who's, I think, speaking this afternoon. There's a bit of a different philosophy behind the two protocol stacks. TCP was essentially designed to create network fairness, to have, in case of congestion, applications back off, and you get a nice distribution of available bandwidth to the various users of the network capacity. While if you look at QUIC behavior, it's essentially very, very heavily targeted towards my app performance. If I'm an application developer, if I want to get my content to end users as fast as possible at any cost, you will gear towards using a QUIC stack typically versus a TCP/IP stack. And there's various tidbits of information. For instance, Uber did a study on how their app reactivity is or reaction time is on heavily congested mobile networks, and they essentially decided to flip their application completely to QUIC, just because it is better when things are tough out there on the network, and they want to actually get the user experience to be above par compared to others on the network. So, we have to think about, when we design IP networks, how we deal with this. So I kind of highlighted this already, but I think it's very, important to emphasize, right? These large logos that generate around, 50% of traffic on your average internet link, they've switched for, all intents and purposes fully to Quick. It's 80% of their traffic is generated on Quick. The biggest holdout today is Netflix, who has a super optimized TCP/IP stack for their content delivery. Now, this is not all. It's not just a Quick, right? When we talk about a fully encrypted protocol stack for application delivery, there's actually, three main pieces to the puzzle here, right? You have Quick that runs over UDP that serves H3, HTTP3, but you also have encrypted DNS. DNS over HTTPS is being used extensively by the applications I just cited to essentially draw all DNS control back into the application provider space and essentially manage the content delivery 100% from the application view and not leave it to anybody else to deal with, right? So this creates another level of obfuscation and visibility that goes away in your networks. And then there's further plugging of holes, if you wish, or plugging of visibility points if you look on the wire that are being encrypted away, I would say, with encrypted SNI and encrypted client hello and various other efforts that are ongoing, which really makes traditional deep packet inspection, where you look on the wire and you see some of these control elements flow by in the clear, makes it very hard to actually keep up with. And you need to look at other methods to manage traffic if you want to, effectuate a level of quality of experience or fairness on your networks. So this is an interesting snapshot. Again, you see Facebook pretty much flipped overnight their full application to Quick. They were on TCP for a long time. Then they invoked Quick, and essentially an upgrade on the mobile phones generated 86% plus traffic. And YouTube, who was kind of the spearheading Quick development historically, obviously is very high up there in the percentages. So this is kind of a slide for the people that are skeptical about this and say, hey, this is just a thing that's, a fashion thing, is going to go away. We'll have a different fashion next year. All these logos that I have out here are actively working with or on applications that run on this protocol stack. So this is not something that we think is a fashion du jour at all. And you'll see it, I think, much more appear in enterprise type application space than what we've seen in the past. Because I talked about mostly, consumer traffic here, but we see a trend in the enterprise space as well. So I have a few suggestions on how to potentially deal with this based on a set of customer input that we gathered over the past couple of years interacting with customers who essentially say, hey, I have certain delivery contracts with end customers. There are, there's holes coming into those guarantees that I give. What can I do about it, right? So, for instance, managing video streams versus video downloads with the same, application space behind it. I can't differentiate. Accelerating delivery of, certain aspects of Snap was one of the things we got. Account for encrypted traffic in terms of source destination when it's effectively they sit behind CDNs and you can't see the SNI, things like that. More generically, we see a lot more questions coming up on, how to manage these flows, mitigate impact on congestion in, for instance, radio networks or other access networks for, guaranteeing and creating a level of fairness between the users they are serving. So one thing we thought about is essentially you can profile in the time domain various applications or categories of applications where you can differentiate between, if you look in time on, how a video stream is behaving versus a quick video stream. They have different patterns on the network, or, live video streaming such as a Zoom call or a WebEx call or YouTube TV versus, downloading of content, right? So time domain is really a critical aspect to take into account when you actually want to look at encrypted traffic. And you can essentially build models which will help you to categorize your observations into certain sets of application categories, which will give you a better level of granularity than you would have if you just look at the bits and you don't have a way to model against time behavior, right? So that gives you a bucket of categories. The next thing that we think is critical is to essentially understand how you can, how applications are running into congestion, how your network is behaving under congestion. You can look at essentially behavior of that time domain, how it's backing off, how it's speeding up, and therefore infer that you have a flow that is under congestion, and therefore you could potentially take action. Obviously, if you want to create some level of fairness or quality of experience on networks, when everything's running smoothly, everybody gets his fair share, and there's no congestion, there's no need to interfere, right? Now, and then as a third piece, once you have that information about the link that you're looking at, what kind of various application categories are flowing on it, and you can detect certain flows being under congestion or not, you can essentially start looking at some of those flows and apply a set of traffic management rules should you wish to do so, right? For instance, elephant flow management, and I'll talk about a few use cases in a second. So we think that a very important part of the toolbox of the future is going to look like something, a chain like this, where you can only look at IP header information, look at the protocol source IP, gather as much data as you can, look at the volume that is being generated by that flow, and look at the time domain as to how those flows are actually behaving on the actual wire that you're looking at. Then do the categorization and infer what's being actually dragged across those links. Decide whether there's a level of congestion happening in those downstream networks that you're actually looking at, and decide on a policy action to control, create fairness, shape, drop, etc. traffic, so that you optimize your delivery mechanism towards end users. So a couple of examples where you could apply this technology. I think first of all, we generated visibility, and I think visibility is a critical aspect of network planning. This kind of toolbox could just simply passively generate a set of data for you in networks that is extremely useful. You can start figuring out what's going on and use it for planning purposes, etc. Then secondly, you could, we've had questions to actually do custom policy enforcement. What we mean with that is essentially if you have flows going from the same client to the same destination, but they are actually different application aspects or simply different applications, you could start differentiating between, for instance, downloading of videos versus streaming, and then apply a different level of policy without affecting the end user experience, but rather make sure that everything gets pulled through. This is explicitly interesting in networks that are dealing with scarce bandwidth. So typically mobile networks, we see a lot of activity around applying this kind of thing. And another example is time domain. We call it time domain shaping, where essentially you optimize the user experience under congestion. If you have massive YouTube videos running on your network, because of the nature of those kind of video streams that do very heavy buffering onto the endpoint, you can actually invoke, once you've detected congestion on the network, invoke to that set of the network that is using a lot of bandwidth, the YouTube video, a level of shaping, not doing any dropping, but essentially pace the speed of delivery of the running videos towards the end user. He won't notice it, but at the same time, you will be freeing up time slots, for instance, on the radio network to deliver other content to the same or other users that's sitting on the same cell, right? So this is a very handy technique to start improving the level of utilization you have on the network, maintaining the level of quality that you want to give to the end users on those cells. And we've seen variations of this also in the peering space, where you have broadband. In this case, I call it a broadband service provider, ISP, that accesses end users over wholesale access operator. They're interconnected with a committed information rate, an SLA that has certain bandwidth settings. If you have congestion, essentially as a ISP going into those networks, you have only one choice, which is just burst above the SLA and pay more. Or this is the bad scenario, you start dropping packets, you get more retransmission, and effectively you're not helping yourself nor the customers you are serving, because you're essentially indiscriminately dropping packets. You can't actually see with normal techniques what's going on the network. So applying some of these techniques to such a situation, you can start picking out heavy bandwidth applications, start pacing them, slowing them down without actually affecting the delivery of the application, letting other traffic go through in that time span that you're shaping traffic. So that's kind of a level of smart congestion alleviation you're doing, which will give you in return less interconnect fees, less SLA violations, if you say it negatively, but you will end up getting more bang for the buck on the interconnect. And another use case we've seen is essentially an ability to look at a set of flows on the wire, figuring out you have a set of real-time collaboration applications going, and making sure you carve out enough bandwidth for those, where you limit the amount of traffic that's being consumed by big flows that would affect that real-time collaboration, and essentially generate a nice conditioned bandwidth envelope for the real-time collaboration apps versus other traffic that you have on the same links running. So in short, we think that time domain observation, IP header inspection, and building models that understand from that data set what is going on in the network with a scalable flow management system behind it is something that can help generate fair use on networks, and not ending up with a few applications consuming all of the capacity, reducing, the quality of experience for some and leaving it for others. So this protocol stack is a stack that we think is here to stay. I think Jeff on his blog recently said it's going to even become bigger than TCP very soon. So we all need to think about how we can work on this kind of traffic management in a way that benefits the end users on networks. With that, thank you. I'll take questions if there are some.
Maria, developer of BERT. I'm having a question about your comparison between QUIC and TCP, let's say it like that. You are saying that QUIC is like rising and taking over the domain of TCP. Do you think that it's going to eat TCP completely? Or are there some parts of the internet like, well, let's say SMTP or even BGP, this is also over TCP, that will stay at TCP?
So I left my crystal ball at home. Let me start with that, right? It is very clear that it continues to grow. Where this will stop, I think, is anybody's best guess. To me, the biggest attractiveness of the setup is essentially that if you use a quick DOH stack, let's call it, as an application development entity, you pull everything into your user space. You define, what scheduling mechanism you're going to use, how you're going to load balance, what artifacts you're going to distribute across the globe, et cetera, and it becomes really, really compelling. Does that mean that everything's going to go away? Other protocols, probably not, but it's definitely going to go, beyond 45% in my opinion.
Hi, this was a great talk. Thank you so much. This is one of the ones that I really came here to see. My name is Trey Darley. I work in the cyber resilience space for Accenture Security. I'm also on the board of directors at first.org. So this is kind of wearing both hats, but I'm not speaking on behalf of anybody. It's a question. I've heard a lot about QUIC. There's a bandwidth traffic management aspect to this, but it's being driven, I think, predominantly by sort of content delivery needs and privacy concerns. And a lot of the criticism I've heard, the sort of what if-ism, what about-ism, has been sort of like mainly two things. Like, as a company or institution, this is going to break all of my bumps on the wire for security controls and on the hosts. It's going to disrupt everything I do from a security perspective. And then as a parent, I'm not going to be able to stop little Johnny from going and looking at, I don't know, elephant safari slaughter porn or something. I don't know. I'm sure it exists. God forbid, don't Google that, because I think I just made it up otherwise. So my question is, I guess, to you, but also to anybody in the room from some of the big vendors who are kind of pushing this protocol shift. Many of you work for companies that also have security needs and have security offerings. So if this is going to displace a lot of the security controls on the hosts and on the wire, what are your companies anticipating to replace this with? And also, having kids, this is a let's take this offline kind of question, but I suppose there are people in the room who can come find me on the coffee break and educate me more about these two things. And if you have an answer, thank you.
So I think who's securing what is essentially a question of where do you sit in the food chain, and what does that then mean in terms of security. And if you look at this stack, it's essentially a TLS 1.3 environment, right? And so people will argue that if you're at the endpoint of that encrypted tunnel, you can do security, right? So what a fact is that in the middle, opaque, don't have to ask anybody security capabilities just got like X times harder, right? That is a fact of life with these protocol stacks. Now, does that mean that there is no security anymore? No, I think it means that whoever holds the keys of those encryption environments can actually invoke security, right?
But it sounds like you're saying that we have to move more.
I'm sorry, but I actually have to cut it right now. If you have any questions, please join the speaker.
I get the.
He's here.
I get the.
Because we're actually running short of time. We have 3 lightning talks. So I'm sorry, but we have to close the queue. Sorry.
I'll be around. We can talk.
So thank you, Bert. Our next speaker is Elisantila Gatti and Nikos Kostopoulos from National Technical University of Athens. They'll be presenting about enabling distributed configuration and control for WiFiMon probes. The floor is yours.
Thank you. Hi, everybody. What a huge stage. You look great from here. I am Elisantila, and I'm a WiFiMon service owner, GN51 project. Today, I'm going to show you a service that will help to see, understand, and feel your Wi-Fi. Can you help me, please? Yeah. Okay, thank you. But what is WiFiMon? WiFiMon is an open source Wi-Fi network monitoring and performance verification system, which is vendor independent and transparent to the Wi-Fi network users, which means that measurements are automatically triggered upon visited a monitoring website, and which is more important, there is no need for end users to install any applications. It is independent of Wi-Fi network technology, and it captures user experience. It also provides metrics like download and upload throughput, link quality, and signal strength. But how WiFiMon really works? WiFiMon relies on 2 monitoring data sources: crowdsources measurements from end users roaming the network, and also hardware probe measurements from fixed network locations. Who is it for? Many NRNs have shown interest on using these services, and some of them are using like SNet and Rush. Lately have shown interest also Switch. WiFiMon can be used in network technologies or laboratories, like NetMod laboratory in National Technical University of Athens. It can be used also at conference venues, like GIAN Symposium 2020 and TNC 19, that we had pilots there that were considered successfully. So why not? You can use it here. Let's see a brief history of WiFiMon. In 2015, the idea of WiFiMon is born, monitoring the performance of Wi-Fi network as experienced by end users, but without requiring their intervention. Presented at the community in TNC in Porto, TNC 15 in Porto. Complemented by hardware probes that monitor Wi-Fi performance per network access point. As I said, WiFiMon will be subsequently challenging by monitoring the conference venues at prominent GIAN meeting. WiFiMon pilots in TNC 19 and GIAN Symposium 2020 conference venues delivered promising results and lead to the declaration of WiFiMon as an official GIAN services. To offer better performance, WiFiMon is integrated with NMAS to codify some of its components and also automating WiFiMon installation. We have some additional steps. WiFiMon becomes more user-friendly by redesigning its user interface, and also support for eduroam. WiFiMon team is currently trying to simplify probe configuration and control, which I'm going to tell you today and present it today. So let's see. We have an old approach and new novel approach. Old approach is the picture on the left. We can see the administrator, the yellow one, and multi-type probes. The administrator should go to each of them, configure, for example, plug in and monitor, and hardware configuration would be required by the administrator. But on the right side, we have new novel approach required. One administrator from a center of point connects to the probes and everything happens more flexible. Administrators can configure and reconfigure WiFiMon hardware probes from the WiFiMon user interface. It can provide data like device identification number, location information, etc. And also configuration files by using Ninja templates. By using Ninja templates, network administrator go to the new user interface that we have redesigned and developed, received input from the users, and it controls where brackets are and substitute them with values. What technology or infrastructure have we used? Solution is based on SALT infrastructure management tool. We have also WiFiMon analysis server, that it is a device that manages everything, and it's called master, so SALT master. And we have also WiFiMon hardware probe that are devices that are managed and are called minions or SALT minions. What are the advantages of using this technology or solution? SALT established application layer. So using SALT, you can find the probe behind the NAT without knowing IP addresses or using names. So public IP addresses are not required. We need an IP address, but not a public one. The second one is SALT includes a 0MQ message broker. We have a queue that receives messages and a need to distribute to the client. So if you see the picture before, we had 3 probes. And if you want to configure them from a central point, everything will happen in parallel. But if we use an Ansible playbook on Ansible, administrator should go to each of them. To the first one, make the configuration, then to the second one, make the configuration, and so on. By using this message broker, all configuration will happen in parallel. So if you have 3 probes or 1,000 of probes, everything this requires the same time. And the third one is configuration files generated from templates are transferred from WiFiMon analysis server to the probes. So we are using this tool to copy files from the SALT master to the SALT minions. Some of our future work: automation of probe installation is one point, machine learning for performance prediction, and the last one, more visualization options. I want to thank you for your attention. If you have questions, we are here together with my colleagues, which is online, Nikos. And if you are interested, we are also here to help you using this nice service. Thank you.
I don't think there is any question from the audience, but if you want to have any question and discussion, I think the speaker is here during the weekend, during the whole week. So thank you, Alessandra. Our next presentation is about Bogons Observatory by Lefteris Manasakis by CodeBGP.
Thank you very much for the introduction. I want to thank the program committee for giving me the opportunity to speak in front of you today. Today I will speak to you about Bogons, a topic that I came across like almost 20 years ago, and I was fascinated about it. And since 2 years ago that we built CodeBGP and we started the CodeBGP platform, which is a BGP monitoring service, a few months ago, I had the idea that we can use our platform to study the Bogons. But because if you want to study the Bogons, the first thing you need to do is to identify what a Bogon is. So Martians are private and reserved addresses reserved by RFCs, defined by RFCs. Traditional Bogons, according to the Team Camry website, include Martians and prefixes that have not been allocated to a regional registry by the Internet Assigned Numbers Authority, by IANA. And the full Bogons contain the traditional Bogon prefixes, but also include the IP space allocated to the regional registries, but not yet assigned by them to local registries for both IPv4 and IPv6. This is a list of IPv4 Martians, which is heavily inspired by the BGP filter guide of Enalnog. And this is a list of IPv6 Martians, again, inspired by the same website. Now, for Bogon autonomous systems, the idea is the same. An AES should be termed as Bogon if any of the following conditions is true. It is reserved for a special use by an RFC, for example, private AES. It is not part of the block assigned to a regional registry by IANA, or it is not assigned to a local registry by any regional registry like RIDE, for example. This is a list of reserved and unallocated autonomous systems. And why we care about Bogons is a question. They are usually the result of configuration mistakes. However, they are also commonly found as the source of various types of internet misconduct, such as DDoS attacks, hijacks, route leaks, and other types of nefarious activity. They have also, we have anecdotal evidence of events that resulted in outages that were caused by Bogons. And in order to study them, we will use the BGP monitoring service we have developed. And we use BERT2, and I'm happy to see Maria and Andre here in the audience for our routing daemon. We use route reflection and IBGP because we want to know for each update where we got it from which router in the world we got it from. And by using route reflection, the next hop is not altered, so you get the information. We gather all the data in route collectors, and in order to forward all the data via BGP to the CodeBGP platform, which resides on the cloud, we use the BGP add path capability. This is some numbers for our peerings and the geolocation distribution of our routers. And this is a graphical representation of what I just described with words. The monitors being connected with the route collectors and the data are being propagated to the CodeBGP platform. And you are able to view Bogons in real time, basically. You can see in real time using the platform who's announcing, who's propagating Bogons, who's accepting Bogons. So the CodeBGP platform is configured to monitor full Bogon prefixes, as I defined them in the previous slides, both for V4 and IPv6, and Bogon ASNs anywhere in the AES path. And this results to routes that can almost also have RPKI valid prefixes, but because in the AES path there might be a Bogon AES, for us this is a Bogon route. And if you go to the UI, the platform, you will see more than 100,000 routes currently that are Bogons, and this is one of the reasons why there are so many. The methodology for this study, so I had I was in the taxi, and this is a funny story. I was in the taxi during DKNOG in Copenhagen with my friend Max Tucci, and I was pitching this idea to him. And I told him, how can I identify Bogon AESs? And he said, that's very easy, typical Max, way of talking. This is very easy, I will show you. So RIPE-NCC publishes a CSV file which contains the prefixes and AESs that have been assigned to local registries based on data gathered from all 5 regional registries. A script checks every hour, it downloads this file, identifies the entries that have been either available or reserved, and creates 2 lists, the Bogon prefixes and the Bogon AESs. And these 2 lists are used to update the BERT filters of the core BGP monitoring service. I should say that the list is huge. It's almost 300,000 prefixes and millions of AESs, and BERT does not even break a sweat. And these Bogon AESs and prefixes are forwarded to the platform via BGP. This is the URL for the file. And this is how the file looks like for the reserved and available autonomous systems, and also for the prefixes. We have open sourced this methodology basically. We have a shell script implementing the methodology in this URL, a BERT template, a Python script you can use to extract Bogons from RIPE and route views MRT dumps without even having to have a router. And readme with detailed steps, you can use this URL and play with the Bogons yourselves. Or you can get access to our platform following these steps, and you can see Bogons in real time, whose basically we can use the Bogons instance to make sure we don't announce or propagate Bogon prefixes, make sure we don't use or propagate Bogon AESs, and figure out who does it, and let them know so they fix their announcements and filters. These are some screenshots from the UI of the platform, where you can use, for example, in the routes table, the AES path filtering, where it also supports regex, I must say, where you can filter for your own AES or any other AES to see which routes might be present in the Bogons tenant that are Bogons and contain your AES. And you can also use the on-mouse over functionality in the UI, where you can use RIPEstat and go directly to RIPEstat and other sources of information like Cloudflare Radar to see more information about each route, each prefix, each AES. Same for the prefixes. The prefixes table, I must say that, as I said before, contain the prefixes that are present in Bogon routes, but themselves, the prefixes, they can also not be Bogons themselves. They're just present in Bogon routes in the UI, just as clarification. Next steps, we will conduct a measurement study. We have already developed a team that will conduct a measurement study for the Bogon phenomenon that can hopefully result in a presentation, in a publication. Try to correlate Bogon data with DDoS attacks, BGP hijacks, and other types of security-related events. And we will seek funding for develop methodology and automation that will periodically inform people about their misconfigured BGP filters. The goal, of course, is an internet with less Bogons. This is a slide with the references for this talk. Thank you very much for your attention, and I would love to hear your questions.
This one worked, that one didn't. Hi, Antoine Vuren, Liberty Global. We had a discussion yesterday, right? I have a problem with the full Bogons. There is a recommendation to filter on full Bogons. When there were traditional Bogons, this was easy. The list was actually quite static, and you didn't need any automation. You only needed to do this, every half a year you would update your routers. With full Bogons, basically, this list fluctuates so heavily that you need to update your routers automatically every 24 hours. And very high distant routers in our networks, this is almost impossible to automate. There's also the question of who's authoritative for maintaining this list of full bogons. Okay, RIPE publishes this CSV file, but I haven't read any best current practice or any documentation that this is the authoritative list of what a full bogon is. Tim Kimru does a great job offering tools to acquire the list, but it's not always matching with the CSV file that the RERs produce. So I actually have a proposal, and this is a very simple one. Why don't we have the RERs put an RPKI ROA to AS0 for all the prefixes that are unallocated? In that way, I don't need to implement automated code for all my routers. The RERs are responsible anyway for defining what an unallocated prefix is. They only need to put a ROA to AS0. I'm already doing RPKI validation, so I will block the full bogons.
As I told you yesterday, sounds like a great idea to me, and we should take it further.
Guys, I'm sorry, it looks like we have 5 questions and we still have 5 potential questions and one more lightning talk speaker. So maybe I'll let the first, I think, you want to step back?
Yeah,
because otherwise I'll let...
I have a very quick question,
Right.
Andrea Bashevsky, Internet Society. Why didn't you use the full bogon from Tim Kimru and develop your own?
So originally the idea was to use this list of prefixes. It has 2 issues for me. The one is that it contains only prefixes and not ASs, so it's not the full list that I wanted. And also, when I asked for Tim Kamrik, who are very good friends of mine, and I really like their work and everything, when I asked them, how do you produce this list? I didn't manage to get an answer. So I could not use it for research because I cannot support it. That's why I didn't use it.
Yeah, sorry guys, I think it's a bad timing on our part because of the longer presentations, but I appreciate your research and I know you have a product behind this. So yeah, we still have one more speaker though that I'd like to hear. It's, yeah, thank you. Hi, yeah, and I hope we can catch with you. It's please Peter Thomason with the deSEC project about secure DNSSEC hosting. If I'm right, you are sponsored by RIPE Community Fund.
Yes, hi.
Go ahead.
Which is the button?
Middle one.
Oh, yeah, the green one, okay. I think here, yeah. Okay. All right, who thinks DNSSEC is easy? Okay, so some people have misconceptions. I'm not telling you which ones. I mean, which people, not with whatever. Okay, so as you probably know, for DNSSEC, you need to do 2 things. You need to validate signatures, but you also need to secure the delegations, because if they are not secured, there's nothing to validate. According to EPNIC, the global rate of validation is 31%. I don't know of queries or resolvers, but whatever, it's a decent number. What do you think is the secure fraction of secure delegations? 2%? Who bids more? Okay, nobody bids. Anyway, it's 7% according to the source at the bottom. And the validation rate actually depends much on the country. It's 31% overall, and in Germany, for example, it's 70%. I don't know, the Netherlands, probably, I would think in the same ballpark. I was surprised about Russia, and Saudi Arabia has even 99%. Why am I telling you this? Because if the delegations are insecure, there's nothing to validate, and there are only 7% secure delegations. At DESEC, we think that should be ramped up, and we get support by RIPE for doing that, which is great, and which is why we got invited to speak here. So I'll tell you a little bit about our project. So as you already said in your initial reaction, DNSSEC is too hard, and most people who tried to use it know that, and that's why we try to make it easier. And the way to make it easier is to do a managed DNSSEC hosting service. At least that's our approach. So think of it as Let's Encrypt, but much smaller and also much less funding, and also not for TLS certificates, but for DNSSEC. So you can just create a zone with us and configure things, and you don't have to, I mean your records that you want to put in the zone, and you don't have to deal with any DNSSEC stuff. We try to automate all of that as much as possible. So it's fully automatic. We think we have the fanciest graphical user interface on the market. I will show you. And we support some modern stuff like Dane. We also have a dynamic DNS service under ddyne.io, which initially was our playground before we started doing serious hosting. We started and released the service in April 2020. Since then, it's grown quite a lot, and we are a RIPE member, an IETF contributor, specifically with DNSSEC automation stuff. So how do you get the DS records to the parent, for example? That's a big problem. There's some work ongoing there. And we have some costs, which are server operations, Anycast networks, development, and all of that. And that's where we thank our supporters today. That is specifically RIPE. Okay, so this is our Anycast network. And much more interesting is our user interface and the REST API. So the slide here is space limited, so I decided to make a subtle point of showing our mobile screenshots. So the graphical user face is mobile friendly. It is quite straightforward and reactive, so while you type, things get validated. There is field level validation. So for example, if you look at the right-hand side, this is how you enter in our RSET of type MX for mail exchange records. And it's actually a hybrid between a text line and a multiple field form. So for example, when you receive an MX record in an email and you're supposed to paste it somewhere, that often doesn't work when there's multiple fields. But you can still paste it here and the software takes care of it. So it feels like a text editor with lines, but it still has field validation. It has 0 external resources, so you don't leak anything if you don't like that. We don't even have cookies, so we don't even have a cookie banner, which I think is also unique. Then we have a REST API. I will not get into the details here, but it's documented. It has helpful validation, and it supports advanced things like transactions with multiple record updates at the same time. It can do paging and token scoping and stuff like that. It also has MFA authentication. About the RIPE Community Project Fund, the question is how do we use it? So primarily we use it for the server operations, which we need for our primary and DNSSEC signer. We also have backup machines. Then there is the Anycast network, which we don't run ourselves because we don't have the corresponding ops team and not necessarily all of the knowledge to do it. So that's quite expensive. And we also try to push some development stuff like DOQ support and API improvements, for example, to make the token scoping more granular or for domain owners to be able to inspect the replication state per POP. Yeah, so that's what we use that for. And we're very grateful that RIPE is supporting us in the current round. This is it. Questions?
Yeah. Thank you a lot. It's a great project. You know, as a DNS geek, I like this. Please, folks, you have a minute or two, and I would say that please go to the RIPE86 ripe.net and rate every talk you have seen, or at least you plan to see. And that feedback goes directly to the presenters. So it's not just something that we collect and never use. No. Every comment you write, and you can write comments, would be sent by the program committee. And you can also apply to be a member of the program committee. We have still an hour and a half till 3:30 to be exact, so you can email to pc@ripe.net. So I don't see anybody stepping to the mic, so am I in any remotes? Okay, good. So we are done then, and enjoy your lunch, guys, and don't forget we have another plenary after this. Bye.
Apparently there's a question on the chat or something.
Yeah. Oh. There was, okay, good. Yeah, thanks. Nice project. Really, I love it. You know, we are DNS company, and maybe we'll partner with you, but.
The question is like, do you open source any or all parts of your platform or plan to? Do you open source any or all parts of your platform or plan to? Okay. I'm just applying that.
Yeah. You know, yeah, like this is play and this is what's like, oh. Okay, we don't need to. Yeah, okay, let's put it here. I think the confusion is that this doesn't really look like I agree. No, look, if it's not obvious to you, it's broken. Like, and sorry for cutting it short. It's like no problem. You didn't. The first part was DNSSEC, have to improvise and ask his colleague, and then he brought this lawyer who was at the end. And honestly, that was probably a better deal. If you get just two people, it'd be fine. Now with three, it's like 80% of the time. Yeah.
Yes, so I don't have a card, but you can even meet leaders at deSEC, yeah. So let's talk about your stuff too, and I'd be interested in collaborating on something.
Hey, nice to see you. Thank you. Did you just arrive?
No, like an hour ago, but yeah.
Yeah, I missed some DNS chapters. Yeah, hi. Oh, damn.
They will, people or the
Working with registries. Oh, I see. Okay, that is, I know, not that it's one of yours, but I know it's like clean DNS. I'm not saying you're the same, but it's like, I'm aware of the very simple things.
Several different systems. We're trying to consolidate all of them into a
Oh, I see. So you want to build like a forum for consolidation?
So soft structure, forum, discussions about.
Okay, I'll do it. Where are you located? In the States? Or?
I'm in the States, but we have offices in New York and Brussels.
I live in Rotterdam, but I'm not very no. I'll pass it on.
I'm actually
okay, I'll understand that because I'm not always sure which sometimes I don't attend every session first. Well, now I was moderating it. Okay, thank you.
Someone
And that is good. I would keep this in mind. So it's tomorrow afternoon, right? Or
it's actually right before lunch.
oh, okay. So just like this. Okay, I would make this a mental note.
Anyone at .ua would be interested in?
Yeah, I'm running the register actually myself. I mean, I'm well, I'm a technical lead, and I'm interested in this stuff. I'm not sure how we can elaborate if so. It's not a product. It's not a existing organization yet, but we plan it to be.
We actually have about 45 participants so far. We started. We have a knowledge base of about 2 million.
We lost about 20% of active nodes. We actually fighting this. Well, not fighting, but we try to incentivize people, but we can't really lower the prices now because of the economic downturn. So, when, like for example, I can potentially react to, let's say, weekly, monthly, well, maybe not daily. And for example, I build a system that write member to member, and like funnel, like you can say, subscribe to that member. My suffix, right? Subscribe to those three names, and updates will be sent to me in some reasonable API.
We have an API that allows you to access
so that I can download those updates and have some
whatever regularity you want to use.
Sorry, one of them, I think the yellow marking. Okay, this one, like I grabbed it from the back and it wasn't working when I was there. But maybe I have to flip. So maybe take care of this for the next people because I was really frustrated, at least with one of those. Yeah, it's okay. Maybe it's not your fault. I'm just saying, like, good. Okay, thank you.
Yeah. How is the bird multi-connected?
Hi. Ja, ik kon de knopje niet vinden. Ja. Hij heeft hem uitgedaan. Ja, toen is hij om de andere te pakken. Ja. Maar hij zei, nee, ik was zo gefrustreerd. Ik zei hier nog, weet je wat ik dacht? Ja, nee, dat is ja.
Hello? Hello, 1, 2, 3, test. Cannot share preloaded slides. Hello.
Nope. Yeah. Hey, Randy, we can hear you at least. Just give us a sec.
I think we have an ops team, but we don't have a control.
Or I can also, let me set this up.
Hello? Hello?
Yeah. Hi, Randy, can you hear me? It's okay. Sorry, folks. Sorry, we just need to get forward and back here. It's literally to here, unfortunately. It's not a great place to be standing. Sorry. Sorry? Yes, absolutely. Is this your Coke? It is my Coke, yes. It might be, yes.
No. Is there a button? Wave in this direction. Wave.
Oh, that's better. Thanks. Okay.
Please don't. Hello, Aaron. Hi. Brian, Wolfgang, so your chairs.
Yes, there is actually it's not necessarily minutes, but
yes. Sure, is busy with Randy because he should go to the demo, not to this version, because there's a grabber on this slide that you see behind, and that's why it's not done to be done live. It's done to be done by a demo.
We had done it live before, but apologies, that's my mistake.
No, but now we are communicating the link to him where he can do a demo, how to share his stuff.
I can promise 25.
Jeff, can you hear?
yes, you can see your slides in front. And there's a clicker over there.
Oh, there's a camera. Now I've got audio. Yay! Okay, so in theory, I am feeding audio and video.
Yeah, yes, you are. Cool.
Cool.
We'll promote you to speaker now in a second, Jeff.
As well.
Oh,
this is the timer, and there's also the time.
Great. Okay.
And like I said, in total it's 30 minutes, including questions. So if it's at 0, and this is the clicker for your slides.
Thanks. Yes, I did play with this a bit earlier.
So I will surrender the microphone and the video, I guess, somehow. Stop the video, mute.
Before the demo for Randy, I think it's important that we go to the demo room because at the moment these slides are using the grabber, so we cannot do a test behind with them because they are not here.
So it's a bit too early. Maybe we could do that maybe 10 minutes before.
Okay, I mean, that'll be fine as well. It's just I'm overly paranoid and I got people to come here early, so that's fine.
Yesterday I simply switched them on. It worked.
I mean,
I was so lucky.
It should be fine, but we want to reassure Randy that it's all going to work.
Yeah, I just chatted him that we're basically we need to meet ECHO people.
Yeah.
And I'll ask them in chat to show up here pronto because they were balance.
In your
okay, now Anna is the first speaker.
and in your queue, if you could promote myself and Wolfgang to appropriately know. System works. We know the system works. Do you want to start or?
Yeah.
Cool.
I'm getting used to that. I had a post on Mastodon recently. If any of my teachers would know that I earn my money by writing in English, they wouldn't believe it. And if you had told me that I would stand in front of an audience talking, me always stuttering when I had to go to the blackboard at school time, I wouldn't have believed it. So things change.
Very much so.
But I'm still the introvert.
I was saying that actually I used you as an example when I was talking to Doris yesterday about she was saying she's an introvert.
Yeah.
Well, not like Wolfgang.
I'm completely introvert usually, but I enjoy standing in front of a camera, making. Yeah. But I can do all these things if I have to. If I have to make a doctor's appointment, I can do. Are you logged into Mythical? Do you need to have access also to the OS? I can log in. I can log in now. So where is my? You want to come with me? Yeah. Trying to light it. What's the goodie bag? Oh, there it is. Where did I get that? Getting rid of
Your total time, 20 or 25?
The total time is 30 minutes.
Yeah, I know, but for
I put 20 on it and 5 minutes for the extension. You have to. It has two timers. I put 20 on the first one.
Okay.
And 5 on the second one, and I told her that 20 minutes is over. Doesn't mean she has to suddenly stop. But,
okay, cool. As long as we're all good with that, that's all good.
And for the online speakers, we have the online timer, which is visible once we are promoting.
Well, so where is that thing?
And usually what I did to the last session, I rather looked at the clock. So if the first speaker was finished earlier, I gave the second one more time and so on.
Yeah, that's fine.
I think we only ran over this morning.
So can I use some multiple accounts? I assume so, because it's not personalized code. I'm going to try it now. Well, I'm gonna.
Classes.
Yeah, because you get credits as a. No, you don't anymore, right? Because I can't find. How do I request? Maybe you can't, but you don't anymore. Yeah, it doesn't look like it. What the fuck? Anyway, right. Log out. Log in again.
Sound class at 1993.
This one is 2FA. After this talk, right? What was it? 3, right? E something 3. Yeah. Oh. Need to log in again once you click on enter. That's great. Great website. Yes. Oh. Yeah, 1 million is gonna do a lot. Wait a sec. Oops. Don't use your 2FA code as a code. Yeah, I have 76 million now.
That's right. Anyway.
Yeah.
There's no water fountain here in the room, right?
Ridiculous.
There is at the very back, yeah.
Well, it's not just probes. It's also I got some gifted at some point.
Can you hear me?
Yes, we can hear you, Randy.
Hear me?
Yes, we can.
Are you sharing your slides or sharing your screen, Randy?
Hi, Jeff.
Hi.
I cannot hear you.
Are you sharing your slides or
Nope.
doing a screen share?
Still no here.
Oh.
Gonna turn your microphone on?
My mic is on.
We can hear you, Jeff. So I'm just messaging Randy.
Okay.
The internet.
Okay, I just heard you.
Okay, great.
Show your slides.
I'm annoyed about the feedback. You didn't send me the feedback.
I see 2 DNSSEC.
Yeah.
Or not
so
2 DNSSEC.
we can see those slides in Meet Echo, and therefore it'll all be good to put them up. And we saw your slides in Meet Echo as well, Randy. So that seems to be whatever you were doing there was working.
Okie doke.
Okay.
Should I show my face while showing the slides?
That's entirely up to you. But yes,
But,
I mean, that's
it is conventional.
It's a thing people do, certainly.
I'm known for being conventional. Okie doke. Somebody still has a hot mic.
That's probably still me, but we can, if the lovely people would kill it for 10 minutes, that would be great.
Just warning you in case you were going to say something untoward.
I would never do such a thing.
Work for 2 weeks after. Certificate. So I'm never sick.
Hopefully not.
Yeah. It's me. No difficult questions. No, sorry. Yeah, it's a shorthand machine, so it's completely different to any other type of. Basically, it's learned the theory of the machine, and then built up your speed. So it's all short forms phonetics. So you to press keys together, not like an upper keyboard where it's one at a time. Yeah. So we look who the speakers are going to be, and we put in how we're going to write those names in one stroke. That's yeah. So yeah, basically it is. So a lot of people get offensive when they just can't catch it. You know, their forward names like that. We won't do. Yeah. Thank you very much.
Lightning talk in. What's the lightning talk in this?
Mary gave
Mary
that.
gave that lightning talk.
I think that was Madrid. She gave that was
Madrid, yeah. So, you want to check out the archive, Madrid. Mary.
Mary, yeah, she gave it, yeah.
Yes, I mentioned it.
Whatever, yeah.
There was no way I was able to do that anyway. Not that I offered her, that's Mary's paying, not mine.
77.
Yeah, 73, I think, possibly, but yeah, they all very bad at remembering numbers. Okay.
You're just in the UAE based. You think so? 73.
See, that's it.
Yes.
They can't see our type. Second show. Yeah, no, I know, but that's just for no, no, it's yeah, okay. Yeah. I'll ask him.
Yeah, but there's still stuff that is not ideal. For instance, with extension headers, I before did it better. I just did
Yeah. I mean, the only email address was only added in there.
No, we don't type this. I need to make notes for my colleagues. It's actually the new one with the Mac chip.
It's a new one.
Yeah, it's from 2021. I got this. No, 2022. Yeah, it got bigger again. It's got the MagSafe. It's got 4 USB-C and it's got the new Apple chip. It's very heavy. Yeah, but the smaller ones don't do really well with audio-visual files. They get slow. If you're editing a podcast or a video, it doesn't work.
I've heard only good things about the M2s.
Yeah.
I think this is an M1 though.
Okay.
I have an M1 studio.
The M2 is very like 24-hour battery.
This one's pretty good.
Okay. Let's get this started. Hey, good afternoon. I'm Wolfgang and I'm going to chair this session together with Brian here. And short announcement, well, I'm repeating myself, but hey, the plenary sessions are governed by the program committee. And if you want to join the program committee, there is still time to put your name forward. Just send an email to pc@ripe.net. And we will put you on the list and you can be elected and stand here at the next RIPE meeting. Good. It's 2 o'clock and we are starting the first afternoon session. First presentation is by Anna Kustura, and she's going to talk about what should networks do with IPv6 extension headers. Anna, the stage is yours.
Is this on? Oh, yep. Hi, everyone. I'm Anna. I'm doing a PhD at the University of Aberdeen. And there I specialize mostly in wide-scale internet measurements to help protocol standardization. Today I'm going to talk to you about IPv6 extension headers, and I'm going to present to you some results from a recent survey that we've done with RIPE Atlas. IPv6, pausing for effect. So as you know, it was standardized in the 1990s in RFC 2460. But what I want to point out with this slide is that it only became a full standard in 2017 with RFC 8200. So basically between the 1990s and 6 years ago, you have some years of operational experience that inform what made it into the full standard. To begin with, IPv6 promised a few things. It promised to fix the lack of IPv4 address space, and it managed to do that. It promised a simplified base IPv6 header that would lead to more efficient forwarding and routing. And indeed, the IPv6 base header is less complicated than the IPv4 one. It also promised improved IP packet fragmentation. And I guess in the original spec, the way fragmentation was specified was a little bit too complex, a little bit too flexible, and many RFCs came along, many refinements, so to speak. And so in the full version of the spec, you have a more constrained version. You have a more constrained way to do fragmentation because it was too flexible for not a lot of benefit. IPv6 also promised multicast, and I put a question mark because I'm not talking about local multicast, but rather interdomain, which never really took off, or should I say yet. And it also promised end-to-end security, aka IPsec. And IPsec did take off, but I mean, it was mandatory in the original IPv6 standard in RFC 2460, but is no longer mandatory in the full standard. And in the meantime, other ways of doing end-to-end security have emerged, like QUIC or VPNs. And finally, IPv6 promised extensibility, and this is what this talk is about. Notice that I'm pointing some arrows from fragmentation and IPsec towards extensibility because they are done via IPv6's extensibility framework, which are extension headers. Right, so extension headers, they are the filling, the sandwich filling, if you will, between the IPv6 base header and whatever upper layer protocol you have. And they add new functionality into IPv6. So you can have fragmentation via the fragment header. You can have IPsec via the authentication header or the ESP one. You can have different ways of doing routing by using the routing header. And then finally, the two extension headers that I measured and that I'm going to talk about are the destination options header and the hop-by-hop options header. So as the name suggests, the destination options header carries options, and these options are intended for your destination, for the end node. And the IP hop-by-hop option header carries options that are meant to be looked at by routers on the path, if configured to do so. Right, so look at all these amazing extension headers and all the functionality they bring to IPv6. Well, it's not that simple, because extension headers had a bit of a rocky start. There's many concerns around them, and they are all summed up very nicely in the RFC, in the title there, 9098. And I'm going to try to summarize it for you. But essentially, the first routers that implemented IPv6 did not have a way to process packets with extension headers in hardware. And so they punted all of the packets with extension headers to the control plane of the router via the internal link. And essentially, if you do slow path processing of extension headers, you open up your router to all sorts of denial of service attacks. That was one problem. Another problem is that extension headers, you can have multiple of them in what is quite a complex arrangement. And that led to implementations that have quite a lot of bugs. And so you open routers up again to the denial of service attack by sending them malformed packets with extension headers. The implementations were buggy because as IPv6 got adopted, not a lot of extension headers were going around. And so the code paths were not exercised a lot. And there's such a bug that was discovered even in the past 6 months. So basically you can send a malformed extension header packet to the Linux kernel and basically make it panic. That's the link at the bottom of the slide. And finally, because you can have many extension headers in the same packet, you can have an IPv6 header that is quite big. and that places extra processing demands on the router. So routers end up not being able to forward packets with these headers at line rate. And so that's yet another problem that extension headers can have. It comes as no surprise that many networks drop packets with extension headers. And some measurements done maybe in 2016 in RFCs in 7872 point this out. But the story may not be so dire after all, because now you have many of the problems that I mentioned in the previous slides have seen improvements over the past 20 years. You now have better hardware that can process extension headers in a more sensible way. And recently, within the past 5 years or so, you actually see renewed interest in extension headers. Many of them are being worked on and have been specified within the IETF. Probably the most widely deployed one that I'm mentioning here is the IPv6 segment routing type. And then the rest ones are a bit more niche, but they are all either destination options or hop-by-hop options that are used for some sort of telemetry or measurement. So you can have altmark, MPDM, and with that, these options you can use to measure things like packet loss or delay in your network. And then you have options described in IOAM, which allows you to essentially collect packet telemetry and operational information as packets flow through your routers. The last option that I mentioned here is quite special because all of the previous ones have something in common. They are supposed to be used only across an operator domain, so in a controlled environment, in other words, not across the internet. The last option here, the minimum path MTU discovery option, can be used to, as the name suggests, discover path MTU. And of course, then its scope is internet-wide. So the question that I'm trying to answer today is, can options be used more widely across domains or in the internet? So the way to find this out is through measurements. I will be only focusing on destination options and hop-by-hop options as I speak. And here are some measurements that have been done over the past few years. They all report different things. That's because they measure slightly different things and they use a slightly different methodology. But what they all agree on is that packets with extension headers don't really survive the internet 100% of the time. So I've done my own experiments with RIPE Atlas, and I've tried to also measure survival to begin with. The way to do this is I took all of the IPv6 enabled RIPE Atlas probes, and there's about between 5,000 and 6,000 of them, depending on time of day and so on. And I've sent out traceroute packets to 7 destinations, some of which I controlled. For simplicity today, I will probably only show results from 1 or 2 destinations at most. So yeah, you chuck packets across the internet, see if they arrive at the destination AS. I tested both TCP and UDP to see if there's a protocol difference. And let's see what we found out. Destination options. Well, it looks like many packets actually support destination options. They see a very high survival rate, between 90 and 97% across all of the destinations that I've tested. And here I'm showing you the results for the UK. If at this point you're wondering, but what option did you send? Well, RIPE Atlas allows you to only send one option, and that's a padding option. This one was specified in IRC 2460, so it should be well understood by routers everywhere. And we've sent the minimum possible size of option, which is 8 bytes. So for UDP, very high traversal rates. For TCP, not so much. And while here we're at the good end of the scale, we found a traversal of 70% for this particular destination. This varies quite a lot depending on where you're going. So I would say between 40 to 70%. But the transport difference is there between UDP and TCP. What about hop-by-hop options? Well, the story is slightly different here. While destination options survive many paths, hop-by-hop options only survive a few of them. The transport difference remains, so there's still more packets survive over UDP than over TCP. So I guess the next question that we asked was, Why? Why does this happen? To answer that question, we first look at per AS survival. So where do packets get dropped? Here, what we found is that overwhelmingly is the local AS that is responsible for most of the drops. So for example, in the case of destination options, the local AS, and that is the AS where the RIPE Atlas probes itself lives, drops maybe 5% of all UDP packets sent, 25% for all the TCP packets sent. And so if you think about it like this, you send packets on 100% of the paths, and then once they go through that first AS, you only get, say, 75% of paths still supporting them, in the case of TCP and destination options. For hop-by-hop options, the story is again slightly different. That local first AS actually drops up to like 3/4 of the packets that you send, or rather it drops all the packets for 3/4 of the paths that we tested. So local ASs are a problem. So next we try to work out what would actually happen if the packets would traverse that first AS. So in other words, are there any barriers for packets to traverse to the end of their destination if they were to survive it? So the way to find this out is we did the test in reverse. That is, we sent a trace route from our original destination all the way back to the RIPE Atlas probe. We can do this because most of the RIPE Atlas probes have public, and by public I mean global unicast IPv6 addresses. And we kept the protocol and the port the same. And the question was, does the packet then on the back, if you test it backwards, does it reach that first AS? And we found out that for destination options, it definitely does. So that means we tested around 300 paths where packets were originally dropped. And we found out that 97% of the test, of the reverse path test, were successful. So that means that if you were to eliminate those drops caused by the probe's local AS, you could improve traversal by quite a bit because there's no other obstacles on the path. So you could bring traversal up from, say, 92% to 96%. So that's great. What about hop-by-hop options? Well, there the story is slightly different again, because not all of the packets we sent on this reverse path did make it back to the original AS. You could still improve overall traversal. You could still double it if you were to eliminate those drops from the probe's local AS, but you couldn't necessarily bring traversal beyond, say, 25%. So the key takeaway from this slide is that transit networks don't drop packets with destination options, but they do drop quite a lot more packets with hop-by-hop options. Why does this happen? Well, you can have many different reasons. You can have weird router architectures that just simply drop packets with extension headers on site because they don't support them. More commonly, probably, what you have is network policy. So this is basically people, network operators, I mean, trying to protect their infrastructures with ACLs, trying to protect against the denial of service attacks and dropping packets with extension headers. And then you have different devices that like to look into your packet. You have things like load balancers, which often need access to the upper layer protocol. Basically, they want to know port numbers or something. And when they see a packet that has an extension header, then they just drop it. The next question we then asked was whether or not extension header size makes a difference to how it traverses. For this, the experiment remains the same, except the RIPE Atlas platform allows you to specify a size in bytes for the extension header that you're about to send. And we sent many different sizes. We incremented by 8 up to 64 bytes in size. And again, it's the same test. So survival is successful if the packet makes it to your destination AS. And we found out that, yes, there is like some sort of magical number beyond which packets with extension headers get dropped a lot more. So TCP sees the biggest drop in traversal at around, with extension headers that are around 48 bytes in size. And for UDP, that's shifted 8 bytes because it sees the biggest drop with packets with extension headers that are around 56 bytes in size. So notice the 8-byte shift between TCP and UDP. This almost kind of implies that the size of the transport header makes a difference to the survival of the packet with extension header. So how does that make sense? Well, we know the TCP header is larger than the UDP header, so maybe traversal has something to do with the total size of the IPv6 plus extension header plus transport header. Well, the fact remains that where extension headers can be used end-to-end, often you want them smaller than 40 bytes for them to get through. So they work if they're small enough, but we don't know why. And especially we don't know what the difference, why we see this difference between TCP and UDP. So if you have any ideas, let me know, and I will buy you a beer. Which brings me to the last experiment. This is the fun one, the novel one, as maybe you've seen info on extension headers and sizes before, but you've probably not seen this. The last experiment that we did has to do with load balancers or routers that do equal cost multipath routing. So basically you have devices in the internet that like to spread traffic on different paths. And then to do this, they use some information. They use maybe a source and destination port, and maybe they use a source and destination address. Port information becomes a bit more inaccessible because it is not in the same place if you introduce an extension header in the packet. So then, if you do add extension headers, does this impact the function of routers who do ECNB? That was the question that we tried to answer here. And to do this, we used Paris traceroute. Paris traceroute is essentially like traceroute, but on steroids. Instead of doing one single traceroute, you do 16 of them, and then you combine the results, and then you work out what the topology is between a source and a destination. This works because between each of the 16 measurements, you change the flow label in the source port, or at least this is what the Paris traceroute version in RIPE Atlas does. And so load balancers route you onto a different path every single time. So what did we find? Well, if we do a Paris traceroute measurement with packets with no extension headers whatsoever, we find a median of around 4 paths. This is great. This is exactly what we expected because essentially this reproduces the findings in the original Paris traceroute paper. But what we didn't expect to find is that as soon as you add an extension header into the packet, Paris traceroute starts detecting fewer paths. So essentially what this is probably due to is the fact that you get the load balancers that use a byte offset as a basis for their hash function. And in that byte offset, maybe they expect to find port information, but because you have the extension header there, they no longer find port information, and then they route you onto the same path. So that's why you detect fewer of them. This has some implications. It means that if you are going to use extension headers for something, you don't want to put them into the same flow. So basically, if you have a TCP flow that mixes packets with and without extension headers, you have to be quite careful because they might go on different paths because of this issue. Also, a possible fix for this might be to use the flow label, or to at least to mix the flow label into whatever function it is that you're using to route packets on different paths. But I will now give you a nice practical example of the problem that I've just described. So I will show you 3 figures. All of these are basically measurements of the same source destination pair. And the first one that says no extension header measurement is the vanilla measurement, the one measured without any extension headers. So Paris traceroute in this case discovers 4 different paths. And you can see there are 2 different load balancers there. And then in your second figure, you can see what happens when you add a destination option into the mix. Suddenly, all of the packets take the exact same path, possibly due to the problem I've described. Now, you'll probably not guess what happens when you add a hop-by-hop option on this particular source destination pair. And what happens is probably a bug or something quite unexpected. Suddenly, you run Paris traceroute with packets with hop-by-hop options. And that first router seems to basically enumerate all of the interfaces it has. So this test detects 14 different paths. This is clearly not expected behavior. This is probably some sort of bug, I would assume. But what it shows is that not all load balancers out there are necessarily able to cope with packets with extension headers today in the internet. So right, so now we get to the point where I answer the question in the title, like what should networks do with them? Well, if you have vulnerable hardware, so if you have hardware that you know processes extension headers on the slow path, well then you have to have some sort of firewall. And by firewall, I mean access control list in place to just block them, or block the ones you don't need, even better. If you have better hardware that doesn't do stupid stuff, then you don't necessarily want to firewall all of them. In fact, if you unnecessarily block extension headers when you don't need to, you can stifle innovation. So basically, you can discourage people from specifying new options. There's two things that will help this extension header story. One is better hardware, which I've mentioned, and the other one is having there's a few new drafts in the IETF that have appeared that aim to talk about how you should process them, and they aim to steer the discussion in a direction that would make it then easier in the future for these to be processed. So if the other question was, can we extend IPv6? The answer is, it is done right now. All of the options that I've talked to you about in the beginning, they are being used by people within their own domains. That's quite low risk because you control your own hardware and you know exactly what you're going to get. If you want to use extension headers in the internet opportunistically, well, you're going to have to wait a bit. Destination options are quite close. They are almost there because they traverse most of the paths. But for hop-by-hop options, we're just going to, well, have to wait and see. If I'm going to speculate, I think the operational experience that you're getting now from people who run these things in their own domains and the improvements in hardware will eventually translate. So if the right option comes along, you might as well see it go. And this concludes my talk. There are some references on this last page.
Okay, thank you very much. Do we have any questions? We do, please.
Hello, Jen Linkova. Thanks again, Anna. I just have a comment. I think I've said that before. So we traditionally, we operators, normally permit stuff which we need, right? So actually V4 fragmentation might be broken as well as V6 if nobody cares. So that's why I think people are slowly fixing fragmentation. People actually are using ESP quite, they will be using it more and more because every time you use Wi-Fi calling, for example, your phone actually established IPsec channel to a gateway. So as soon as you switch to V6 only network, you have to use ESP. And if you block ESP, you would notice it, right? So I guess it's, we shouldn't be putting the cart in front of a horse, right? There are headers which are used, and the reason we have them broken and filtered is because we have had the safety net of happy eyeballs. And I would expect the situation improve as soon as we start deprecating the legacy protocol in the network, like RIPE network actually almost did, right?
Yep, agreed.
Okay, please.
Mia Kulevin Erickson. Talking about happy eyeballs, did you test how stable your measurements are? Is it if you go like, if you measure it once on certain parts, it always stays like this? So if it's broken, and if it works, it works?
Yes, I've repeated my measurements a number of times, and yes, that is generally the case. Interestingly, when I did the ECMP test, what I found is that you actually do have a handful of cases, so not that many, where if a load balancer routes you onto a different path, that path may be broken. So basically 3 paths work, 5 paths don't, depending on where exactly you're going. You might get there, you might not.
So, I mean, to conclude Jen's comment, it's a chicken and egg problem, right? We have happy eyeballs, but it makes it work, but, you know, it makes it more complicated and whatever. I don't know what to do.
Yeah, I think maybe we need the right option to come along.
Okay. In that case, thank you very much. So our next speaker, who is coming to us live over the internet, is Jeff Houston from APNIC, and that's an incredibly slow fade to black. We have Jeff, excellent, and we have some slides. And so Jeff will be asking the question, DNSSEC, yes or no? Please take it away.
Thanks for that, Brian, and good afternoon all. My apologies for not being able to be with you this week. I would have liked to, I almost got there, but family medical emergencies intervened. But here I am. You know, over the last few years, I've become fascinated by technologies that just don't quite work the way we thought. And, you know, if you sort of look at that, what hasn't worked the way we thought it would, you'd think IPv6 would be the major sort of area of study, and you'd probably be right. You know, 30 years later, we're still running a whole heap of V4, and V6 is still just waiting. And it's kind of how much longer? But, you know, let's move along a little bit, because you've already heard about V6 this afternoon, to another absolutely fascinating topic, which is the DNS. And this whole issue of how are we going with DNSSEC? Because, quite frankly, it's not working the way we thought. I'm like, why isn't Google.com signed with DNSSEC, or Amazon, or Facebook, or Microsoft, or a whole bunch of other domain names? I'm like, if DNSSEC is meant to be so great, why aren't major internet enterprises using it? Are they just ignorant? And the fact they're not using DNSSEC is really just, oh, haven't heard about it yet. Maybe on Thursday we'll get around to it. Or there are real reasons why they're not. And if one group of folk is saying, look, DNSSEC is actually really very, very useful, you need to do it. If you want to get a new GTLD through this ICANN process, you have to DNSSEC sign that top level name. So some folk are going, yay, yay, this is great, just do it. But there's a whole bunch of others that aren't. Why? Why the mixed signal? And I'm kind of fascinated with that. You know, why do we sort of look at this technology and think, well, you'd think that having a mechanism that says, this is the answer, and the DNS said it, and you kind of go, yeah, really? Having a mechanism to go, is that a lie or is that the truth, would actually be really helpful. You'd think everyone would want it, because, you know, the internet's a really hostile place. You know, if we turn the lights off, it'd glow in the dark, it's so bad. So, you know, you'd think having some mechanism to actually say, this is a good answer, we'd all be going, yes, I'll have 5 of those, this is fantastic. Yet there are a bunch of folk, big enterprises, major enterprises, who sit there and go, yeah, but no. So let's have a look at this a little bit. And what I want to actually look at is the case for and against. So what's DNSSEC in one slide? There you go, DNSSEC in one slide. Hope you're a speed reader, because it's gone. The case for no, I don't need no DNSSEC. And part of the issue is, despite all of us saying keys are easy, keys are hard. Keys are really hard. And quite frankly, we have a whole lot of trouble keeping NS delegation records in the DNS properly tamed. So this whole issue of actually trying to deal with keys, whoa, we trip over our feet constantly. There's a website there that just logs them as they come. And quite frankly, I don't expect that website to go, you know, out of action anytime soon. The mistakes just keep on coming. How often should you roll your keys? You're a zone admin. Every 6 months, because you need to keep the practice in. Wright first tried that with some of the keys on their reverse zones. And they found every time they rolled the keys, the query traffic just rose and rose and rose. Because there are a bunch of people out there that were getting pre-canned configurations that had these keys already built in. And every time they changed their key, it's going, whoa, don't like the answer. So sometimes regular rolling gets you into trouble. On the other hand, if you roll infrequently, like say every 5 years, like the root zone key, then every time you do it, it's a new adventure into the unknown with new stuff and new procedures and new ways to stuff it up. So in some ways, it's not easy to figure out how to actually do that kind of, you need to do this regularly, but not every day kind of thing. So we're still not sure how to deal and manage with keys. The procedure for passing part of my key upward to my parent, you kind of go, well, it's just like an NS record. It's like a delegation record. You just hand it to your parent. We have built an entire industry over there in the registry, registrar, ICANN land about trying to get the NS records right. And it's an incredibly complex process, EPP the lot. And when confronted with, well, let's just add DS records to this, everyone just throws up their hands in horror. Can't do it. Really difficult. Don't know how. Because all of a sudden, we're confronted with yet another problem. The processes of doing it with semi-automation and polling. You know, it always strikes me as bizarre that whenever you get a mechanism where you can't do explicit signaling, the first thing everyone reaches to is unconstrained, uncontrolled polling. Probably the worst idea we ever have in protocol design. So you just sit there and constantly frob at the other side going, have you changed yet? Oh, have you changed yet? Have you changed yet? You know, it just seems so wasteful. So this doesn't work. And of course, there's a whole lot in DNSSEC to get warped, to get twisted, and to mangle. We've talked about key management, but what about zone signing? How long should the TTLs of those signature records be? 20 years or 2 weeks? Should we sign the entire zone all at once? Which is fine if you've only got 5 entries in your zone, but if you've got a few 100 million, this could be a problem. Do you use front-end signers instead? You know, what's going on here? And what about the TTL settings on all of these records? And that's just the simple zone management problems. Very few folk run their own computers in the basement anymore. They just put it out to a cloud. We're a service-oriented world. And what do you do with the DNS? I just hand it to a DNS operator. They look after it. But what if they fail? Oh, okay. I'll hand it to 2 DNS operators, because surely 2 is better than 1. But what about that single key that you're doing with your front-end signers when you've got 5 different operators all handling DNS zone publication for you? How do you manage that? How do you synchronize across all these providers? All these issues with multiple keys and the DNSSEC behavior. And then again, you know, just to make life even more fun, the wonderful mess that is NSEC 3, which, you know, could only have been invented in the IETF, couldn't it? No one else would have dared to wander into such a space, which, although it sounds simple, has become hideously complex. So, you know, things are getting more and more complicated. And then we get into the next issue of incremental signing, because we invented these negative records, no data and no such domain, because the assumption was that online signers wouldn't work. We shouldn't be putting private keys out at the front end. You know, all this stuff doesn't work. We should just assemble these and sign it and then just serve static material. That was 10 years ago. We've moved on. And now we're actually seeing a huge amount of use of these incremental signers, where you push the answer out to the edge of your infrastructure and then attach the signature as the answer leaves, which is great until you think about NSEC records and NSEC 3 records, where somehow you need to know a bit more about the zone than just this name doesn't exist. And so inventive folk have got extremely inventive and started to invent compact forms of these spanning records of NSEC and NSEC3, which actually just span the 1 byte around the name that doesn't exist. They really are a synthetic form of saying, no, not really, but I'm not going to tell you what is in the domain. I'm just going to limit this all the way down. And now we're actually talking about saying, well, it's the same NSEC response, whether it's no data. In other words, the name exists, but you're not asking for a resource record type that is defined for it, or there's no name out there. And we're trying to look at redefining those two kinds of error codes into a single compact error code in DNSSEC that says, just no, that's not there. And this compact form of denial and service can often, of course, confuse resolvers out there, because resolvers always get confused. What kind of crypto do you need? And if you're talking post-quantum resilience, this is a very, very difficult answer, because all of a sudden, if you try and stack things up and try and get more complex algorithms, they just get bigger. And of course, the larger they get, the harder they are to compute. The harder they are to compute, then the more time is spent. And all of this means that as we get these responses that get larger keys, etc., then all of a sudden UDP starts to fail out. These large responses stress out DNS over UDP. You start to get truncation. Let's switch to TCP. More round trip times get burned. And of course, if you get anything wrong in the config, as always in the DNS, there's this huge amount of cached configuration out there, cached content that isn't going to fix itself. You actually have to wait for TTLs to expire. The problem that Slack got into, geez, October 21, when it found itself in the black hole of there is no such thing called Slack, had to wait for 24 hours to repair because of the TTL choice. I'm like, if they had a smaller TTL, you could have resolved it in an hour, but no, we want long TTLs. Oops. And last but not least, when we talk about validation, very, very few resolvers out there in sort of user land, my phone, my laptop, whatever, they don't validate. They just rely on the information provided by the recursive resolver somewhere upstream. But hang on a second. That path between the recursive resolver and me is entirely unprotected. If someone attacks in there, the answer is, sucks to be you, I guess, because there's no protection. The only thing that says the recursive resolver did its job is it sets one bit going, yes, I validated this. I have set the AD bit on an unprotected path between the resolver and the stub. Talk about trust. This just seems to be naive trust, incredible trust, and probably misplaced trust. So validation is a problem. It's slow, it's error prone, it stresses out UDP, and most end users don't even put those validation functions in the edge. If they did, I think every Wi-Fi hotspot would be non-functional. So they just rely on someone else to do it, set the bit and go, oh yeah, we're good, which seems bizarre for a security product. But there's a really big question. All of this work, all of this effort, what's the threat? Well, the late lamented Dan Kaminsky came up with a very novel form of attack, which basically was off path. You didn't need to be on the path to actually see the query, but with a certain amount of just jamming responses back down to the target victim, you could actually make a random chance of getting the right answer inserted back in first and mislead the end user. And this Kaminsky styled attack worked, but there are lots of ways of countering it. And the way we've chosen, oddly enough, is not everyone should run DNSSEC. Far from it. We just randomize the port number and randomize the upper lowercase of the query name and check that the response has the same randomization. And then an off-path attack, trying to guess what was in the query in order to get in first with the wrong answer, is largely countered. So that's not a threat, not as bad as it was. So all that's left is on-path direct attacks of response substitution. But even that, because you see, my app and your app, my browser, your browser, everyone else, basically can't count on DNSSEC. The whole reason why we're all using TLS is because it can't count on believing the DNS. It doesn't believe that the answer it gave is necessarily the service I need to go to. And so the belts and braces approach says, look, irrespective of whether the DNS lied at me or not, I'm going to start up a TLS session and send it, we do the certificate dance. And basically, if I don't get the certificate for this name, then I'm not going to actually go there. If I don't get that key signed by the right private key, this is not the authentic server I want to go to. So in some ways, all that's going on is TLS is actually what's saving us. DNSSEC is kind of, yeah, well, So inside all of that, why bother? The case for no, the reason why I guess Google doesn't, the Bank of America doesn't, and a whole bunch of others don't, is it just makes things slower. There's more to go wrong. We don't even know what we're protecting against, and we're adding complexity, fragility, and cost without understanding the benefit. Oh, and by the way, TLS is working just fine. If I convince you. Have we made the case? Because, of course, like any good debate, there is a yes case. And the yes case is, I suppose, somewhat more subtle, because you can accept the fact that the threat model around the Kaminsky attacks, etc., aren't really compelling. So in some ways, DNSSEC, as it stands, is not the answer. But DNSSEC does one thing that we're kind of missing that would be good to have. Because if we really could trust the DNS responses we got, if we could believe that they're authentic and they're current, then we could use the DNS for roles that we're not ready to do today. We could use the DNS to actually do things where today it would be really, really unwise. And I suppose you've got to start with the question, is TLS actually working? Is TLS doing a really fine job? And it's a good question, because quite frankly, the whole issue of domain name certificates sounds truly, truly bizarre. I go off to somebody else, and I've probably never met them before, some third party and I say to them, that's my domain name. And they say, well, give us money, Jeff, and I peel off some money. Well, these days, if I use Let's Encrypt, I don't pay them any money at all. And they then issue me with a digital object that says, this is Jeff's domain name. Huh? Well, okay, great. And then I present that certificate to everyone else going, this is really my domain name. They've certified my key pair. I've signed this with my private key. This is genuine. Sounds sort of weird, because quite frankly, there's a trust model going on here, which is pretty odd. There's about 1,000 or so, I think it's about 850 entities that are members of this certificate and browser forum, the CAB forum. And they issue domain name certificates that are trusted by browsers. So if you're a member of this forum, then the certificates you issue are trusted. Well, great, but what's going on here? Well, this certificate issuer says, I'm going to take some tests to determine if you control a domain name. Well, what's that test? I'll put a text record in your domain zone. If you put this text record in with some value, then you obviously own the domain name. Okay, sounds a bit sus, but what's the certificate say? Or what's this process says? Well, it firstly says, I will never deviate from this test. I will always give everyone the same test, except of course when they deviate, registration agents, etc. And secondly, they undertake that they never, ever, ever lie about the certificates they issue, except when they do. Oops. And they undertake that their systems that they have online to actually do these tests and issue these certificates are never, ever, ever compromised by hostile attack, except when they are. So it's kind of a weird trust model, isn't it? And quite frankly, any of those trusted CAs can issue a certificate for any domain name. And so I don't have to, if I want to imitate or get a certificate about your domain name, I don't necessarily have to compromise your certificate authority, the one you used. Any certificate authority is fair game. I can knock off any of them and get a false certificate for your domain name. And folk will believe it because pinning is a really difficult problem. So difficult that in Chrome, the Google name is actually in the code. The pinning is done directly for Google. The rest of us, oh, well, you've all got a problem. But okay, you know, let's solve this problem by transparency because sunlight cures all ills. So all CAs should stash a copy of the issued certificate and transparency log. So all issuance transactions are recorded for posterity or something. Oh, I've seen attacks that last for all of about an hour or so. No one cares about the footprints they leave behind. The data has been exfiltrated. The damage has been done. Nobody cares about transparency logs. They are just a mere tissue, a pantomime of actually good security here. They don't work. And of course, the whole thing about revocation is a nightmare. I pulled up a certificate, revoked it immediately, and then started running a massive ad to see who went there. And the number is scary, scary, scary big, because quite frankly, almost nobody, by almost, Apple does, but almost no one else checks for revocation of a certificate. So even when the issuer and the subject say, this is a bad certificate, don't use it, everyone else goes, nah, certificates don't care. And so they just keep on using it. OCSP stapling is kind of pointless. None of this stuff works well. And so it leads you to the thought, why do we trust TLS? And I think the answer is scary, because we don't have any alternative. There's nothing better out there. We trust it because there's nothing else to trust. It's a desperation rather than a well-engineered system. Could we do better? And this is where this thought bubble about DNSSEC comes in. Because what we're really trying to do with certificates is to associate a domain name, a service name, with a key pair. And if you can do that secure association without all the paraphernalia and theater of certificates, and just simply put it in the DNS and sign it with DNSSEC, you get everything that the certificates offer, the X509 system, without that added rigmarole that the X500 system brings along. You get currency and authenticity, and a whole bunch of intermediaries just aren't a part of the story anymore. So DANE, which is what we're talking about, allows a clean association of keys and names. We can do this better. The domain name certificates, this detached third-party commentary, has had and will continue to have all kinds of problems. But that doesn't get over the fact that DNSSEC sucks. It's just hell. And the real answer is, don't use it. Let's not use DNSSEC and supplying signatures and validation using UDP at all. Walk away from this. It doesn't work. And the answer is, well, can we do this over a different transport? And of course, the RFC series these days is a lot like the Bible. Everything is there, everything. Anything can be said, anything can be contradicted. There's an RFC for it, no matter what you're trying to do. And so if you look at RFC 7901, you see a very cute idea of pushing the workload of validation from the client across to the server. And the server actually assembles the validation chain and just passes over to the client saying, look, use your copy of the root zone key signing key, the KSK, and you authenticate all these answers that you would have got from the DNS had you bothered asking. If you can validate that, this is good, which is a really interesting approach in pushing the pain elsewhere. So we can do this because, yes, there's another RFC as well, 9102, that talks about using that chain extension inside the TLS handshake. So instead of passing certificates, I just pass the DNSSEC record that says, this is the key, this is the reason why this key and this domain name are bound together use your copy of the root zone KSK to validate this and press on. And all of a sudden, there's been no DNS queries. It's queryless. Dane and DNSSEC can fold into TLS without all of the time, trouble, and hassle that we've currently got with the third-party certificate system. So if we're serious about DNSSEC, we've got a whole bunch of problems that we need to fix. And one of them is, maybe we're just not thinking about the problem right. Incremental queries and answers and the DNSSEC do not work well together. And let's not try to make it. We're going to waste an extraordinary amount of effort not solving this. So let's just move on and move away and start looking at DOT and DOE and TCP transports and trying to fold DNSSEC directly into the application levels that need that kind of information. Now, we can do a bunch of things here and change a lot of this, but it's going to take time, money, and effort, which is fine until you realize that I've never paid for a DNS query in my life, and neither have you. No one pays for the DNS. They just don't. It's kind of this, oh, well, it's included in my ISP service fee, whatever. And the folk who run open resolvers, well, you know, success, disaster. The more I use them, the more they've got costs that they're not getting any money out of me. So in some ways, the economy of DNS actually works against the deployment of improvements in DNSSEC. And we might be stuck with UDP because of economics, not because of technology. So maybe we should rethink this completely and walk away from DNSSEC being an attribute of queries and answers and think about DNSSEC as a server-side function right up in the application. In the same way that a huge amount of the internet is actually being reimagined as application level interactions. Even Quick is an application level system, not a platform or infrastructure system. And just simply think of DNSSEC in the same context as an attribute of applications. Because as far as I can see, there's kind of this chicken and egg problem if we try and make DNSSEC work in the DNS, that it's really hard to make a compelling use case that makes DNSSEC in the query response model essential. It just doesn't work. And quite frankly, we can do it differently and put it on the server side, but that only works if everybody signs. We can do a much better job in creating server-side authenticity and leverage DNSSEC to do so. But quite frankly, with no one signing, there's no point in doing it. So in some ways, the why bother and no point sort of things wrap around each other and self-reinforce the problem that it's really, really hard to change things. And when we talk about, well, is DNSSEC going to fly or not? The issue is this is a really big internet. It's massive. And widely distributed diverse systems hate change. They just loathe it. Change is challenging to orchestrate. Costs and benefits are misaligned. Large-scale systems just don't change easily. And they're incredibly averse to complexity and fragility. And quite frankly, even if the X509 certificate system is creaking, groaning, and falling apart, that might still not be enough to convince the world to change. The benefits are marginal. The transitional costs are really, really high. And I think I can generalize it this little bit. You know, why has V6 taken so long? I'm like, did we get the design wrong? Is it really, really broken? And I think the answer is no, not really. It's a fine protocol. If that was our first thought back in 1983, we'd probably go, yeah, right, works fine. It's not that it's V6 or DNSSEC. It's that once a technology sits in the middle and is the dominant technology at the time, it is awfully hard to unseat. And when we talk about security and bolting on security as an afterthought in so much of the DNS, the IP infrastructure, we kind of land up with the issue that, yeah, it's a really rough fit, but we're actually getting precisely the amount of security that we're prepared to pay for. And that's a sad answer. I've got a couple of minutes left by my clocks, and hopefully if I hand it back to the room, there is some time for questions or bricks or anything in between. Thank you very much.
Thank you. I see 3 people lined up at the microphone, and since we are quite short on time, I'm closing the microphones right now. So you can ask your questions, but the microphone queues are then closed. Let's start over here, please.
Hello, my name is Maxim Tuliev from NetAssist. The question is, if you compare on slow link like satellites, DNSSEC and DNS over TLS, what will be faster and what approximately the rate? How much faster? Thank you.
DNS over TLS versus DNS over UDP works best in the stub to recursive resolver, where the same session can be reused. So it takes time to set up TLS. Oddly enough, DNS over QUIC is faster. So once you've set that up and you're then using that same security association to ask again and again and again, it's much the same overhead. So in the stub to resolver case, continuously use session, it actually makes no difference whether you use UDP or TLS or QUIC even to actually handle the sequence of queries. In the recursive to authoritative server situation, all bets are off. All bets are off because there's no single session that can get reused. And so recursive resolver to authoritative server, TCP, TLS, QUIC, they all become a little bit scary. Scary because they just take up time and resource. Thank you. I'll be quicker next time, I promise.
Okay, there's one online question from Shane Kerr. The concerns about compact online signing are overstated. Several vendors have been using it with separate implementations for many years. It's different, but it works. Well, it's a remark instead of a question.
Fine. Okay. I'm well aware of Cloudflare's work. I think it's brilliant. But yeah.
Matthijs Mekking, I think you raise good questions that we have to think about it, but I also want to say that the case for no one case you sketch it too dark, then that's key management, key rollovers. There's open source software, bind, not DNS, where it's just simply turning on an option and it works for you. It works for 90% of the people here, and yeah, so when I think of DNSSEC is hard on a protocol level, but really on an operational level, it's not that hard. It's very easy.
I have so much sympathy for the good folk at Slack and Amazon who managed to kill Slack for 24 hours once they signed their zone. There's so many bits that just don't work right, and unfortunately it's so easy to get it wrong. So Matthijs, yes, I'd like to be confident too. I'd love to be confident. It'd make my night. But the experiences we have tend to say we still haven't got it quite right yet. But we live and learn.
Jim, last question.
Yeah, Jim Reed, another fellow traveller on the DNSSEC bus. Jeff, fantastic talk as always. Thanks for that. Could probably rant at this microphone for as long as you've talked today about all the defects and problems with DNSSEC. I realise I'm up against the clock, so I'm going to keep it fairly short. I think one of the things that needs to happen now is, in my view, it's time for the IETF to think things properly about this. I think we're at the stage now where DNSSEC is a stinking mess. It's never going to get deployed universally. Give up. It's never going to happen, and we should stop wasting your time in the IETF, putting in new tweaks and tweaks to try and make it better, to try and make it easier to deploy. The tooling's never going to happen there, and it's never going to work because the protocol is fundamentally broken. And the main reason for that is that nobody gets the benefit of signing because it's the benefit for others. So if you sign, you take a risk. If you're on the resolving side, you do validation, you're taking the risk. So that's never going to work out. I think it's time we have to sort of say, stop this nonsense and perhaps rely on just using encrypted DNS transport such as DO or perhaps DOQ. I think DNSSEC is a dead duck.
Okay. I have a very quick response to that, Jim, and it kind of goes, this talk was never going to happen in the IETF. It was only going to happen in a room of network infrastructure operators. It is not the IETF's decision to say no. It's a standards body. It's addicted to saying yes. They just can't resist. They'll always standardize stuff, no matter what. But it's actually the infrastructure operators who have the call on where and how they spend their money and the way they define their service. This is the room and the people who honestly need to think this through. So this talk is to you, audience, and to you, folk who run infrastructure, going, think about what you're doing and what your customers want. And if DNSSEC isn't working, don't flog the dead horse, move on. And I think in that, I agree with you completely.
Thanks, Jeff. I just wanted to make one quick follow-up remark to that. It's a pity that you cannot bring this kind of discussion into the IETF because I think it has to take place there, and it's a crying shame that can't happen. That's another entirely different argument, but I think that's an important thing that has to be borne in mind too.
Okay.
Thanks, Jim. And thank you all for your attention and bearing with me online. Thank you.
Okay. Thank you, Jeff. Thank you. Quick reminder, please rate the talks, and also you can still put your name forward for the program committee elections. Next speaker is Randy Bush. Is he online? Can you promote him to speaker, please? And Randy is going to talk about RPKI ecosystem measurement. Randy, the stage is yours.
First, I want to continue the conversation of a moment ago and note that there is a higher percentage of operators and operator presentations in RIPE than at the IETF. And there is a higher percentage of researchers and research presentations at RIPE than at the IETF. And there are no vendor presentations so far this meeting, and I don't miss them. Thanks to the RIPE Program Committee, RACI, and to the community. But anyway, so this is a story about the RPKI as usual. Romain had to present this at the Passive and Active Measurement Conference and an academic audience. So first he just had to describe the RPKI. And the RPKI is another example of complexity that I've ranted about for some years. It started simply, like most things. But if we want to think of our general structure, the classic 3 planes, except I didn't take a plane to get there, I'm coming over the internet. So there's the management plane with the normal management protocols, and we drive configuration down it. And RPKI and ROV are one aspect of configuration. Okay, and so they drive down to the management plane, they affect how BGP happens, and then they affect the payload. And the payload's important because that's what the customer's paying us for. So we use the RIRs and the RPKI to maintain our data, and it reaches all the way down to the data plane to move the packets. But what happens when something goes wrong up in the management plane and the RIRs, and I put in a bad ROA? How long does it take to fix it? Well, let's think about how to measure this. On the left, we see the management plane. On the right, the control plane and the data plane on the bottom. And we can take timing from when, we call this the query, the user tells the RIR, hey, create a ROA, please. The RIR then, we can measure when it signs it from the signing time, the publication from when it appears the publication point, when validators get it out on the internet, when BGP is affected, we see it at the route collectors, and then on the data plane, we can actually trace route. So, being experimentalists, we get prefixes from all 5 of the RIRs, some 24s in 4 some 48s and 6. And from one AS, which has both ROV upstreams and direct peers, which are non-validating, and as a separate experiment, we get a bunch of prefixes from RIPE that we use from different ASs over on the other side of the world that are all in the non-validating universe. And we measure for 11 months. Well, what do we measure? Well, we use something we call ROA beacons. And so we, at each of the 5 RIRs, depending upon their user interface, we either get to use an API or we use screen scraping to create and delete ROAs. We divide the prefixes into 2 groups, control and test. The controls always have good ROAs. Those prefixes are always valid. The test prefixes always have an invalidating ROA, locked on all the time, and then half the time we announce a validating ROA. And if you're an RPKI freak, you know that a validating ROA overrides the invalidating ROA. So let's see what happens here. We create ROAs. We see when they sign it, the not before time, the publication time, when relying parties get it, and when it appears in BGP. This is ROA creation. First, we notice that APNIC has a 20-minute batching time, so the mean is 10 minutes. The parentheses are IPv6. Okay. The publication time of ARIN and APNIC, ARIN and LACNIC are greatly skewed. Something's going on here. It turns out, and I'll go into more detail, that the hardware security modules used to sign the ROAs are, due to the fact that they're normal infrastructure for grown-ups, are doing everything in GMT. But ARIN and LACNIC are running their servers in local time. So you get a monstrous skew where the not before is hours before the publication. Now, we noticed this after a while. We told them, and they hacked around it. But this greatly skews their data. But so we see that, for instance, after NIC, we do something, 3 minutes in publication, 15 minutes it's in BGP. RIPE, about the same. This isn't bad. Okay. So the ROA creation delay is significantly different across RIRs. And we know at least one NIR, and we didn't measure NIRs, that only publishes once a day. And originally, APNIC only committed to once a day, but now they batch 20 minutes. So the relying party we used was unfortunately only one instance of software, and you should check out Philip Smith's measurements and how relying party software varies, and it is not pretty. As Jeff says, we're running in a pretty broken universe. We did not test RPKI to router performance because that is like DNS is, and therefore those measurements we've taken of it, it's effectively zip. So that's fast. Some relying party software has head of line blocking. In other words, it's going along and it hits a publication point that it can't reach, and blam, it stops dead till it times out, and the other publication points are not fetched until the time has happened. The collectors at RIPE and RIS, they're great. If the control prefix is missing, we throw away the measurement. So we get the BGP effect. We only used RC0 and 1, and studies have shown that's enough. RIPE and RIS has all the biases we've discussed for years, just like leaking all your internal prefixes was an earlier presentation today. Revocation delay for a ROA, APNIC has had a stuck interface and the 20-minute delay, which skewed their data greatly. Click, clicky, click, clicky, click. There we go. So we can see we look at a CDF of BGP update to a create, and we see the time zone bugs for LACNIC and Aaron. I told you about the time zone bugs. Run your infrastructure in GMT. This is a global internet. Withdraws are slower than announces. Okay, and we'll notice two interesting anomalies here. First, the right shift, but also the slow slope up to closure. And there's two things happening. The reason withdrawals are slower is most of the big ISPs have multiple relying party caches. For a ROA to validate, only one of the caches needs to have a successful ROA. For a withdraw to work, it must have withdrawn from both of the caches. So the polling skew of the caches skews the delay time for withdrawals. So here we look at Sprint and NTT with their consent. You'll see the publication lags for the signing problems. We'll see the slower withdrawals. We also see the relying party software has a stuck ROA bug. If you've seen papers and presentations on BGP stuck prefixes, well, we have publication points and relying party software with stuck ROAs. So, BGP update delay, again, showing the slow polars between these different ISPs. Here's a range of ISPs. Some have slower polars. And you see the stuck ROA that it never reaches 1 in some cases. Okay, the stuck ROA bug again, this is a withdraw. Okay, as opposed to a announce. And the data plane measurement, trace route from a bunch of Atlas probes to the test prefixes. Frequently, the results are similar to BGP. In other words, the control plane does seem to be in sync with the data plane. The one cute thing is, for those who know path hunting, path hunting is my router really has, depending upon how many peers it has, multiple paths for the same prefix. If I get a withdrawal or an invalidation on one of them, I fall back to the second, and similarly to the third and fourth. That's called path hunting. And here, the red vertical lines are with the validating ROA has been withdrawn, and we see that we accept for a few minutes some other paths. That's the only thing interesting we learned on the data plane. Okay, so we have two major delays in me fixing the bug where I issued a bad ROA. The delay at the RIR's publication to the publication points, and the ISP delay getting it into BGP. The polling delay of ISPs is big. If we assume Arabic and Latinic time zone anomalies are fixed, let's not worry about those two, and let's just look at Afrinic, which takes the majority of the time is between publication and the relying party. The same for the APNIX prefixes, the same for the write prefixes. So what we're seeing here is the ISPs are polling infrequently. This is a historical artifact because when there was only rsync, the RIRs whined about the loads on their servers. But now, RRDP dominates. We don't need that fear. So, the problems we have is BGP propagates in minutes, not as fast as we might like, but it's still pretty darn fast. RPKI is significantly slower, which kills both or damages both time to repair and time to authorize a DDoS mitigator and things like that. We found the two HSM problems. We found head of line blocking on some bad relying party software. We also, I'm not going to discuss it here, when we dissected the ROAs between the RIRs, we found some interesting differences. The limitations of the study was the relying party software. We only used one example, and it wasn't a very nice one, and it had a fixed fetch rate, so we couldn't vary it to see the resolution. We didn't measure RPKI to routers, I said, but that should not be fast. My family has jokes about should. We also did not measure delegated CAs like NIRs, big ISPs, etc. And between the RIRs, how to automate issuing and withdrawing ROAs was hell. The researcher who did the heavy lifting on this end was Romain, and he says he never wants to do an ops-heavy experiment again. He just lost too much time doing this. Okay, this was a paper at PAM. Again, the full author list. And of course, this is an operator forum. That's nice research, but what can we do? CAs and RIRs, please publish very frequently. Relying parties, poll at least every 10 minutes or more frequently if using RRDP, because caching and the if modified since header means the load on publication points is negligible. Don't be afraid of hammering them. Not too frequently if it's rsync, maybe 30 minutes. And yes, this discourages rsync, but we're trying to deprecate it. And you can tell whether it's rsync or RDP by the URL from which you're fetching. And by you, I mean the relying party software. Okay. As protocol designers, BGP is the only large-scale push protocol we have. And I agree with Jeff that pull protocols suck. And money sucks, but it's what we've got. BGP as a transport, unfortunately, if we tried to push RPKI data over it, it's a dangerously shared fate. And by that I mean the purpose of the RPKI is a parallel set of data which are meant to check each other. If you use one to transport the other, it's called shared fate. And among other dangers of BGP is it is utterly unordered. Reordering at every hop is pretty much guaranteed. We did try back in '98 to design a system with DNS for it. That draft is still in the repository somewhere. The problem is make before break. If I connected to Jeff's ISP right now, and I have a ROA for it, and I want to connect to Ilyach's, I have to issue an ROA for Ilyach's. That's two separate ROAs so that I make before break. I switch the circuit, and then I take away Jeff's ROA. But on DNS, I can't have two delegations. Also, DNS is, again, a pull protocol. So we fantasize about a floating protocol for the management plane, that's immune to routing attacks. I fantasize about world peace and ending world hunger. So, and as I said, IETF doesn't seem to be a great place to put big hopes in about this. And a warning about what's happening in the IETF. And it's parallel to a warning Jeff made, which is, if you remember back 5 years ago, this thing about the DNS camel and the rise in DNS complexity. Well, 18 years older before, I made a presentation at the IETF plenary. It was the same presentation, except it's a horse instead of a camel, and the DNS, and we're overloading it. And we continue to overload it. So one of the most famous and best computer scientists of the last 100 years, Edgar Dijkstra, says, don't be confused by the complexity of our own making. And this is a big warning to the glorious IETF. Thanks to permissionless research to these people who donated rack space, bandwidth, routers, switches, Atlas probes, et cetera, et cetera. And that's it. Thank you for your indulgence.
I mean, we try to discourage position statements masquerading as questions. Hello, yes, please.
I love the talk, Randy. Trade Arley, Accenture Security, and First.org Board of Directors. Just as a person, though, question. Where do you see the role of standards organizations in the future? Like, so much of the standards work seems to be happening like in running code, sort of de facto and defined in small cabals from what I see. I'm not such a player in the IETF, but I have done in some other standards organizations, and I think you touched on a valid point. How do you see standards organizations evolving, or what role do you see them playing in the coming decade or so?
Well, we need some place to generate complexity. Operators are too lazy and want things too simple.
Okay.
Hi, David Lawrence, Salesforce. I appreciate that this is an operator-first community, and I have an enormous amount of respect for Jeff and for Randy and for Jim. But there's quite a lot of negativity here for the IETF right now. I would just like to point out that in the next session, we will be having an IETF BOF to better explain how we can be working together rather than at loggerheads with each other. The IETF very much does need operator input on how to make things better. I would just like to kind of veer us away from everything is terrible about the IETF.
You're speaking to someone who sat at a dinner table and had one of IPv6's major designers look him in the face and say, operators don't even understand logarithms. Sorry.
So let's move swiftly along at this point in time.
Hi, Robert Kistaki, IPNCC. Pretending for a moment that I don't work for the NCC. There is a slight difference between IPv4 and IPv6 related timings in your slides. Can you offer an explanation for that?
No.
Thank you.
Okay.
Interesting question, of course, but no, we didn't dive into it, Robert. Sorry.
Tim Bruijsels, NL Labs. Thank you all for doing this research. I think it's really valuable to see what the propagation times are that we're looking at, which, you know, have an impact on DDoS, have an impact on mistakes you make with ROAS. I'll get to my question or statement. I think it's really good if there is a strong indication made about what is an acceptable delay in RPKI validation. Because the thing is that I asked this question a couple of years ago and I didn't really get a clear answer on that. When I used to work for RPCC, I actually worked on a fully asynchronous RPKI validator that doesn't block, but the cost is you get a huge amount of complexity. And if the story is half an hour is good enough, then you're going to get code that does the simple thing. It does sequential processing, it blocks, because it's easier to reason about. It doesn't make it right. If there's a strong message that, no, this needs to be faster, it needs to be resilient, it needs to be not blocked because some repository is being a bad actor, which to my mind is, well, pretty clear that it shouldn't. But I think that message will help because that will guide relying party implementers to make that. When the story is, no, it should be simple to reason about and just do this thing eventually, but do it well, then you get a different solution.
I hear your point, Tim. I hear your point, Tim. And I think as an operator, I would like it to be on the scale of BGP. Not necessarily just 2 minutes end to end, but could we get it 10 to 15 or somewhere is reasonable in that a mistake is acceptable. And secondly, I believe that you can do relying party software that doesn't head of line block with reasonable software engineering. And I think that the broken publication point that's causing that software to get head of line blocking are not stupid people. It's just operational mistakes. It's, hey, I need to protect my publication point, so I put it behind a firewall, and some klutz changes the firewall rule until we catch it, you know? And whether that's the firewall at an institution or a firewall of a rather large country. Sorry to rant on, but I hear your point, Tim.
Okay, there is nobody else at the mics, so I think that's that. Thank you again very much, Randy. Okay, so that concludes our session coffee break. I would ask you again to rate the talks. If you suddenly wish to nominate yourself for the PC, you have 120 seconds, give or take. And yeah, enjoy your coffee break. Thanks very much, folks. Okay.
Good session. We managed.
Yes. You just give him, say that there is a question in the queue. Yes.
Maybe I need a microphone because this is for you.
Two microphones. Let's ask Javier. He will just enable the mic, and then he will be heard on the.
So we have a small.
Have you seen Sanders?
Yes.
What? Where is he right now?
He went to he has some meetings. I will come around to the microphone.
Non c'ho voglia, e poi arriva l'estate, quando piove giù, fa venire su una.
Yeah. Yes.
Le sondate per quei soliti punti del cazzo che poi io so come fatto che c'è i burazzi, giorni che schiaffone a rovescio. No, perché sei una cazzo, stai zitto. Ma infatti ho fatto sono venuto col collega Lorenzo. Su lei stamattina si vedeva proprio perfettamente vestissimo, col riflesso, c'erano tutte le risaglie nel vercellese, no? Tutte belle, piene, mondi del cazzo, state fecchi, parla sopra un po', solo pizza in faccia. Vabbè, sono un po'.
No, it's not what I thought actually. Was it some? That doesn't do. No, I thought they skipped both.
Sempre pochissima gente. Va bene, va bene. Luca?
Yeah, I need to make a phone call, sorry.
Penso un cazzo. Dunque, io sono contento da una parte di aver passato con la fase della nuova resolution che si deve fare quando i 4 anni. Beh, deve essere abbastanza divertente quella fase. Già adesso che inizia a essere un po' reattivo, nel senso che scambia, scherza, è già divertente.
Hello.
Hello. That's not giovane. Italian giovane is young.
Yeah, okay, he's not young. Why? He's got a mustache, but it's not white. It's not a white mustache. Get white head.
So maybe I'm older than you?
No,
No.
I don't think so.
Okay, I'm 49.
I'm 53.
Okay. You win. You win. You win 2 times. You're older because you're older because you are.
Yeah, I'm trying to tint it to clarify. No, I've been asked actually if I was doing colors, and I said, no, way.
No.
What? what? It's not normal. No, I'm losing my hair, but at least it's only gray here.
No, 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 no. It's okay.
Yeah. Anyway, I'm gonna try to find that Giovanni. Yeah. Because the E would be Giovanni. Giovanni? Yeah. You don't pronounce it with a E again? Okay.
I don't know from where he is.
Oh, the shoe from Italy?
The surname is
No? Okay. Wow.
so.
Yes. I need to say that the voting is open for the
It's not spot. I just sit here and come there if
Okay, no, no, if you want to introduce Giovanni, no, you can. Okay.
You are the expert member. You are the older member.
No, I think Brian.
Brian?
Brian is the oldest.
You are older than me, maybe.
Hey, Tom. Hi. I was just looking for you. As we did.
So here, in fact, you have, let's move this way. So here you have the lecture. So it shows you the next slide and stuff like that. Here, what you have in front of you, the confidence screen.
You speak languages.
Non mi dire, eh? Oh. Io ero nato a Nova Gorizia. Io ero nato 20 mesi dalla conflitto.
I think your other presenter is up on the stage.
Oh, maybe we found Giovanni.
Yeah, I think that's what
This guy
found Giovanni.
I think given the explanation that he's getting about how the presentation system works.
Yes, it works. Hello, welcome to 4 p.m. session. My name is Jan, this is Antonio. We will be chairing this session. Please have a seat. We can wait for another minute because I think the bell was rang. So we have an announcement. At 4 p.m., that's like now, the voting starts for the program committee. So please go have a look who volunteered to be at the program committee and do the work and cast your votes. Thank you very much. So our first presenter is Tom. I saw him somewhere. There is Tom. Tom will talk about incident management at scale. Thank you. The floor is yours.
Working. There we go. That's weird. Okay. Good afternoon, everyone. As introduced, I'm going to talk a bit about incident management at scale, specifically incident management at Cloudflare. So, quick recap, basically the why you have to trust me slide. I'm principal network. I love that name for this slide. It's great. I'm going to keep using that. So I'm a principal network engineer at Cloudflare. I also work on the backbone, so I kind of have two hats. But one of the other things I also consistently do is I break things. I break things usually from vendors, but sometimes also my own stuff. When things break, you kind of need to fix them. And that's basically what this talk is going to be about. Why do we need to fix things? Why do we need to care about incident management in the first place? It's that all of the infrastructure that we as a community have been building over the last 30 years is becoming more and more of a critical or a crucial aspect of day-to-day life and day-to-day society, which means that we can get very annoying things in the press that are basically just, network X did something bad, and therefore, you couldn't cook your pizza or whatever else that happens. So really important that we get on top of these problems as fast as possible, that we fix them as fast as possible, but also that we communicate about them as openly and honestly as possible. So what's incident management specifically at Cloudflare? It looks a bit like this. Sometimes, right? But what we try to do is not some of you may have heard about ETIL. We don't follow ETIL because ETIL specifically calls out for a dedicated incident management team that is, that kind of handles the entire process and make sure that, things happen. The reason why we don't follow ETIL is because everyone needs to be part of the incident process. That means that every engineer or every team that pushes code or hardware or infrastructure or anything else to the edge is responsible for their own stack. That means that, you break it, you fix it, quite literally. But that means that we need to make sure that everyone involved has really good training and a really good understanding of what the processes are. And because we're a growing company, it's not always the easiest thing to do. So one of the things that we have done is instituted an incident commander. Incident commanders are basically the WD-40 of the incident process. They're only there to make sure that the individual contributors, so the SMEs, the subject matter experts that are actually involved in, it's like understanding what broke and trying to fix what broke, that they can get all of the resources that they need, right? That can be, it's like, do we need more time? Do you need more engineers? Do we need to page someone? Do we need to get someone out of bed at 4 a.m.? Those kind of questions can be asked by the incident commander so that the engineers that are actually trying to fix it can actually work on fixing the problem and don't have to kind of deal with the meta-ness of an actual incident, right? It's like, focus on the thing that you're good at and we'll deal the rest. And that's what the incident commander is. So the incident commander is all of the engineering managers. We follow a weekly rotation. So the incident commanders are on call for 7 days a week, but it is follow the sun. So, they're not on call for however many hours is in a week. So you're on call for 8 hours, Then you hand over to, it's like if you're in EMEA, you hand over to the US, and then the US hands over to Singapore, and Singapore hands over to Europe. Works really well. So let's talk a bit about that process, the process that the incident commanders are there to kind of WD-40 the hell out of. So first of all is you have detection. So detection, most of the time, hopefully you have automated alerts, right? You set up some rules in whatever system that you're using, be that for us, for example, we're a Prometheus company. Because we're a Prometheus company, that means that we use Alert Manager. And that's kind of how we set up our alerting pipeline. But it doesn't have to be that specifically. Like, for example, Grafana has a really good setup for alerts as well. But the really annoying thing with detection is, well, you need to know what can break, right? It's like, I know it's like a glass pane. If I throw a ball through it, that glass is going to break. And that's a known failure scenario. And you can test for that, right? But not everything that we build, especially on the infrastructure level, has an easily detectable problem. So for that, we discovered this amazing thing called customers. Customers are great at figuring out problems. So when customers detect problems, it's usually probably already a bit too late, because that means that it's public. It means that people have noticed. It means that people are going to start yelling at you. It means that there's an additional pressure of, it's like whatever it is that you did, don't do it, is not usually the most constructive conversation to have. But it kind of is what this means. Like, you need to do mitigation and remediation. It's really important that we distinguish between mitigation and remediation. I think for some people that might be all of the same thing, but mitigation is, stop the bleeding immediately, right? It's like you lose an arm, you want to stop the bleeding because, otherwise you don't just lose the arm, you lose the life. And remediation then is, well, how do we continue from here? Can we get a prosthetic on there? Like stuff like that, right? It's figuring out what's the long-term solution to the problem that, either customer uncovered or metrics uncovered, or, just running things in production uncovers. So that's the big difference between mitigation, which is, stop the bleeding. It's like whatever it is, like do a rollback of the code. If you know what the specific bug is, like for example, you forgot a colon, then you push out a new release, you get that going as soon as possible. And then you do a longer think through of, well, how do we make sure that this just doesn't happen again in the future with more solid structure? And that's kind of where reporting comes in as well. We have a very clear culture of incident reports at Cloudflare. That means that every single incident that we have needs to have an incident report attached to it. For the most part, those incident reports are internal, but for our customers, if the customer, says we were impacted by incident XYZ, could you please tell us what the hell happened and how you're making sure that doesn't happen again? Then we occasionally redact some things, rewrite some things. It's like, it doesn't always have to be the nitty-gritty details, and then we ship that to the customer. A really important thing to note with the reports is that what we try to do is, you have the engineers working on the incident, is that you don't have the engineers that worked on the incident write the incident report. You have someone else do it. The reason for that is it kind of helps you resolve another problem, which is communication during the incident. One of the things that is very easy for engineers is to kind of get stuck in your own head, and you're not communicating about the things that you're thinking through. You're not communicating about the things that you're seeing. You're not communicating about, it's like, oh, I think I might solve this that way. So you don't get the feedback from your colleagues. So by forcing someone else, an outsider, to write that incident report, you're forcing the engineers that are working the incident to over communicate, to communicate everything that they're thinking, everything that they're seeing, making sure that they're, it's like pasting the right graphs to make sure that, it's like we're looking all at the same thing. Because if you don't, you're going to get a bunch of questions from an engineer like a day later or 2 or 3 hours later, where they're just going to ask you, it's like, yeah, so 50 minutes in that incident, like nothing was said. And then suddenly you go, I fixed it. What happened? Like, how did this, what, right? Like, where's the timeline of events happening? So by doing that, we kind of just make that better. One of the other things as well is because, like we want to work on fixing the problem. We don't want to work on communicating. One of the things that we've built is a bot called Respect Tables. Respect Tables is, for us, we use Google Chat. I think we're the only company that uses Google Chat. Yeah. It works, I guess, for the most part. But Respect Tables, it's a bot. It allows us to very easily update timelines. It allows us to very easily post status updates. It allows us to page people if we need to page. We can check on-call schedules, things like that. Just kind of makes things a bit easier, so you don't have to go through the gazillion different interfaces that exist for it. You know, it's like dashboards and then pagers and it's like everything else. It centralizes that system, making sure that it's as low of friction as possible. Again, for the incident commander, but also for the ICs if they really need to. We also have an incident board. The incident board, this took a really long time to get this, because that basically means that there's no incidents. That's really, really hard to get no incidents. But the incident board will always list the active incidents at Cloudflare. It makes it easier for incident commanders that are just going to come into rotation, for example, to just have a quick look as like, okay, what's broken? But also for engineers, you know, it's like you wake up, I'm in London, so I wake up at, you know, usually 9 GMT-ish, or get into work at 9 GMT-ish. And I can then just open the incident board and have a quick look as like, is anything broken? Is there anything out there that might require the network team's attention? If the board is clear, awesome. If the board isn't clear, I have a very quick, very easy or nice overview of what is broken and if I may or may not need to be involved in this. Another thing that we do communication-wise, because all of the previous items are internal communication, right? It's making sure that the rest of the company knows what the status of the network is, what the status is of our edge services, everything else. But we also need to make sure that we communicate externally, right? Because Cloudflare wouldn't be Cloudflare if we didn't have customers. It'd be significantly much more fun, but you know, something's got to make the money that makes me get the links. So the thing that we use is Cloudflare Status. You know, there's a gazillion different status page providers out there. We use one. And what this will allow us to do is just kind of communicate, hey, look, we know that this system is broken. You know, it's like, oh, DNS propagation is delayed, or we're having issues in this specific location or whatever. So that customers that see issues with Cloudflare can have a look at the Cloudflare status website and they can see, like, oh, Cloudflare knows about it or Cloudflare doesn't know about it. And if Cloudflare doesn't know about it, then you go on Twitter and yell about it, right? A really important thing with the Cloudflare status page is that address that you see there is not Cloudflare IP space. Some of you may or may not recognize that IP space. It is Google IP space. Also, I want to thank Google for making sure that there's signed ROAs for that prefix, because, you know, it wouldn't be a RIPE conference without mentioning RPKI every single 5 minutes. But IPv6 doesn't exist. But we make sure that, you know, it's like the Cloudflare status page, it's important that it's not hosted on the Cloudflare network, because if we break the Cloudflare network, how can you check the Cloudflare status page if the Cloudflare status, you know, it's like circular dependencies, we all know, bad idea. So we make sure that that's hosted somewhere else, so that when we do have a full complete outage, people can still figure out that we have a full outage. And then last but not least, it is incident reviews. We do these once a week. We do that in both the San Francisco time zone and the London time zone. We don't have one really in Singapore. We are trying to spin that up. Apparently Singapore just doesn't have as many incidents, I guess. Good people. But so yeah, it's like we do them once a week. And what we do there is we walk through the incident, right? We'll basically just open the incident report, and either the engineering manager of the team that was responsible for the incident will walk through it, or if the engineering manager wants an individual contributor, so random engineer, to kind of walk us through what happened, they'll walk us through what happened. And the key point of this is that we can then have a chat, usually 5 minutes. We need to move things along, right? And we try to figure out as a group what we could have done better. right? It's great when you can like walk through an incident and the incident lasted 10 minutes and it was super easy to fix and we had all of the tooling and we had all of the dashboards and everyone instantly knew what they needed to do. But that's not always the case. And in those cases, we tried to figure out, okay, like what went wrong? Is there something in the process that needs fixing? It's like, did we get the right engineers on the right call at the right time? Did we get the right team? Did we even know something broke? Because like I said at the beginning, it's all fine and dandy if you have metrics and you can define alerts around those metrics. But if you don't have them, then you rely on customers. And that's a really bad look, right? We prefer not to get paged by customers. So if it was a, like a customer mailing in or, it's like calling or anything else, then we need to figure out, okay, is there something in our existing systems that we could have used to detect the problem that the customer is talking about? Because if we can't, it's gonna happen again, right? The basic assumption should be something that broke once will break twice, will break 3 times, will break 4 times, and we'll just kind of keep breaking. And if you don't have anything that detects that, then you're just going to keep repeating the same pattern over and over again. And I was going to say that's a code by Einstein, but I think that's not actually code by Einstein. So it's not insanity. Either way, that's kind of how we try to do incident management at Cloudflare. I hope it's kind of helpful for some of you to maybe review your own processes and implement some of the things that we talked about. But I'm more than happy to answer some questions now.
Thank you, Tom. Interesting stuff. Are there any questions? Yep.
Also, you wanted the microphone.
Do this. Yes. Now it works.
Okay, Tom. What is the incident that deserve a blog post-mortem?
I mean, we are a blogging company, right? We're a blogging company that just happens to have a CDN. Most of the time, it's the ones that we've deemed interesting in one way or another, right? Like it's either going to be it was super interesting or it was hyper visible. Like we had an incident last year in June or July where we basically killed 50% of our traffic. It wasn't a super interesting problem. Like at the end of the day, it was just a misordered firewall, misordered routing policy term that meant that we weren't advertising prefixes that we were supposed to. That's not hyper interesting, right? From like, I think everyone here that has an operational background has done that at least once, probably more than once. So it's like from that aspect, not super interesting, but it was hyper visible. So at that point, it behooves us to talk about this publicly, be honest about it, kind of crawl through the dust a bit to make sure that customers understand we have a process for this and we're trying to make sure that it doesn't happen again. That's one aspect. And then the other one is, well, that's kind of neat. Like, that's not supposed to break that way. And then we talk about it because I think it's a benefit to the entire community that we talk about interesting problems because, we all go through the same shit. So.
Antonio, are there any online questions? Nope.
No.
Okay, it's you and then Will and Daniel.
Hi, Tim Mattenberg, DKIX. You have gone through some detail that you kept the status page out of your own network, which is perfectly reasonable. I would be interested in how is the information on that status page fed? Is that kind of tied with your incident report internally, or does somebody need to do that manually? Is that part of a manual process?
It's both. So we have certain alerts configured that will automatically post a status page. So, like for example, the first one I can think of is if our API availability goes below 80%, we instantly automatically create an incident. Incident gets spun up, and in that process of the incident spin up, the status page also automatically gets created. The thing is, we can do that for hyper-specific cases where we can automate this, but because our fleet is now so many different pieces of software that we offer as a service, it's really, really hard to automate that. So for those aspects, it's our customer support folks They will, like we'll tell them, hey, please, status page, this is the wording, and then they'll put it up. So it's a mix of both.
Yeah, cool. Thanks.
Okay. So.
Will from a small ISP called Citis in Switzerland. I'm wondering, you're like a fairly decently big company. Would you have any suggestion for a company that's still an ISP with 20 employees to how we could deal with that? Because it's rough to get full-time picket and like on call 24/7 and so on.
Yeah, I can fully empathize. I used to not always run a large network like this with a lot of coworkers. I think the best suggestion I can give is be kind to yourself. Sometimes, like, we're sometimes hyper vigilant, which means that we start alerting on metrics that we probably shouldn't really be alerting on yet. But it's that customer anxiety, right? It's like if we don't look at this, then the customer might mail in. Just so be kind to yourself and make sure that if you do have a on-call rotation and if you do have incidents, that you're doing this within like intervals that are reasonable, right? Where you can say, well, 5-minute outage, yeah, it's gonna suck, but it's a 5-minute outage, right?
Yeah.
So yeah, be kind to yourself.
Thank you.
Daniel.
Hi, my name is Daniel Kramberg. I'm the first and current employee of the RIPE NCC, speaking only for myself. Thank you very much for this presentation. I would really personally like much more of this happening. So I like the style, I like the openness. My question is, how do you justify that sort of inside the company? I'm quite sure there might have been some people who say, well, we shouldn't be talking about our mistakes. How do you deal with that?
Frankly, never came up. So
okay,
it's
so then my follow-up question, I tricked you. Then my follow-up question is, why don't other ISPs do this? Because what I get from some of the engineers is we're never allowed to speak about this stuff. How do you create a culture that is different? Because my big example is the airline industry. They got forced into this, and my fear is that we might be forced into this stuff as well if we don't do it ourselves. So. Any ideas?
100% correct. Is you can bring the horse to water, but you can't make it drink. Yeah. So, yeah, as a suggestion, I think it just from an engineering perspective, us as engineers, we need to go to leadership and go, look, this is important. This helps. It's good for our reputation within the industry to openly and honestly talk about the shit that we fuck up. That's really important. And if we don't do this, the European Commission is going to make us do it. And them regulating us, it's already bad enough with the stuff that Rudolph talked about. I'd also not like to get, it's like European Commission mandated incident reports because they're going to be dreadful.
Yeah.
So well, better do it ourselves.
Here. And by the way, I like your speed test. And anybody who hasn't looked at the Cloudflare speed test, do so. It's the best one.
Thank you. I'll let the team know. For those of you trying to look for it now, it's speed.cloudflare.com.
Cool. We still have 5 minutes for questions. So please.
Okay, Ties de Kok, RPKI team at RIPE NCC. Just had to mention that again. You talked about going over the incidents with other people. You guys also go over alerts to refine that. And could you maybe elaborate on how you guys handle that?
So alerts is something that is handled on a per team basis, right? So we do have an SRE team, but most of the stuff that we push in our network is owned by the engineering team that built and wrote that thing. They're also responsible for alerting and observability in their own software suites. So that's something that we keep within the teams themselves, because for those aspects, they're the SMEs, right? Like they're the ones that know, well, this is important and this isn't. It's not super helpful, I think, for other engineering teams to then kind of come in as like an outsider to just kind of go, it's like, oh yeah, but it's like, you should be alerting on that. That's not super helpful, but we do encourage teams to, regularly prune alerts or regularly prune metrics as well, because there is such a thing as too much data. So we make sure that the teams are aware that it's perfectly fine to do that, and to kind of redefine alerts that are trigger happy, not trigger happy, things like that. So it's something, it's a culture more than it is a process.
Yeah, agree with that. Thanks.
Okay, please. It's your turn.
Hi, Trey. Just a quick question. I forget the name of the tool that you referred to that was helping the incident commanders sort of cut through all the different. Yeah, what was this?
There we go.
One, the
Respect
robot
tables.
one. Respect tables.
Yes.
Is there any part of that that's generalizable enough to be open sourceable? Because it sounded really cool. Maybe that's a dumb question.
No, possibly the problem is that a lot of that are tight integrations with APIs that are either internal or semi-public, so it's kind of difficult.
Well, I hope you don't mind. I may borrow the idea somewhere.
Go for it, please.
Please.
Keep my soul Glamper Digital. Under the EU's new NIS2, which is coming into force in 2024, and I believe Cloudflare would be covered under this as a DNS service provider.
We already
How
are.
are you updating your processes to comply with the reporting requirements for incidents under NIS2?
We're already covered by NIS in Germany and the UK for DNS specifically.
Okay, but specifically, what changes are you making as a result of NIS2 versus 1?
As far as I know, there's no changes that we are required to make from the DNS outline. So we need to report to the, I think for us is the Portuguese regulator. So, you know, whenever we have an outage, we report it to the Portuguese regulator.
Okay,
and that's the closest I'd like to go to NIS2 for mental health reasons more than anything else.
Entirely understandable. I was just looking at it this morning and dreading.
All right. If there are no more questions, Tom, thank you very much. Where is Giovanni? Oh, here you are. Giovanni Mura, assessing e-government DNS resilience. Let's hear it.
Just a second. All right. Can you folks hear me? Can you hear me? Yeah. Yeah, all right, thanks. So yeah, good afternoon, everybody. My name is Giovanni, and I'm gonna be presenting this work here. Okay, I'm gonna stay away from that. With colleagues from the University of Twente and the National Cybersecurity Center here in the Netherlands. And I'm a data scientist with SIDN Labs, which is a research team at SIDN, which is a DNS registry. And I'm also assistant professor at TU Delft, a university here in Holland, 20 kilometers from here, which is those Delft Blue China comes from, it's from there. So just before I start, I'm more in here. Some of you may have known Ricardo. He was a colleague at Twente when I did my PhD, and he unfortunately passed away last March. And he was also a colleague at SIDN Labs, and he was a RIPE ambassador in Brazil, and he attended this conference before, so I'm more for him. All right, a little bit of the context before I dive into research. This is a paper we did. So before I published the paper, the National Cybersecurity Center here in the Netherlands had commissioned SIDN Labs to do a study on the Dutch government eGov domain names and their resilience, their infrastructure, what they use for DNS for eGov. So that became the Dino project, and we teamed up with colleagues at the University of Twente to do this research. So this paper in particular is an extension of this project because the Dutch government just needed to know how the Dutch eGov behaves. And I took this quote from this philosopher from Mythbusters. He says, if it's worth doing it, it's worth overdoing it. So what we did, we not only got the Dutch eGov domain names, we got other eGov domain from other countries, and the idea is to compare them. Because governments increasingly are using more the internet to communicate with citizens. This is the definition of eGov, and eGov provide crucial services. In Holland here, you can do taxes, apply for benefits, driver's license, a bunch of stuff. Here's a screenshot of my local government here in Delft, where I live. It's a bunch of things you can do online with this eGov. And what happens when eGov breaks, right? There was This happens in the US. Some Russian hackers shut down dozens of state governments there in the US, Kentucky, Colorado, and if that was offline during the DDoS attack, people could not access the eGov services. So that became a problem for those people. And since eGov is fully dependent on the internet, and the internet is fully dependent on the DNS, we have an issue here. And I found this beautiful haiku, this form of Japanese poetry that says, I'm going to read it out loud. It's like, it's not the DNS. There's no way it's the DNS. It was the DNS, and it's always the DNS. So when there's a problem. So we're going to look now for the back end of eGov domain names from different countries and compare them. Because DNS has been designed for resilience. There's a bunch of ways you can replicate servers in that, and with Anycast, a bunch of other features. But deploy these things are increasingly complex, and they're not exactly cheap. And configuration errors may even go unnoticed because you just need one server to operate actually correctly. And then if a resolver can reach that, you're never going to notice until system breaks, obviously. So the question we want to answer in this paper is like, if the eGov domain DNS servers, I mean authoritative servers, are configured following the best practices for robustness, if they're redundant enough. And what we do to measure that is to use internet measurements. So our contribution is to analyze the eDNS, eGov DNS infrastructure for 4 different countries. All right, is it? All right, thanks. So what we do, we measure the eGov DNS infrastructure, yeah, it's better now. For 4 different countries, we use active measurements. We compare them because we need to know how they compare to each other, and they provide some suggestions for improvement. And why we choose this 4 here, like we have the Netherlands, Switzerland, Sweden, and the US. Because it's very hard actually to get eGov domain names. Nobody makes this information available. So for the Netherlands, most of the Dutch eGov domains are registered under .nl, but we actually had to get the National Cybersecurity Center to give us a list of those domain names. And in Switzerland and Sweden is the same. We had contacts that help us to give these domain names because we wouldn't know. And the US, luckily, they published the .gov list. So you can just, it's open information, just go there and download it. Wish you could have done more, but it's not easy to get. So this is the data sets we have. We have these 4 countries here. This is the number of second level domains we're going to be looking into per country. So the Netherlands has a population with 600 domain names in a population of 17 million people. Sweden, roughly the same number of domains with 10 million people. Switzerland, roughly 4,000, but only 8.7 million. I suspect it's because of the language that they have many languages there, 3 official languages, I think 4 even. Some like the train company has 3 domains because we've one in German, one in French, other in Italian. So maybe it's because of that. And the United States, because it has a large population, almost 8,000. And I'm only looking at second level domain here. But when I was doing those slides, it looked to me like the scores you're having in this Winter Olympic Games, because you have all the skiing. This is the countries that are traditional on this sport. So the first thing you're going to be looking at here, the measurements that we did, is to evaluate the sort of single points of failure where you don't put all your eggs in your basket. So we're going to look into different aspects of that, different types of baskets. The first one you're going to be measuring is using DNS providers, the usage of single or multiple DNS providers. So how you measure that? So we have here a domain, let's say example.nl, and this domain has 2 DNS servers, authoritative DNS servers, a.example.nl, b.example.com. Each of them have their own IPv4 address, and they're used by a certain autonomous system. What we measure is the number of autonomous systems for the particular domain name that announce this IP address. So in this case, we have 2 DNS providers for this particular domain, meaning if one goes down, the other one can take out the traffic and respond to DNS queries. Users can still reach their eGov services. So this is the table to summarize that. Here, again, we have the second level domains for each country and the responsives that we got. And 42% for the Netherlands, 41% for Sweden, 43% for Switzerland, 82% for the US. For IPv4, they use a single DNS provider, which I mean, but you gotta remember these domains are very dissimilar. Some are from local government. Maybe they don't consider themselves very important to have the redundancy at this level. Maybe are not. Maybe some are not. But again, like I think 80% for .gov domains have a single DNS provider may be a little risky. I mean, it's not up to me to evaluate that. They should make their own decision. And you can say, well, but this is a bogus metric. I'll put everything in the cloud. And the German company called Haribo, we probably can find this in the Netherlands as well. It's a very popular brand here. You can find the supermarkets. They made their own candy for cloud providers. You can see here. But even cloud occasions, they fail as well. There was a Dyn attack, the classic DNS attack against Dyn. We used Mirai botnet 2016. Route 53 failed in 2019 as well. Amazon.com doesn't use AWS for DNS. They use UltraDNS and Dyn. And we saw Cloudflare doesn't use their own thing for the status page. They use Google. So it's not your practice to put all your eggs in your basket. And if you look who are these DNS providers per country, here we have a table which shows per country, like which are the top 5 DNS providers per country. And many of these companies you wouldn't know unless you live in those countries. And the reason is that the DNS providing market for eGov is dominated by local companies. And this is because you have like small towns and local governments, they say, well, we need a new website for the servers. Which registrar should I use? Oh, you should use the hosting provider that I saw in the advertisement. So it's like, it's a really local decision. This is at least for the Netherlands. I talked to the people there. So like here I have TransitPay. Oh, let me go back. TransitPay, that's a local company that's very well known here in the country. In the US, we have the big ones that we know, GoDaddy, Cloudflare. So I think it comes from this tradition on that. So the conclusion is most DNS providers are local. The only exception here is number 3 in Sweden, that's Microsoft. All right, now we're moving to a different metric. We're gonna look at the number of DNS servers that each domain has. So if you have a domain here, example.nl, NS records define how many in DNS, how many servers they have, and here we have 2, which is like a.example.nl and b.example.nl. Yeah, in this case, we only found 6 .gov domain names that had a single NS record. That's against the original RFC 1034. It's 35 years old, older than a bunch of people here, by the way. Not older than me, unfortunately. But we notified .gov. There are 3 domains there. They fixed it. 3 of them, actually, they moved to, I think 3 of them, they moved to Cloudflare, by the way. So they fixed it, but we didn't find any other zones. All right, other thing you're going to look into here, again, the number of BGP prefixes that announce those DNS servers. Example.nl has the servers, they have these IP addresses, but if you look at the BGP prefix, if they're coming from the same prefix, that means they're not topologically diverse. They share parts of the same infrastructure, either routing or some part of infrastructure. And that's not a good recommendation for eGov service if this eGov is popular enough, is important enough. So now these results, if you have one prefix, you have the same location. You have a false sense of security. If there's a large DDoS that takes down the prefix, your entire eGov website is going to be down. So what we have here in this figure is a CDF that shows the number of prefixes that announce the eGov domains. So what I'm showing here, there's like 40% of the Swiss, no, roughly 1/3 of the Switzerland eGov domains, they have a single prefix for the DNS provider. So 1/3 of the domains, they use only one prefix. For the rest, for the other 3 countries, they're having 20%. And most of the people here are having 2, which is a good thing. It's better, 2 is better than 1. And some have even like 4 or even more. So this is the number of prefixes. Another thing you're going to be looking into is the number of top-level domains that are used in the NS records. So the DNS servers. So for example, here, this one has .nl and .com as top-level domains for their own DNS servers. So if something were to happen to .com or .nl, you still would be able to resolve this domain. So it's the TLDs for the NS records, not the domains themselves, by the way. So here we have 2, and we see that Switzerland, for example, here, the red color here, again, the CDF, here we are showing the percentage of the domains that they're using, how many TLDs they use for their NS records. Most eGov domains from Switzerland, they use only one TLD, their own. And we're going to get which one it is, but it's .ch. The Netherlands, on the other hand, is the most diverse. They use like 40% we're using here, and the others come in between. So it's a good general policy to diversify things if you can. I mean, it doesn't mean that the still these are going to break, but I mean, it's just a principle that you should apply to your eGov services if you consider them important. So yeah, only one TLD is not a really good policy. And if you look into what TLDs these eGov domains per country are using, you're going to see the number one here obviously is their own thing. And the United States, even though it's .gov, .com, it's also very closely associated with the US. The first number one is always their own. And then you have like alternating between .net and .com, probably for historical reasons as well. And .eu is not very popular, and .be as well. It's Belgium neighboring country here. But that's, so the conclusion is typically they have their own country for eGov, and then they have .com and .net. Now we're going to be looking to extra features that can improve the resilience of DNS. One of those things is IP Anycast. We had a paper talk about how Anycast reacts to denial of service attacks. This presentation, all those links are in red, are clickable. You can download later. They're going to point to the paper or PDFs or references. And the second thing you're going to be looking into is the time to live fields for DNS. We had 2 papers on that as well, and RFC 9199 summarizes them for operators. So here we have IP Anycast and Unicast. With Unicast, what you typically have is one prefix is being announced from one location. In this case here in Amsterdam, this prefix is here being announced. So all traffic gets to the single location. If there's a DDoS, all the traffic goes there and you get overwhelmed. With Anycast, you have the same prefixes being announced from, in this case, 4 different locations on different continents. So traffic gets distributed among these locations. Some maybe remain online while others go down. So we measure using some internet census and iGrady. And by the way, Rafael is also in the room. He's a co-author in this paper. We found that in the US, 58% of the Gov domain names, they have Anycast. And this derives from which DNS providers they use. And not so good, very few suites domain names are actually doing eGov. Like mostly they don't do Anycast. And Sweden and the Netherlands have 20% of the servers for eGov, they use Anycast. So it's ironic because like in Switzerland, I think it's the GDP per capita is the highest among all those countries, but they're still in eGov a little bit lagging behind. And I think they could do a little bit better job here. And these are the ones that don't have any Anycast. And most of them, they have 2, so I don't know what they have. So time to live. I think we talked before about time to live here, but like DNS time to live, it's a field that controls how long a record is going to remain cache, and is the last resource you have against a large outage. If the authoritative server goes down, if the record is still in the cache of your local resolver, and you'll be able to retrieve that thing, you're going to be able to resolve your eGov domain and do your interaction with the government. And the current recommendations, this is not set in stone. This is like pure recommendation based on studies we did that uses at least a couple of hours TTL for your domains. So what we did to look into the eGov domains, measure their TTLs, and we plot here. We're going to show here just the median average value per country. And we see here, the Netherlands is kind of doing well here. Like this is all in sequence. But Sweden and Switzerland, they're using 1 hour for the authoritative servers, and the same for the IP addresses of these authoritative servers. So all these folks here in red, light red, probably can increase a little bit. The United States is doing a little bit better here. So even if there's a DNS problem, you need to propagate a couple of hours, 1 hour. It's not, you need someone to go there and fix it. So at least we can have like 2 hours TTL, like at least for people to fix the stuff. That would be helpful for them. So for now, I only talked about web, but we're going to web and doing things. But we also look into this paper about eGov email DNS. I mean, email is also important. Here in this paper, the paper that we did, we also measured the backends of eGov email. We are in Rotterdam. There was a very famous philosopher here in Priest and Erasmus of Rotterdam. Here you have a picture of him writing some email. It's like some centuries ago, but he was very popular. And what we did, we got an example.nl, and to look into their DNS backends for mail, we got first the MX, which are DNS records that define their mail servers. Then they get authoritative servers for the MX domains, and then the A records, and then we follow from that on A records. And what we found, I'm going to show only the first most popular provider for all the countries. It doesn't matter which one it is. It's not your local provider that's the most popular here. Government really loves, they really love Microsoft. They love Outlook. I think this governments look for stability, and maybe it's a generation thing, like they're older people in the government. They don't want to use Slack or, Discord or whatever tools young people are using nowadays. So they want their own Outlook thing. And it's like 20% here in Switzerland, 41% in the US, and the Netherlands and Sweden is roughly 39, a little under than 40. So the DNS backends for email is mostly from Microsoft, from Outlook for all the countries, but the DNS backends for web, for the array records and stuff, it's mostly local market. So that's a very interesting thing. So if you want more details, there are more things in the paper. You can download here the paper if you're more interested in this part of the backend. And the recommendations we have for eGov in general, if you consider that particular eGov website you have, it's important, you should provide some diversity into that. You should add more DNS providers, more DNS records, prefixes in those that come along. You can use different TLDs for your authoritative servers, and deploy anycast for more robust services, and reconsider some low TTL values that you have. Maybe you can increase them. And here's an example of an infrastructure that lasts for a long time, built for last. This is Segovia, a Roman aqueduct in Spain. And I think this is, we reached the conclusions then. We found that many eGov domains are not following the recommendations for robust services. This creates unnecessary risk, and they should re-evaluate themselves to see if they can replicate, if they consider their services should be critical. And we hope those findings can help and prompt their operators to improve their resilience and redundancy. And again, another example of robust infrastructure. And if you're interested, here's the paper. You can download it here. And a side thing, yesterday's we were talking about in the time session, like the NTP session, we have a free NTS servers here in the Netherlands. You can check time.nl if you're interested. I forgot to say that in the mic. But anyway, that's the conclusions. And if there are any questions, I'll be happy to take.
Please.
Hi, Lars Lehmann from NetNode. You talk about the recommendations. I can probably drag out twice as many recommendations as there are DNS operators in this room. Yeah. Which ones are you talking about?
It's exactly the ones I evaluated, like don't use a single provider.
Yeah, but where does it come from?
So for ourselves.
My point is that there is not a single set of recommendations.
That's right.
You cannot talk about the recommendations. You can talk about some recommendations say that, and you can explain why this is good and why this is bad for different situations. But this sounds like there is a single set of recommendations that everyone should operate from, and there isn't.
I agree.
So that's.
But I think I said that. I think this is not set in stone. It's like, yeah.
Please.
I agree.
So thanks.
That's a good topic for the BCOP document.
There is one on the way.
Oh.
So this is our own recommendations. This particular one here is like, this is our own thing, like suggestions, let's say, if you want to.
Okay. Please.
I'm sorry, this may be an inappropriate or silly question, but
say who you are first.
Oh, I'm sorry, Trade Arley. I speak for myself, but Accenture Security and First.org Board of Directors. So DNS considered as infrastructure. There's been a fair number of talks about DNS here. It seems like there have been issues with the protocol for a very long time. Just as a sort of thought experiment, and a question to you. In 2039, after we've dealt with the end of the Unix epoch, do you think we'll still be using the DNS protocol?
That's a very good question. I actually don't know the answer because DNS was never originally designed to last for so long, and still there. And IPv6 was designed to replace IPv4. It still hasn't happened. So again, I have no idea. I mean,
So then I'll just last follow up. There is that old saying that any sufficiently advanced technology is indistinguishable from magic. At some point, we're just going to get locked into tech debt.
That's right.
Okay, any more questions? Yeah, you have an online question?
Oh, yes. From Carsten Schiffner. Did you encounter any problems in internet services that eventually got rooted in low TTLS? Internet services means services on the internet, web, mail, etc.
I can't remember here by heart. We did a study, other studies on that, and I don't remember like outages specifically now, but I remember we found the TTLs, for example, for the authoritative service from the .EY, the Uruguayan TLDs, that they were using very low TTL, and then what happened is that they were getting massive latencies for the services because all the queries had to go to the authoritative service before they come back. And we notified them, they changed, and then the latency was reduced to 90%. So not only protects against outages, but also improves performance because you can get response for caching, and nothing beats caching in DNS.
All right. Any more questions? It doesn't look like people is running to the mics. Okay, thank you.
Thank you
very much. This concludes this session. Please remember to rate the presentations so we as a program committee know which ones you did like, and vote for the new PC members. Thank you very much.
It's a feature, not a bug.
Also in the other.
They're all arriving now.
Okay, hello everybody. So I'm not Daniel Karenberg. This is not the session about AI. My name is Mia Kühlewind, and we're talking about the IETF. And I think this is just like a very good continuation of the day because we talked a lot about the IETF and RFCs and whatever. So hopefully we can help you here with some additional information, and maybe you also have some questions later on that we would be able to answer, hopefully. So let's see. So we have a whole hour. So I was begging some other people from IETF leadership to sit here next to me so I don't have to stand here for an hour just on my own. So we have Warren Kumari here, who is one of the Ops AD. We have Eric Wank. Sorry, we're joking about the French pronunciation earlier. You want to say your name again yourself?
Eric Wank.
Thank you. Who's one of the INT ADs. And then Jari Akko, who is not on leadership anymore, but he used to march and then he escaped. But we are nicely keeping him with us for this session at least. So that's us.
Apparently, I'm the opt AD.
Oh, that's entirely. But good that you noticed. Was it me? No. Now everybody's awake at least. Okay, so what we do today is we have prepared like a whole bunch of slides, but we will try to go through them kind of quickly. There's a lot more information on the slides than we will talk about, but that also gives you the chance to just read through the slides of your own and look at the pointers and figure out more information if needed. So, but what I would like to do is that I present you some slides about kind of what the IETF is and what we're doing in case you don't know anything about the IETF. And then we talk about some trends and hot topic, and we just selected some of them depending on like who's here on the stage and was able to say something. And then we also talk a little bit about new work and new groups because we thought that might be interesting for you. And at the end, we have a part about how to participate because that's a question that comes up very often. And what I would like to do a little bit is to also give you a chance to speak up. So we will try to have some breakpoints in between where we have a few minutes for any kind of questions. But you know, feel free to jump to the queue. I might not take you immediately, but we have some breakpoints there. And hopefully, if we get through this in a timely fashion with your help, we also have some time for further discussion at the end and more questions from your side. Sounds good? Okay, let's move on. Okay, so what's the IETF? This is kind of the overall diagram, and you don't need to know all the acronyms. The one reason why I'm bringing this up is because I'm the chair of the IAB, the Internet Architecture Board, and a lot of people don't even know what the Internet Architecture Board is. So I wanted to explain this in like 2 sentences. Effectively, we have 2 parts, or like the part that is kind of in this red box, that's kind of the part that is doing the technical work, right? We have like the different technical areas. Each area has at least one, or actually at least 2 area directors. Some of them have 3. Then we have all the working group, which are part of a specific area. And then the group of all the area directors is called the IESG, the Internet Engineering Steering Group. And this is one of our leadership groups. So the IESG is responsible for maintaining or managing those groups, and also everything that is related to like keep those groups productive about our meetings and these kind of things. And then there's a second leadership group, which is the Internet Architecture Board. And this is a group of 13 experts. And as the name says, we have the oversight over the architecture, which sounds really exciting. But what we try to do besides some kind of management tasks as well is that we are kind of trying to have a little bit the big picture, right? We look at like what's done in the IETF, where are maybe topics that are not well covered, where are gaps, and then we try to start a discussion in the community and figure out, you know, if there's more work we need to do. We help getting new work into the IETF and these kind of things. So, and then there's a few more groups that care about the organization of the IETF. For example, we have the LSC board, which is more on the financial side of things. We have the trust. We have the RFC editor function, which is that is responsible for actually getting the RFCs out and doing some editing at the very end and these kind of things. And of course, there's the IRTF. So that is the Internet Research Task Force, which is also organized in research groups. And that has been very valuable for us to bring in researchers and keep the connection between research and the engineering community and have some exchange and discussion there. Okay, I personally like numbers, so I brought this one slide, and I hope you actually also kind of, maybe this is kind of surprising for you, but it gives you kind of a feeling about what kind of community the IETF is. So if we look at kind of at the unique email addresses that we see over a year, and in this case, it's just the example for 2022, we see like more than 6,000 unique email addresses that are participating in the IETF in some form in a year, that might be registered for a meeting or on a mailing list or in drafts or these kind of things. So that's kind of what we see as our community. If we look only at the meetings, it's more like 3,000 to 4,000 people who registered over a year. So you see, like for a single meeting, we usually have like 1,000 to 2,000 people, whatever, depending on how many are remote and so on. So you see that there's like a certain number of people probably who come to every meeting, and then there's a certain number of people who come to like one of the meetings and whatever. But a lot of things are happening on mailing list anyway, so we have much broader community than what you see at the meetings. Maybe also just to give you a feeling about the IETF, in that year we had like 126 working groups, and currently it's probably around the same. It's always around 120, 130 working groups or whatever. Because we're kind of rechartering a couple of groups every year, and we close a couple of groups every year. Yeah, that's the IETF in numbers. And then, like, I don't want to tell you like all the details about our process or the IETF or whatever, but I really want to mention one thing, which is the hackathon. So before every IETF meeting, the weekend before every IETF meeting, we actually have a hackathon, and I think that has been a big success. The hackathon is also doesn't have a registration fee or whatever, so we also get sometimes local people just coming to the hackathon and not to the IETF meeting, engaging with us. So that is really a place where people meet, talk together, hack stuff, do interrupt testings and these kind of things. And it's something that people enjoy. It's something that brings in people from other communities, and that's something where we actually get some work done, which is really important.
And can you spot one RIPE participants on the table there?
Jen, you're in the picture. Yeah. There might be more actually. So this is the first breakpoint, because that's everything I tell you about how the IETF works. But if you have questions, I can try to take them, or I can hand over quickly to other people here if they want to add something.
Yeah, I just wanted to add that the hackathon is my favorite piece, and it's quite liked by many other people as well. And one of the reasons for that is that whenever something big is being worked on, there's usually a large number of implementations around a particular table, and they're working on things together, interrupting and so on. So for instance, when we worked on TLS and Quick, it was like 15 to 20 different implementations, and a lot of the ideas actually come during this phase.
Okay, so now we go into the exciting part, which is talking about actual topics and hot trends here. And Warren is taking over from here for now.
Are you going to do the slides?
No,
Yeah. Oh, I get the clicker. Woohoo! Seems dangerous. And a laser. So hi all. It does actually say. No, it doesn't. Oh, it says over there. You see, nobody showed me. I don't want to see that. Nobody told me I can't point this. So hi all, I'm Warren Kamari. I'm one of the Ops and Management ADs. And Rob Wilton, who does more of the management side, is on the Meet Echo. So if you have any management questions, we can ask him. So I will mostly be talking about DNS and some IPv6 stuff, but there's a bunch of other interesting work happening in the Ops area and the rest of the IETF as well. But for now, I'll mostly focus on DNS because I'm a little weird and I really love DNS. Unfortunately though, DNS doesn't love me. Whenever I try and troubleshoot any sort of DNS problem, the only error I get is serve fail. And initially I was kind of offended, but it turns out this happens to everyone. Fairly much anytime anything goes wrong in the DNS, you get serve fail. So we decided that might be a problem. And there's now RFC 8914, which helps solve this. So now when you have any sort of failure, in addition to getting the failure message, or sometimes actual successful queries, you can also get an annotated error message. So an example of this is error code 7. It used to be if a DNSSEC signature expired, you'd just get serve fail and nobody would know why. Now you can get the serve fail, but you can also get something actually specifically telling you signatures have expired, and this should make troubleshooting a lot easier. Another one which I personally think is really cool is a error code specifically for censored. So in a bunch of jurisdictions, DNS operators are required to do some sort of DNS filtering. The problem with this is when an operator filters something, the users often have no idea why, and they call up and they shout at you. Right? You're like, why are you blocking my access to the site? With this new extended DNS error thing, you can actually return a DNS message, or you can annotate the DNS message saying censored. So instead of the customers calling up and shouting at you, they can call up and shout at the government instead. So we published this document a while ago, but we're now seeing some fairly good deployment. For example, Cloudflare has deployed a lot of this, and most of the open source implementations are also working on implementations. Another interesting thing in the DNS area is the alt-TLD document, which is now with the RFC editor. And basically what this does is it sets aside or reserves a string .alt for any sort of name resolution system that is not the DNS. So we've been seeing a bunch of name resolution systems that are kind of blockchain based. Another example is like the Tor resolution system, which uses .onion as a name. There's also the GNU naming system. All of these non-DNS systems have a bit of a problem in that there's no easy or useful way for them to be able to get a string to use to identify themselves under that. As an example, the GNU naming system, GNS, is going to be naming itself gns.alt. And so that provides a way to sort of prevent collisions with the DNS and also a space for them to be able to use. Ooh, the clicker works. An interesting V6 thing is one of the reasons that we keep hearing that people aren't deploying V6, especially in the enterprise, is that there's a bunch of features in V4 which just don't exist in V6, or at least don't exist in V6 the way they're deploying it. One of these is the fact that operations people and security people often use IPv4 DHCP logs for all sorts of things. So the CEO calls up and screaming that he can't print. Standard thing is the help desk has a look in the DHCP logs to find his printer, try and ping it, and then suggest, you know, it would work better if he plugged it in and turned it on. This works well in V4, but if you're using Slack, there is no DHCP logs. So what this proposal does is it provides a way for a host or sort of client, when it uses Slack, to be able to just inform the DHCP server, hey, I'm using this address. And now, you know, there'll be DHCP logs for Slack type addresses. It doesn't actually ask the DHCP server for an address. It just says, hey, I'm using this. You should note that and stick it in your log and possibly in your DHCP database as well. So I don't want to take up all the time, so I will hand it over to Eric, who's going to talk about some other DHCP and V6 stuff, and then some other area bits.
And if you don't mind, I will be standing. I hate to be speaking, being seated. So regarding IPv6, we all know that having Slack is not always very nice. We've got scalability issues, specifically if you are getting more and more V6 addresses by using temporary address. So we end up with a big neighbor discovery table. So the idea behind the first draft is basically to use DHCP prefix delegation. So we can delegate a /64 or maybe a later another size to one host, meaning we don't do any more burning the neighbor discovery cache on the router there. We also use DHCP PD and other mechanisms rather than NDP. So we are maybe most probably increasing the security of everything as well as scalability. Kind of cool. As we all know, a big difference between V4 and V6 is not only the size of the addresses, but it's also about extension headers, basically in your domain, in your area, and in 6man, which is basically mine as well, 6man for 6 maintenance. It's basically the operational consideration, pretty much linked to what Anna has explained earlier this afternoon, but also a proposal to limit the amount of extension and the option inside. right? You know, for instance, an option and hop by hop, they can have option inside of those extension headers. So they want to limit this somehow. I'm not really sure whether it's a good idea or not, by the way, on this one. I mean, but again, the IETF is not only one voice, there's the voice of many people, right? And part of our goal to be here today is to also say, hey, you are operators, you are a different community than the IETF, we need your feedback. So if you have ideas regarding this hop by hop or extension headers in real life, please come and say, right? And we will explain to you later how we can do it. Another quick one was, you know, the way we select the source address in IPv6 is interesting, right? We typically prefer IPv6 to IPv4, except for ULA. If you have both a ULA and IPv4 address, IPv4 will be preferred. Okay, this is kind of nothing broken really, but it's surprising. That's one of the drafts is there. And we have many, many drafts, including one from student of mine and Anna and others, doing measurement about what's happening with extension headers, because there are multiple ways of to skin this cat. Another one is not about v6, but it's in int area. It's Madinas. You most probably know that IEEE, but the implementation as well in iOS and Android, we changed the MAC address. Of course, if you change the MAC address, and some scenarios maybe you will keep changing the MAC address during a connection. So associate to an access point, right now you keep the MAC address, but there are some plans maybe to change the MAC address every hour or so. Pretty much like the v6 temporary addresses. For privacy, of course, that's cool. So this working group is basically looking and analyzing what's the current state regarding IEEE, but also what the vendors are doing and what could be the impact. And we've got a good relationship with IEEE there, and of course with the people, the vendors handling this. Could be interesting for you.
Yeah, actually, before you hand over to Yari, this is the next break point here. So this is again your chance to go to the mic and ask some questions about IPv6 and DNS, because that was already coming up earlier today. Did you all have a coffee in the break?
There will also be time at the end as well, which we hope there'll be a bunch of questions then, because otherwise it's going to be a short session.
Yes, go ahead.
Hi, Samuel Stefan. Just you asked for questions, but basically this feels like a presentation, like a one-way communication by you telling us about stuff that is being worked on or has already happened. Like, I wouldn't know where to start with. Like, I wouldn't know what questions to ask, because it feels like it's just information. So what is actually what do you want to get out of this book?
So no, fair enough. I think what we wanted to do is sort of seed the room with some topics that people can shout at us about. So this is more just, here's some stuff. What are your views? Like, we have some more slides further on about if you want to participate, how. But a fair bit of this is just, we want feedback. We know that building and deploying protocols without feedback from the people who are actually going to like designing and implementing protocols that people are going to deploy them doesn't end well. So
thanks.
Yeah, we really want to get feedback, right? So I was expecting personally people jumping to the mic when we were talking about some DNS and privacy and encryption, but it looks like everyone like it. I would be surprised, but.
And I was expecting people to jump up to the mic when you started talking about v6, because that's where all the problems are. DNS is just fine.
So just to say it again, so the slides are kind of crowded because we wanted to give you a lot of pointers for things that might be interesting for you. And especially we will all be around the whole week. So I mean, if you come to questions later on, we will still be around. And feel free to talk to us. And now there's a real question.
Let me try not to fall over the mic. This is Trey again. If that's enough of an introduction, I'll repeat my question from earlier, which is, are we still going to be using DNS in 2039?
So you are
sorry, I was out of the room. I had to take a call, so I missed some of the controversial bits.
There's no controversy, it's all good. So you asked that earlier, and I was like, that sounds like probably, and then I added up, and that's like only 17 years away, I think. And so, yeah, I think we will still be using the DNS, but I think that over time, the importance of DNS names might decrease, right? This might be more of a discussion for places like ICANN. But these days, when somebody wants to access Facebook, they don't open their browser and type in www.facebook.com and push enter. They take this thingy out of their phone and they click on the, like, I think it's like a funny blue icon. I don't use Facebook, but no, as an example. So I think that there is a shift to things like apps instead of domains. And also I think, often people don't actually type in domain names anymore. They search for something and click on the first link. So DNS might end up being more of like a underlying infrastructure thingy and less of a thing where people care about the names. But I think the protocol itself probably will carry on for at least 17 years. But by that point, I'll have retired, I hope, in minutes.
I would like to give a high-level answer. So far, the internet is around for whatever, 40 years, and I didn't see one single protocol disappear. So probably will still be around. But the good thing about, you have one? Okay, we'll talk later. But I think the good thing about the internet is it's not fixed on these protocols, right? We have seen new protocols coming up, and also the existing protocols are constantly changing. And I think that's actually why the internet's still around and why it's still working. Okay, but let's move on this point. So, Yard.
Sorry, I wasn't fast enough. Leslie Daigle. I actually would like Trey to ask a different question. And that is, do you want to be running that in 2029? And if not, what do you want to do? Because the point really is that it's not that the IETF is here to tell the RIPE community what the IETF is doing, or that the RIPE community should go to the IETF and tell the IETF what to do, but come play.
I mean, this is also an important point. The IETF is not in charge of deploying these protocols. It's like the operators, and everybody, like after the IETF process, makes a decision what's successful and what's not. We're just trying to provide building blocks and trying to evolve things and keep going.
Yeah, if it was so simple, right? Everyone would be running IPv6 only since 1997, and IPv4 will be stuck in the somewhere, which is not the case.
All right, so next topic, there's a request to have something which is not like, ready-made presentation of things that already happened or specifications that have been written. This is about a topic like that. So an area where we haven't done everything that we could perhaps do. So ongoing work and your cooperation here and elsewhere is very much appreciated. So environmental impacts of the internet. Vesna made a great talk yesterday urging for immediate action and continuous improvements and so on. And that's, of course, all great. And that's what we should be doing. But we have also been thinking about this topic at the IETF and IAB. IAB held a workshop that Vesna mentioned yesterday. There's pointer here. You can find all the other pointers through that. There's tons of research papers and so on. So go read that. But we also have a question, and the question is, what can standards organizations, IETF in this case, do to help this situation? And the answer isn't really super obvious, at least not in all cases, because there typically isn't a situation where you can just add this bit or remove this bit, and after that the world will be much better place. Usually some cooperation is needed with the ops community and other players. Just to illustrate this, if you think about stuff, what kinds of things we could be doing to help the situation? We could increase understanding. We could perhaps help some other fields. We could make the internet better for the rest of the society. You can do your conference calls and never travel again. Or we could make improvements in the technology itself, like using less energy, for instance, or produce less CO2. And what could we do for those kinds of improvements? Lots of different things. Protocol design, as a protocol designer, I always like to think about stuff in terms of protocols, but unfortunately in the world, there's many other things, manufacturing processes, the energy sources that you use, implementations of your systems as products, architectures, usage patterns of users, or business usage patterns. And so the question is like, are there some relationship between these different pieces? So there's lots of moving pieces on the table. And one obvious one, of course, is that like protocols and implementations go together. One good example of this is, of course, you always have to implement something in order for that to be even deployed. But sometimes the connection is a little bit more interesting. In the wireless communications field that I work with, there was a change between 4G and 5G where some administrative messages got, the rules on when to send them got relaxed. And as a result of that, implementations could be written to sleep more often or for a longer period of time. That had a huge impact on energy consumption of these networks. So power amplifiers and so were able to be turned off as a result of that. So that's an example, kinds of things where you have to actually work together with different parties. Another example is that if you want to understand the world better, like why is my network using so much energy, like who's guilty here? Maybe you need some metrics and measurement protocols and so on. Or if you want to use some green energy sources, but you don't have them always available, but you have multiple sites around the world, maybe you can shift load. Well, if some information sharing opportunity mechanisms were in place, you could perhaps optimize that better. And also there could be negative connections if you made a not well-designed change in the routing protocols. You might cause jitter, for instance, which would impact the quality of, say, people's video calls, and therefore that might not be good for people avoiding travel and so forth. So it's a complicated picture overall, but the picture that does arise is that we actually have to work together, that these different pieces need to be connected to each other, and different communities need to be talking to each other, the researchers to standardizers and implementation people to protocol people and so on. And so you might ask, like, what could we do? Like, give me some concrete examples. There's obviously tons of work here, very difficult problems also, but also some shorter term opportunities. Obviously improvements in metrics and measurements, like just doing measurements in the research community, but also perhaps improving some of the things that where we have standardized metric definitions and so on. We could have intra-domain information sharing. You might ask why intra-domain and not across the whole internet? Well, there's some very thorny issues about trusting information, like, I'm really green, come to me type of thing, that you might not be able to solve immediately. Opportunities to sleep or slow down, we had some examples of that. Data format choices. There's a lot of protocols that run on textual information or sort of verbose message lengths. Some newer protocols, generally have been maybe more binary or compact, HTTP2 instead of HTTP1, and some IoT protocols and so forth. So that's a trend that should continue for new things. And also my personal favorite, proof of work crypto assets. Maybe we shouldn't be doing all that. That's one easy place where to save. So that's it for the technical part of this. I just wanted to point people to where can you contribute and discuss. Of course, in all of these forums in RIPE, I'm sure you guys will have some discussions going forward. At the IETF, of course, this is not entirely new. So we've been working on kinds of things that help the environment, at least indirectly, already many years. But the general IETF discussion on this topic happens on a list called E-Impact. And of course, when there's a specific work, let's say in some routing extension thing or whatever, then that happens in the specific working groups. And I think this could be a moment for discussion. I should say, your ideas here for these short-term opportunities. What are we missing, or should we take off something from that list?
Yeah, and as nobody's running to the mic line, I take the opportunity to actually talk again about the IAB, because sometimes it's hard to explain what the IAB does. And this is a topic that we've been working on. We had a workshop on it. And it's not that the IAB is taking full credit, because it actually comes out of the community. There's a lot of activity. But what we try to do in the IAB is to help to organize the work and figure out what are the pieces that actually can then go into standardization, where we can actually do protocol work or things, document things that are useful.
But you were inviting many people to this workshop. Do you remember who was coming and which kind of industry?
We had obviously some protocol people from IETF, sort of traditional people who'd be doing protocol definitions and RFCs, but also a lot of people. I mean, there's some people from the RIPE community, some people from the research community, quite many in fact. Some people that traditionally don't come to the RIPEs of the world or the IETFs of the world, that would be sort of more on the implementation side of things. And yeah, a pretty good cross-section. We had, I don't know, 70 plus people, all virtual, of course, because we wouldn't travel for saving energy.
Maybe also a general word, like the IAB is organizing usually like 1 or 2 workshops a year on different topics, and it's very easy to participate. We call this invitation only because we want to have people in the room who actually have an opinion. So what we request people to do is send us a short position paper, like a 1-page or whatever, to make sure that people are actually will contribute to the workshop. And then we usually invite everybody who sends us a paper, right? So if you're interested in any of these topics, watch out for these workshops. And then these days we usually have online workshops, so it's very easy to participate, and it's a good opportunity for us to get broader input from different communities as well. Okay, we were hoping to get more input from you on these topics because we need more input, but let me move on for now.
For instance, I was expecting discussion about not using text format in protocols, right? I mean, I was using Netcat on port 25 to debug my SMTP connection because it's easy. Now we want to use CBOR or other, so everything which is binary. So expanding basically the cost of operation, in my opinion.
Okay, we keep that for the end of the discussion. And
yeah,
I move
we can
on.
have that fight in the parking lot.
You'll be condensed and we'll be the large one.
Okay, we have one more topic that I would like to talk about a little bit because I'm a transport person, and I don't think I have to explain Quick anymore because you heard about this already. So I can just like add to the point made earlier today that Quick was kind of, the standardization was finished about 2 years ago, and it's actually taking up. So when we published the RFC, there were a couple of companies who were ready to deploy, and so we quickly ran up to, depending on like which study you look at, like 30–40% of like traffic is Quick these days, depending on which network and who's measuring and whatever, right? But what we do see is that there's more uptake coming, so the number will increase over time. Now it's much slower because, like, from my understanding, it's also the CDNs, for example, they also try to roll out things step by step because they don't want to overroll their network with like this new kind of traffic. So I think it's increasing, but it's going at a speed that might be manageable, hopefully. And the other interesting part is that the work isn't done about Quick. So Quick is one of the 2 transfer protocols that we actively maintain in the IETF. And I would say there's more energy in the Quick working group than in maintaining TCP at this point of time. And there are more opportunities because it's a new protocol. It's much easier to extend. So there's still a lot of work going on, for example, for multipass Quick and these kind of things. So if you're interested in Quick, just check out the Quick working group about what's going on there. It's much less active than it was in the initial phase because we had like so many people coming with different requirements, but there's still good activity there. Talking about securing transfer protocols, there's also a lot of activity still in the TLS working group. And one of the topics that might have come to your ear is encrypting the client hello. So, I mean, what we're trying to do is really try to make protocols as secure as possible. We know this has implications, but the discussion is still ongoing, and this is also something where input from management side and operations side is useful. But I think the goal to actually try to make the internet as secure as possible is the right goal. It's just a question about how to deploy it and do it in a way that we can all work on this goal together. And of course, there's like the last point here is there's also some post-quantum work going on in TLS. So we try to look forward and try to keep the internet secure on that basis. Another thing about security, or rather privacy, or in this specific case, IP address privacy, is that we see a couple of things in the IETF where people use proxy setups, basically. 2 examples are here: Oblivious HTTP and the mask working group. Both of them have, like, in some sense, a similar concept. Instead of directly having the client contacting the server, you have like some kind of relay proxy in between. And the main purpose really is kind of hiding your IP address from the server. So when a client connects to the server, you cannot identify a client reoccurring just based on the IP address. And at the same time, you also want to hide the content and what you're accessing from the proxy. So also the proxy doesn't have the full picture. So basically, these are two approaches for kind of a little bit the same problem, but different use cases effectively. So Oblivious HTTP is specific for HTTP. Specifically for use cases where you don't log in with a user account to a website, because that really identifies you, right? But there are many, many other things like collecting measurement information or whatever, where the user can be anonymous. And then the mask working group is kind of more generalizing this, where mask is used to kind of set up a quick-based tunnel to a proxy and then forward traffic to something else. And this is, for example, if you have heard about Apple's private relay, they use actually the mask protocol there. Sorry, or actually it's just an extension to HTTP Connect. And they have an approach where they have actually two proxies to really ensure only one proxy can see the IP address and only one proxy can see which kind of content server you're connecting, and none of the entities in the chain has like the full picture. Yeah, but at the same time, we are also looking into how kind of can these services be discovered and detected in order to make them usable and on a broader way. So we also think a little bit about deployment, but I have to admit, like, some of these approaches are not fully aligned with different deployment scenarios, but the discussion is ongoing. And in this vein, we had an IAB workshop last year about how to work on management techniques in encrypted networks. And the goal here really was to work together and make the internet more secure, ensure we have encryption everywhere for the traffic, for the user, but also in network operations. It was a very interesting workshop, same procedure. People sent us their position papers based on their interest in their position papers. We generated an agenda, and then we had like 3 online sessions to have a discussion. I think it was around 35 participants. And so there was kind of one bucket of input we got was like how to actually manage encrypted traffic. Usually it's kind of machine learning approach trying to identify traffic. But then there was also a lot of things about deployment considerations, or also papers talking about incentives, right? If you want to cooperate have a collaboration between the application and the network, exchange information to kind of do performance enhancements or whatever, what are actually the incentives for both of the players to do that? What's the right information to provide? And then also what's the kind of mechanisms to do that? And I think the big takeaway from the workshop was, and it's my takeaway, but I think there was also broad agreement between the participants, is there's no silver bullet. There's not like one easy mechanism to like kill or work on all the use cases. It really depends on what exactly you want, what's the kind of information, how much trust is needed, right? Is this information sensitive? Do you only want to give it to somebody in your access network where you actually already have a certain level of trust, or is it information you can broadcast a little bit broader and then different actors can act on it or not or whatever? So it's really, you have to define what the problem is, you have to figure out what's the information, and then you have to work on a solution. And unfortunately, that's a lot of work. But we got a couple of nice proposals, so please look at the papers. And I think we're doing some progress there. And the other lessons learned was also that we have to keep educating people, because it's, there is not one simple solution. We have to go and explain what's the problem, how to solve this, what are the challenges, and we have to do this for all kinds of players, including regulators. And so there's a lot of work to do here. Okay, that's the next breakpoint. Still no questions.
Same question as for the other workshop. Yeah, DNS works, right? So were there operators in this workshop? If you remember. Sorry.
I don't know by heart. I'm pretty sure there were, but I didn't learn the participant list by heart. It was definitely a diverse group of people providing input, which was really nice to see.
That's important.
Yeah. I mean, there is a workshop report, and the workshop report has a full list of participants and all the papers and all these kinds of in there. Okay. Okay. I hand over to Eric. Yeah.
Thank you. Maybe I'll move there as well, so I won't be. Yeah. So new work. It's basically works that we are a square 1 or square 2, or even in some case, square 0 or -1. So we have a lot of things to do. And this is basically where any other input it will have the most impact. So for instance, the first one, top left, TVR, as we say. It all started because we have stars. I mean, all of us, all engineers in this room, right? We have stars in our eyes. So it was about starting. The original idea was, hey, you know all these satellite constellation, like Starlinks and the others? Obviously, if they want to run some routing protocol among those satellites, I mean, they don't really need to send hellos because they know exactly at which time a satellite will become visible, will disappear, and on which direction. And satellites are pretty much clockwork. So all started from this. Yeah, we should have a designing protocol at the IETF for this kind of satellite constellation, where we know exactly the adjacency are coming up and down. And then immediately, and this is what I like in this group, they say, yeah, but there are many, many other use of this potential protocol. It's not yet a protocol, it will just be a long time from now. But what about, I know my POP is going on maintenance. Rather than relying on OSPF, ISIS, LO failing, what about if I advertising that at this specific point of time, I will be shutting down this POP? Or what if, for the green reason, I know that all the day or whatever, I got 2 links in parallel. Hey, maybe I could shut down the laser on one to consume less power. But again, let's warn the other side and let's do the rerouting before. Don't be disruptive. So you see an idea which is really, really dreaming. I mean, yeah, routing protocol in the sky or in the space. Yeah, sure, fun. Completely disconnected from reality. We end up with something which is connected to the reality. We will in the future. Anyway, interesting work, I think. 2 other ones that are interesting is CATS. I mean, something which is pretty nice at the IETF are the acronyms. You cannot imagine the amount of energy we spend finding the right names. This one was before, I forgot about the name. It was beginning. Whatever. Anyway, so it's basically the idea within an administrative domain, right? One single operator where we can identify based on the whatever information, what is the easiest egress of my network? Maybe I got multiple servers and I want to join the server which is less loaded or the server which is the best connectivity right now. And then we use traffic engineering, read tunnels, to connect the ingress of your administrative domain to the egress of the same domain, roughly. Top right. The other one is Mimi, which I love. I mean, is there any French-speaking people beside me in this room? Yeah, you know Mimi, it looks like a cute little thing, right? This cat is Mimi, means a cute little cat. So good link with the previous working group. Anyway, so Mimi, I mean, all of us are using, I guess, WhatsApp, Slack, Yahoo Messenger, or whatever. They don't interoperate, right? So on this one, Mimi will rely on MLS, message layer security, basically to interconnect all those systems. It could be really, really good, I think, for everyone. Skipping, yeah, the post-quantum is always nice, of course.
So we figured out the previous acronym was CAN, and we changed it because apparently a different SDO is using it already. So.
Yeah, a can of worm. Anyway, so now the buff. The buff are birds of feather like this one, but are way more interactive. Basically, when we do it at the IETF, it's basically to start to check whether an ID or problem statement exists. Is that a real problem? Is it a solvable problem? Is it within the IETF thing? And then we create a working group maybe later. And those both, I mean, the first one, BPF, which is basically, as you know, it's no more an acronym, but before it was meant for Berkeley Packet Filter. open source, vaguely related to networking, but they are coming to the IETF to be standardized. Because we want as well to expand the realm of what we are doing and standardizing. And our processes, I mean, they are not perfect. I mean, everyone which has handled IETF processes, they are heavy, we take long time, it takes 2 years, 3 years, 4 years to get something standardized, but the process works, okay? And if you allow me, there are some cases you can even file an appeal, just to wake up somebody in the room, but he's tapping on his laptop. Yeah, exactly, you, Sander, if you don't mind. So we got a process and we are extending it so to other people, so other stuff that are interesting. The other one is structured email. Email, of course, they can be structured, but if you're using MIME and HTML, but the point of this working group is to add data in the sense if you are getting a reservation for a plane or whatever, not only you get the text, hey, Mr. Eric, you are the wonderful customer, you are golden, blah, 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 but you get also data that can be processed on the same mail. Any questions on those groups?
So, but maybe just to explain a little bit more what a BOF is. So a BOF is usually a meeting that we hold before we form a working group to figure out if there's enough interest in the community, right? So the most important part is, I mean, there's a lot of discussion about, do we have a use case? Does it make sense? Is it the right community? But the most important question for a BOF is, are there enough people in this community who actually want to do the work, right? And this is a very nice example for BPF, because it's kind of a different community, but there's some overlap, and we figured out there are enough people. So that is currently chartering. And it's nice to see that this is happening. There's a question, that's great.
More of a comment, it's a mem from NetNode in Sweden on the MIMI thing. In Sweden, the government organization, a number of them has realized that they can't replace Skype for Business with Teams, so they're looking into other things. It will be a lot of open source, but it hasn't. But they have agreed between the providers of solutions and the government organizations that they will use Matrix as a system for video conferencing or whatever. So there is things going on. So maybe Mimi could be something that involves those people. So there is things going on, maybe not in the IETF, but doing similar things.
So the MIMI working group, I think this has been a long-standing topic, right? How do we get these applications to interop, or how can you get like people to move from one application to the other easily? And it's technically not easy. There's also a technical problem, but of course it depends on the companies. And the reason why we have a working group now is because of the Digital Market Act from the EU, right? So there is now some regulatory pressure to make that happen. And what we see in the IETF is that particularly the smaller application providers come to the IETF because they have a real interest, right? We didn't have necessarily the big players speaking up in the working group, but they are around and they're listening, and they have a huge number of interests as well, because it's not an easy problem, so we can provide them a solution. They don't speak up because it's also a very sensitive topic because of the regulation, right? But maybe I'm super optimistic about it, but like I think like if things will work out, then they will work out right now. So let's see.
Yeah, and in Sweden, it is actually the regulation that making the government organizations looking into other things. So it started out by the tax department, and they have like 50 other government organizations involved in this project right now. So
yeah, nice to see some movement there.
So Trey again, I'm gonna stop with all the companies and stuff, but I have done a lot of standards work around security standards. And that's sort of the hat that I wear. I'm sort of, so my example may not be exactly network operator specific, but if you'll bear with me, it pertains to, like, if you write a standard, it's often like, here's the problem statement, must, should, data format, you know, state machine, this kind of stuff. But like, it's sort of a different world. So there are two sort of problems that I want to throw out there and ask your approach to. One that's recently come to me is like, here's an open source machine learning model for doing something really, really cool. And we'd like to be able to standardize, we being some constituency. We'd like to be able to standardize this machine learning model. It would be beneficial to the whole community, you know, like how can we do this and maybe get an ITU identifier, et cetera. So that's one thing. And then sort of, I see it as a subset of the problem where if you know, like Snort or Yara or one of these tools, where it's often referred to like, oh yeah, no, you can put a Snort signature here, you can put a Yara signature here. There's no kind of versioning in that, but like certainly whatever that format, that standard is, has evolved over time, but it's a standard that's embodied in a specific reference implementation, but that's not really RFC stuff. So can you educate me or speculate? Thanks.
So, I mean, I'm not sure I understand the question correctly because there was no question, but let me tell you something.
So the question was, how do you standardize stuff that is hard to describe in text? That's really like code.
I think the answer is poorly. But I mean, we are trying to do some sort of related things. Like the BPF stuff is sort of related to that, right? This is taking a bunch of the stuff that's defined in the Linux source code and trying to standardize it. But yeah, there was another one, which is the Wireshark folk, I was trying to remember their actual name, wanted to standardize the PCAP protocol, or like the PCAP format, you know, like when you write a capture to disk. And we got some way down the road with that, but I think that they got sidetracked midway through. We never actually got around to finishing it. But I mean, there is certain things we do fairly well, but things which change very regularly, we're not particularly great at sort of keeping up with things that change fast. But we can often define like the format and a place that you can use that format to describe other things. Didn't really answer your question, but I faffled for a bit.
No, but so there is a lot of activities, not in the IETF necessarily, but around the IETF to try to kind of validate all the must and should in the text with the code, for example, right? Or generate code from the English description or whatever. These project assist, we have actually a new research group on that. So I'm happy to see this community also coming in the IETF and have a discussion with them. But I think there's also value about having it in English language, because that's how we can talk to each other, right? That's how we have the conversation, and that's how we document things for people to actually learn how to use and maintain these protocols. So there's like pros and cons about that, I guess. And Yari?
Yeah, I wanted to continue a little bit on this, like standardizing things that aren't easily described in words. I think if you look at any of these particular examples, whether it's BBF or AI or whatever, that you'll find that it's actually a complicated system. So there'll be some interfaces like here's an HTTP API, and here's you know, something else, and here's a format, and here's a validation thing that you have to follow these rules and so on. So those kinds of things are typically they're potential targets for standardization, but the actual code, or let's say a data set for AI model or the resulting model might not be. But I know there's a lot of action going on in the AI world where we you know, develop different data sets that go into the as the training data, have different models resulting from that, and others who refine it. So there's a lot of that going on, but that might not be a standard per se. It might be just a agreed thing that we will use this good data set from now on.
And I'll keep this short just because of questions. There are also sort of efforts that we're trying to figure out for things like Yang models, where, you know, it's a set of code which changes fairly quickly, a way to be more agile with that. But who was next at the mic? You're gonna have to fight them out yourselves.
Well, might be me. One thing you mentioned is work on TLS development, and especially encrypting the SNI supposed to make things more secure. Encrypted SNI would force me to move to a much less secure setup currently. I'm currently using SNI in a web hosting setup, web hosting on IPv6 only machines, and some people, for strange reasons, want to connect by IPv4, get to a reverse proxy in front, and let us SNI and hands over the transport TCP session to the backend machine that serves the requests. And that does TLS and the proxy sees only encrypted traffic. And if I get an encrypted SNI, I would have to move TLS termination to a reverse proxy. That's under my control and not under the control of my customer. So in my that would make the setup much less secure in my mind.
May I suggest to express your point on the TLS mailing list? I mean, all those mailing lists, I understand it. You need to do it to subscribe and blah, 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 just for one point, but it helps. It helps.
Okay.
I mean, definitely, and the discussion is still ongoing, but I don't think the end of the discussion will be to not encrypt something that you can encrypt. The end of the discussion is hopefully that we find a different solution for your problem and can strengthen encryption at the end.
Hello, Alexander Azimov from Yandex. I'm a bit afraid of the previous slide where BPF was mentioned. And I try to explain why. You already mentioned the TCP and the foundation of TCP stack, how it should work and so on, was very good described with the IETF community, and it's very useful. But on top of this foundation, there was a number of documents. Significant part of them are already outdated, and they are hardly related to what is implemented in the Linux kernel. So we have a kind of documentation how it should work, and the reality, the very different reality. I can't say that Linux kernel is very good documented. It's not. But the gap is very huge. And what I'm afraid is before we learn from the previous mistakes, because the situation of TCP documentation and what is implemented is kind of, it's not a mistake, of course. It's just what happened. I'm afraid that next approach, if we try to document a very dynamic space like BPF, will fail into the same problem.
And I think that's one of the reasons when you say that there is no real definition of BPF, right? And they are spread everywhere in the source code there, in the document there. There is not even a common version. And as you know, it's running over Windows now. There's an opportunity, I think, to get something which is mostly standardized and it could be interoperable somehow. But it will not be an easy task. And you forget to mention something else, which is the IPR and the license.
So I just want to reply to the TCP part. I mean, I would love a world where like all the standards would be up to date with the implementation. Even so, Linux is not the only TCP implementation. They might all differ a little bit, but it's actually a problem that you don't need solving because it's not a problem that like, you know, is a problem in deployment. And that's why we don't solve it, because if you can come to the IETF and you can work on TCP and you can update the documentation, but everybody who comes to the IETF has like different things, other things to do and more important things to evolve protocols further, right? So we have a few activities, like we just updated actually the TCP standard or proposed standard, how it's called, like I think last year or something, to make it more up to date and also to like document it in a more way that everything is together and nicely defined and whatever. But it was like a huge amount of effort for no real impact effectively. The impact is really, and I hope that's also what's happening with BPF, is you come, and for example, that happened, it was quick. You come at a point of time to the IETF in order to standardize something, because that's a point of time where you need a certain documentation in order to get broader deployment. And at that point of time, it's very useful. It would be nice to keep updating stuff, but that means we just need more people helping us with that, because we only have limited resources.
Okay, thank you for your comments. We'll see.
Just a quick.
So I just want to say we're at the end of time. I have like 2-3 more slides about participation that I will go through at the end if you want to learn about it. But I think we can also go a few minutes over and keep the discussion if you want.
So, I mean, where did Alexander get to? Did he escape? Anyway, I fully understand your concern. My understanding of the work that's going to happen in the BPF is more just describing the base parts and how extensions work. It's not, this is everything and you can only implement this. So I think it's more of a high level, these are the bits that fit together, the instruction set architecture, etc. So I think that it's a very valid concern, but I think that hopefully we're going to manage to not fall into that hole, I think.
You may want to Google IETF Charter BPF and you will see the proposed text that we will be working on. Comments are welcome. That's now.
Thanks. Jim Reed, an old fart who's been to far too many IETF and RIPE meetings. I've got two comments I'd like to make to the folks from the IETF that are here today. First thing is that I would ask you to do is not consider the lack of feedback and response you've had from this particular session or to be discouraged about that. I think it's a very welcome initiative that you've started, and I hope to see more of this kind of thing where representatives of the IETF, for some definition of representatives, could come and present what the IETF is doing, what its mission is, what's the live topics and so on. In other operator fora, for example, NANOG and Apricot, I think the more of that kind of dialogue would be good. And I think it would also be good to try and do that as well in an IETF setting. For a lot of people, as we know, it's very difficult to come to a whole IETF meeting for a whole week. And for industry participants, particularly from the operator community, maybe if there was, say, a half-day session or something like that, for a discussion about these are the things that are going on in the IETF that may be of concern for your networks, so at least they could be kept informed about that, they could come to these things. You used to have something very similar for policy people in the government setting. I think it was ISOC that sponsored that. So there was an initiative like that that was done for a while, and I think it ended with all the COVID stuff came in. But if you could try to do something about kind of multi-stakeholder type engagement, I think it would be very, very helpful, and perhaps encourage more operators to come and take part in the IETF than they do at the moment.
So yeah, something we've actually wanted to do for a long time is co-locate an IETF and a RIPE, or an IETF and a NANOG or something. Scheduling it and getting like the meetings is really hard, but what we hope to do is have more interim meetings. So we have like an interim right after a RIPE, or an interim right.
A short-term thing might be better, but I think the idea of having to have these two meetings co-located, Warren, is just logistically impossible. I don't think it would ever be feasible.
We've tried for a long time. It's clear the logistics won't work.
Yeah, but having some mechanism where operators and others can come in and have a discussion with the IETF and be aware of what's going on would be good, because I don't think that message is actually getting out to the broader community. The other point I wanted to make was about some of the discussions and things that take place in the IETF working groups. Sometimes the working groups don't handle disagreements or conflicts very well. And obviously we've got this consensus-based model, but there have been one or two difficult issues, particularly around security considerations with TLS. The fact that we've got TLS 1.3, which disenfranchised a bunch of people that really had a need for certain things, the working group chose not to adopt those concerns or pay attention to them. So those guys buggered off and went somewhere else.
So yeah, but I want to interrupt you right here, right?
Yeah.
Not adopting something and not considering something is not the same, right? I think there has been discussion, there has been considerations, but there's like, we are a multi-stakeholder group, so there's input from many different people, and at the end we try to reach rough consensus, and that means not everybody has to agree, but like the majority.
I accept that, but there might be, as I suspect, we may well have with the questions that we made before about encrypted client hello, trying to accommodate two mutually exclusive positions is going to be incredibly difficult anywhere, but it'd be even harder to do that in an IETF setting where we've got this basis of rough consensus, and that sometimes the consensus might be more rough than it should be.
Yeah, I mean, I think I would like to make this point again, because I think that earlier, I hope that we don't have to make a decision between more security or less security, right? It's like hopefully always more security. It's just a question about how can we actually achieve this goal in a way that is manageable for all stakeholders here.
Okay. And I mean, another very quick note on that, you know, there is the rough consensus, but if people aren't showing up and expressing themselves loudly and clearly, sometimes the like message doesn't get heard. So I don't really know how to say that other than like, please come participate more and make the message louder and better heard.
Okay,
no matter
but
what
I think there have been cases where people have tried
to
do that,
I know,
gone away
I know.
because they thought they weren't getting heard.
I would like to interrupt because I would actually like, I think this is a good opportunity to go through the last couple of slides. Can I make you wait a few more minutes, Jen?
It's time for others to
Thank you for staying there patiently. So we also had this part about how to participate in the IETF, right? And I mean, like you can come to a meeting because I think it's very informative to actually figure out how things are going, what's happening there. But that's not where the main part of our work is happening. The main part of our work is happening on mailing lists, and you can contribute there. And there are many other ways to contribute. And for example, one very, very helpful thing is if you review documents and you provide feedback either directly to the authors or openly on the mailing list, even better if you want to do that. But any kind of review is extremely valuable, and this can be review about, is the document actually understandable and readable, or also technical, or kind of a broader input, or any kind of other discussion you want to post on the mailing list. Another thing we mentioned already very briefly was the hackathon, right? Writing code, trying to interrupt, figuring out if the protocols we try to write down in English language is actually implementable and understandable by everybody. Absolutely valuable, more valuable than coming to every meeting. But of course, you can also come to the meeting. I really, really recommend this. You don't have to come to every meeting, but coming to a meeting once or a few times really gives you an impression about kind of what kind of discussioning happening there. You also get to know some of the key people. You get a better understanding of where the people come from, how they interact. And it's the same like the RIPE community. We meet 3 times a year, so we know each other very well, kind of. And sometimes when you look from the outside, it's hard to understand what's going on in a specific point of time.
And just to add something, to attend a meeting, you need to pay. There is a fee, but there is also a fee waiver. So if you are on your own dime, you can attend the meeting for free. I should not say this for a budget, but you can.
So, and especially for the remote participation, there's also a fee, which is not the case for RIPE. We introduced this fee during the pandemic because that's one of our main income sources. But for remote participation, it's very easy to get a fee waiver. You just like fill the form and you get one. We don't even check, right? It's kind of your decision if you are eligible to it or not. Like if you can pay for it, please pay for it because we need the income. But if you can't, you can still participate. For in-person participation, we have a different thing, but it is also possible to get a waiver. But of course, we ask you like, how can you actually pay the hotel and the travel and everything and not paying the registration fee? So if you're local, for example, it's a good reason or whatever. So, but talk to us if that is actually the problem for you. Okay, I do have 3 more slides, so I will just run on. So we talked about this already, but why it's important for network operators to participate. So first of all, I think hopefully it will be also interesting for you to come there and understand what's going on. I mean, some of the working groups are really in the woods somewhere deep down in the details, but especially everything that is new work, that is BOF or whatever, this is kind of give you an understanding what's going on, and we try to present some of this here. But we also really need input from people who are deploying and running the protocols. Sometimes it's really hard to figure out in a certain deployment scenario what are the consequences, but we try to consider this. But we need the input because everybody is running their network in a different way. Everybody uses a different set of protocols, and this is like the beauty of the internet. But so it's really important that we get like diverse input from operators and everybody who's involved with the internet to understand what the implications are. And so, like, there's just a bunch of questions that you might ask yourself. Is this actually a real problem we're trying to work on? What are the requirements? Is there anything missing? Does it actually match the reality that you see in your network? So, to be short, we would really like to get your input, understanding what, is this operational relevant, but also kind of is it deployable and manageable in your network? And we really need everybody from this community to help us to improve the internet and make it work better and keep it running. And I think, this is a bunch of links if you want to look at this about, the IETF meetings, newcomer guide, also about how to author an RFC if you really want to write or draft, I have to say, if you want to write a draft, I recommend you the Markdown toolchain, and there's some additional tooling help there, and it's actually a few easy steps in the meantime, so hopefully it should be easy for everybody. And then I just want to point out quickly, there's the IETF webpage with like all the information you might need about the IETF, but there's also the data tracker, which is kind of our daily tool where we do all the work, where you see all the drafts, all the working group, and all this kind of information. So if you want to dive deep, then keep that in mind and maybe look at that. Yeah, and that was the part about the passive participation, and we are already over time, but if you have any questions, I'm happy to answer them. Jen.
I guess it's a sign that the AV wants to stop.
Jen doesn't
Merci.
need a mic.
I don't like two school of thoughts, right? One, mostly for some reason, security people think that we need to specify every single case. On the other hand, you don't have to over-specify everything. The idea of documenting something in RFC, at least in the most of the groups, I believe, is to ensure compatibility, right? You don't need to specify everything. A lot of things could be changing, and Linux kernel might do something which is not an RFC, if it does not break things, right? So I'm just commenting in general because we've discussed that exact problem in like 6 months, for example, many times, right? So I'm just saying that don't think that every possible behavior must be specified. And the second comment, because I think we should say it again, that thank you very much for coming here, right, and invite operational community. And I think people who have been listening for this and still do nothing could not complain 5 years later that vendors implement the protocols. It's not the way people like, right? You could have come and say something and change something and say your opinion, so don't complain later, right?
One last question.
More of a comment, during operator and having had some IETF involvement. You said something that actually prompted me to get up and comment, and that was about choosing between less security and more security. Security has actually multiple meanings, the word security. There is like obfuscation against eavesdroppers, and there's also a robust network operation. And what IETF has been doing in the last 5 years is take away all the tools that network operators need to find out what is happening in their network. Because now it's all encrypted packets going from somewhere to somewhere having gibberish. So a user calls me and says, something is not working. How am I supposed to help him? So please don't overdo that security thing.
Go ahead, Mia.
I just want to make a final
please
comment, but if you wanted to react to that first.
So yeah, I guess quickly. So hi, I'm Warren. I'm the Ops AD. And I mean, that's one of the things that we keep talking about in the operations side is that if everything ends up being encrypted, it's much harder to manage the network. And then you can't actually get the packets, and then sort of things are less reliable. So all I can really say is please carry on sort of trying to help push that so that we can make sure that the message gets heard. Like obviously we want encryption to keep users safe, but not at a cost of being able to actually, pass the traffic. So, we need more input and more help sort of making clear the bits where it works and where it doesn't work very well.
So, but I would like to not only invite you to provide input, I actually would like to invite you to work with us. Because I think we have an obligation to make the network, the internet more secure, and that introduces complexity. There is a trade-off, right? That is totally understand. But that also means we have to work on new mechanisms to help network management in a different way. And that's not an easy task, but that was the point I was trying to make as a takeaway from this workshop we had about this, is that there's a lot of more work before, and there's like a value point to criticize here, which is kind of, we're running in one direction and we're putting a cost on the operators that the operators now have to manage, but that's where we are. It's also not necessary choice of the IETF because it's those people deploying the protocols, right? So there's a bigger tussle here, but I think from here, we actually have to work together to figure out how to make an encrypted network, a secure network, manageable together. And I see this as a big opportunity because I think actually rather than trying to mangle with your packets, mangle with TCP options, interrupting the traffic, breaking eventually things, and relying on that the internet never changed, we now have an opportunity where hopefully the endpoints and the network can talk to each other and like negotiate something that is actually useful for both sides because they have the same interest in making the internet work better.
I wasn't actually not talking about complexity, more of fully intentionally taking away all visibility. That is not a byproduct of accidental adding more encryption. It's fully intentional.
Yeah, it's fully
And
intentional
these people,
to take.
This is what Jim said. If you have a consensus-based culture, and one of the sides is just not wanting to listen to the other side will eventually leave the room, and then the people remaining have all the consensus they want and can do whatever they want, like DNS over HTTP or something.
So I think
or
this
quick.
is also not
So
fully
yes, I'm
characterizing it this the right way, because it just because we came to a different conclusion doesn't mean we didn't listen, right?
Yeah, if you manage to get everybody who disagreed to leave the room, the rest will nicely agree. And
so
in some of the discussions
point,
I have left because I couldn't stand it any longer, that was the result.
So I've been through this discussion, right? I'm one of the proposers of the spin bit in Quick, which is like this one bit we got for manageability in there, and I stick there. And we got it, and it's not deploying, which is a different problem, or not widely deployed, right? But that means it's not neither of the sides that can enforce something here, because we have to work together in order to make this work at the end.
That is the idea.
That's how it should be. Like, I want to reinforce this because, like, you stand here on stage saying like, oh, we need your engagement and everything. A lot of us have been burned by the IETF, felt that we weren't taken seriously. Like Gert said, just I was involved in the IETF, Gert was involved in the IETF, many of us were, and we just gave up. So at that point, it becomes more of a question, what mandate does the IETF have in the operator community? And that's not a discussion to have now, but just keep repeating that we should be more engaged, and otherwise we will get whatever, if we don't get engaged, then we don't have to. We shouldn't complain about the outcomes. We have tried. So I'm like, the IETF has a very important role and does very important things, but things need to change to engage operators again.
And I think that that's kind of what we're trying to do with this. Like, we came along, like, this might not have been, especially towards the end, as successful as we hoped with that. But, you know, I think that this is attempting to do outreach again to try and mend some wounds. Or
so I also don't think this is like operators against the IETF, right? It's a different community in the IETF that is pushing these protocol proposals. And again, like, what we do in the IETF is we see if there's interest in deploying something, and if there's enough interest by multiple parties, we standardize it, right? But at the end, I think we also have to accept the rough consensus, move on, because by complaining, you will not change it. I'm sorry.
Sander and Gert, there is a drink later tonight. Let's talk together, basically, how we can improve the process, because obviously relying on those slides to get operators' involvement, review this and this and this, is too dry, it's not efficient in your mind. So it's true. Right? Yeah.
So, but I want to say one thing. One thing that changed is that we didn't acknowledge the things that are breaking, actually unintentionally, because the intention was to remove information to make it more secure, and that broke unintentionally a lot of stuff that wasn't also well documented, where we haven't been aware, right? So this is a lesson learned, that breaking things unintentionally is a bad thing. Like, if we want to break things, we should do it intentionally, which means we have to learn, we have to understand it before we start the standardization. So I think this is a big lesson learned, and I hope you come back and provide this input to us that we do need in the process. Okay, we are completely over time, and I'm so sorry, but I want to give the last word to Miriam.
Sorry, Jay. Yes, no, that was one of my points. I think we're over time. We need to have respect also the staff, the audio staff, and the MCC, and everybody else who wants to actually leave it for the evening. But I want to come back and say thanks for organizing this. I think this was a great initiative, and I hope to see something similar again. I want to add one more thing, because you're also saying come participate in the IETF. I would like to also turn it around and say we do also have mailing lists and working groups. For instance, an open source mailing working group that's meeting tomorrow, where you could possibly bring up the VPF discussion. I also would like to invite you to possibly from time to time maybe post something on the right mailing lists, you know, related to certain topics that are currently discussed, where you actually would like to get some feedback from the operators community, and then you would reach out to them. I know IETF work is happening at the IETF, and, you know, invite works happening at WIFE, but maybe that would be one way of collaborating a bit more, to also post things more on the right lists. and maybe even ask some specific questions where you would like to have input on. Thank you.
Okay, I will subscribe to more mailing list, yeah. No, thank you, everybody. So as I said, we will be around for the rest of the week. Feel free to talk to us, but there's many more IETF people around, so I'm pretty sure you'll find people to talk to. Thank you, everybody.